All right. Let's see. Well, welcome everyone. It's already 10:30 a.m. Eastern timing here. So thank you everyone for joining today for the Jupyterthon, Infosec Jupyterthon 2022 edition. This is the third year that we're doing this. So we're super excited to see everyone coming back at the end of the year and trying to first share their knowledge and be able to see what other ones are doing with Jupyter notebooks in the Infosec community. With me, we have Ian, Helen, and also Joyce to kick this off. We're all part of the community, so we're trying to support this effort, taking some of our time as well, and trying just to make this happen for everyone. And let's see, we have a couple of things that we wanted to share today as a housekeeping as part of this first session before the keynote. So let's just dive directly into that, and let's just make sure that. See, oh, there you go. And just for those that don't know me, so my name is Roberto Rodriguez. I go by Cyberwar Dog in the community, and I work for the Microsoft Security Research Organization. I love open source. I love dogs. Dogs first is second open source. And also I'm the founder of the OTR community. And this is a community that we put together to encourage the collaboration and also development of open source. So you can go to that open GitHub repository and you can see all the open source projects that I've been working on, along with other security researchers in the community. And a fun fact I would say about me from some open source is that there is a website called Infosec Well Done, which is actually backed by a GitHub repository where I'm sharing all the recipes that I have learned over the years, kind of living by myself as first. And then also there is other security researchers that have been sharing the recipes through that. So that's a project that if you want to contribute, the recipes are actually for things that I can cook right away, because I'm constantly doing research. So if I cook something, it has to be quick, right? So if you go to that site, it's something that I'm also supporting, and it's an open source project hosted in GitHub. And to talk about a little bit of who's actually joining this, this conference. And there has been over 500 people actually that joined this year. Last year, I think it was a similar number. So it's kind of cool to see people coming back, or new also people joining the community. And this is kind of like a way to, well, first we're actually showing this presentation slides with a Jupyter notebook. So for those that are new to Jupyter notebook, you can actually do that. And this is technically interactive code. So if I run this, it's going to be creating this visualization, for example. So just in case if you're trying to figure out what this is just being run on a Jupyter notebook. And this is kind of showing you from the industry, like who's actually joining us. And it seems to be like a multiple, I would say, like areas in the industry that are joining this presentation. The cool thing is that actually this year we have students. I think the last year we also had that, I would say, like option. And there were not too many, to be honest. And at least we are getting a few. And of course, you can see technology, the whole technology industry, I guess, is super interested on how to use Jupyter notebooks for InfoSec, right, in security. Jupyter notebooks is not new, right? Has been out there for at least now, I would say, almost more than a decade, if I'm not mistaken. But for security, this is still a new thing from my perspective. I think based on working in several organizations, I could see that that's still a new thing. So the goal of this conference is to be able to share how others are using Jupyter notebooks and some of the use cases, like why is that so useful, right? That's sometimes a question that we get from other researchers that don't know much about Jupyter notebooks. How do I even use that if I have all these other tools? And of course, the idea is not to replace a tool. The idea is to complement all the tools that you already have in place in your organization. So the idea here is to be able to share what else you can do if you had a Jupyter notebook, okay? And if we talk about the level of, I would say, how comfortable people are saying I'm a beginner, intermediate, or advanced. Once again, this is the third year that the majority, so over 50% of the attendees, all of them that actually register, right? Because some of them might have just seen the links to the live streams via our social media accounts. But we can see a lot of people that are still beginners in our industry. So keep that in mind. One, that this conference it's kind of sharing use cases from a beginner's perspective all the way to an advanced kind of level. And I want you to also see that if for next year you want to present something, you can see that the majority of the people attending this are actually beginners when it comes to Jupyter notebooks applied to cybersecurity, right? The other thing that it was very interesting to see was actually what people are expecting. So we just gather all the information, and this is some of the words that were said a lot through the explanation of what do they expect from this conference. And that's kind of cool to actually see, right? Because there are specific patterns, like for threat hunting, security, maybe Python is what it was used the most also, while explaining why you want to first attend this conference, and two, why do you even want to be part of this community, right? Workflows, informations. So there's a lot of stuff, right? Team. For example, I was surprised by some words, but it kind of makes sense. For example, there was a couple of them that as I was running this code, like some of the words that I could see in little were like everyday, team. So you can see that people want to understand how to actually use this on their day-to-day type of work, right? So super interesting data, and all of this, of course, is available in our website and also in our GitHub repository that is hosting this whole website. So I want to show you that in a little bit. And the last thing, before we jump to this other cool visualization, so a couple of things that everybody should keep in mind here. So this is going to be recorded. So when the live stream ends, the link is already public. So if you follow these aka.ms links, for example, and all of this is also on the website, you will be able to watch the whole presentation again right after this ends, and it's going to be in YouTube, let's say forever, right? The agenda is also in the Infosec Jupyterthon.com site, and I'm going to show you that in a little bit. All the times are in Eastern time, and the keynote starts at 10:45. We have presentations after that all the way to 6 p.m. on day 1 and day 2. In day 2, we're actually finishing the day with a speakers panel. So we're going to be inviting some of the speakers from today and tomorrow, and try to just gather a few of them together for like 30 to 45 minutes and try to answer any questions. So if you want to be able to just ask anything about Jupyter notebooks applied to cybersecurity, that will be the last session of day 2. We also have a Discord server. The invitation is there. Once again, all this is available in the site, so you can actually click on it in a second once I move to the website, and then we exit this presentation mode. And there is going to be a public channel called Jupyterthon, and I'm going to show you that also in a little bit, that you can actually use to ask any questions during the keynote, presentations, and also during the speakers panel. And social media, we're using the Jupyterthon Twitter account if you want to tag that account, and also using the Infosec Jupyterthon hashtag. All this information is going to be super useful through the whole 2 days. And just make sure that you bookmark the agenda, and you can see also the times for each specific presentation. Now, this is the one that I wanted to show you. So this is something that we decided to ask this year is, where are you joining us from? Just tell us the country. And I had to modify some of them because some people put cities rather than countries, and I have to Google each city and make sure that I understand exactly which country this was. And this allows us to create this little map, which is pretty cool because these numbers do not reflect the specific number of attendees. It reflects the number of kind of like countries that are grouped as I zoomed out from this map. So then if we start going deeper, we can see like some of the countries, for example, like in Europe, where people are joining us from. So pretty cool visualization that is also available in the website. We have from South America, Colombia, Ecuador, Peru, Brazil, for example. So pretty cool to see Argentina as well joining us today and tomorrow. And of course, because of the time, we know that people will probably join us later by just going to the link and watching the live stream. So we're going to see that happening a lot. We have some people from Hawaii, for example, Dominican Republic, if I'm not mistaken. Yep, Dominican Republic, Mexico. Pretty cool stuff, right? Just to see where everybody is joining us. And this was all built by taking the data from the registrations, put some Python code on the top, as you can see here, and then simply visualize it in a Jupyter notebook, right? So saving the input, the output, and still be able to interact with this visualization. Okay, so it's 10:40 right now. We have 5 minutes before the keynote. So I'm going to jump directly to some of the how you can access all this information for Jupyterthon. So once again, this is the site, infosecjupyterthon.com. And this, this would allow you to go through all the information that I just talked about, the links for the live streams, if you want to share that with anyone else in the community. We also have the invite for the Discord server. If you are not there yet, you gotta click on it. It's going to actually take you to this Jupyter Open Thread Research server. And then on the top, when you join, it's actually going to show you only one channel. That's because there needs to be a CAPTCHA that you have to do, security, right? Kind of like feature so that we can stop anyone from just, joining as a bot. So on the left, you're going to see actually a Discord bot that is going to ask you if you want to go through the CAPTCHA, the security CAPTCHA. And once you do that, you have to go back to the Discord server. And we do have this code of conduct that you have to accept by clicking on the 100 emoji. And that will then open all the channels in the Discord server. And under the OTR conferences section is where you're going to see the Jupyterthon channel, where we are already seeing a couple of things. So you can actually start interacting with the community that is joining this conference, and you can start asking questions also in this channel. Once again, this is the website. On the left, you will be able to see the agenda, all the talks that are happening today. Really, really cool talks in these next 2 days. I'm super excited. There's a lot of topics that I really do not know yet. So this is going to be cool to learn something new in the next 2 days. Keep an eye on the times, and you can actually learn also about each speaker by clicking on each one. We also have some of the sessions are actually going to be in the site if the speakers share the Jupyter notebooks in advance. If not, once their talks are done, if they want to share their notebooks or slides, we're going to be adding them to this section. But these opening remarks, it's already there as a Jupyter notebook, so you can actually scroll through everything. And this site is going to contain all this information. As you can see, it's actually saving the interactive visualizations as well. So something also pretty cool to do with Jupyter and Jupyter books. What else? I think that should be it. Oh, yes. So one big thank you is for our community collaborators. So these are all the people that for this year decided to take some of their time outside of their busy schedules just to help us organize this. This is I would call it a community agnostic type of event. We have some people also in the previous year from other companies and from the community that join us. So this year we have all of these awesome collaborators, and thank you so much for your time. And this, would not be possible if it wasn't for you all. And make sure that, once again, keep an eye on the agenda, and we can then dive into the keynote since we are on time. So 10:45. I'm going to add Ian to this stream, and then also Ian will start sharing his screen. 1 second. And let's see. So 1 second. Let's see. Wait for Ian to show. There you go. So you can see
Okay, I need to unmute myself.
Yeah. So Ian is a principal software engineer at Microsoft. He's actually part of the same organization as me, the Microsoft Security Research Organization. And Ian is, in my opinion, one of the big supporters of open source that I see at Microsoft with Project Mystic Pi when it comes to security. It's actually one of the Python libraries that I've seen a lot of people talking about in the community. Every time I go, for example, to a couple of the channels in the Discord server for our open thread research community, I can see people asking questions, contributing. So this is a true community open source project, something that was built to enable security researchers around the world. And this also could not be possible without Ian. So Ian, thank you very much for your time today, and super excited to hear your keynote and also your other presentation later today. Thank you. Take it away, man.
Hey, thanks, Roberto. So good morning. I'm very privileged to be here. I mean, normally we like to try and find luminaries. It's a bit early in the morning for me to say that, from the Infosec Jupyter world to give keynotes. We couldn't find anyone for day one, so we have me. I'm very pleased to be able to talk a little bit, not so much about the internals of Mystic Pi. Some of you may have seen some of that in other presentations, but more about the journey that we took to get to where we are today, and the kind of interesting beginnings. So click on the right screen. So Mystic Pi is an open source Python library, as Roberto said. It's Infosec tools for Jupyter notebooks. A lot of it can be used in other sort of Python apps and scripts and stuff like that, but primarily designed for notebooks. And a little quote from one of my favorite authors, Lemony Snicket. What might seem to be a series of unfortunate events may in fact be the first steps of a journey. And what were our steps for our good or bad beginnings? So about 4 years ago, when Microsoft Sentinel was still kind of in the planning stage, we pitched notebooks as a great way to give different options to analysts, hunters, to investigate, security data, something outside the normal realm of like SOC tools. And a little bit to our surprise, they accepted it. That was a great idea. But of course, then we had to create some notebooks that showcased this. And the results, well, they were kind of ambitious and innovative, but we'll show a couple of examples. There were what I call a very low signal to code ratio, kind of a bit intimidating to look at, and also for people to kind of emulate or replicate. So some examples now. Here is the, this is not even just the authentication. This is just getting a couple of the authentication, the workspace ID and tenant ID. A lot of code. This is the beginning part of this is one of my kind of early period notebooks from doing some clustering. This is not anywhere near the whole code. This is just like the preamble. Here is another great big block of code where it's just trying to determine the IP address for a host, like querying different tables and doing different operations. And I'm not sure whether we can see at the bottom down here, like the result is just, you can see the ratio of code to result. And another big block of code just to produce a kind of pretty simple visualization. So the origin of Mystic Pi was to try to clean up some of these notebooks, to remove a lot of the code from the notebook and put them in a separate library. This also had the benefit of making a lot of this code more testable. It allowed us to reuse things, so we could build a visualization, reuse it in other notebooks more easily, and to have a more scope to create InfoSec specific functionality like visualizations and different types of data enrichment. And the final motivation is Mystic Pi depends on a lot of open source packages itself, like Pandas and Bokeh and NumPy, a bunch of things. So we felt it was, we wanted to give back to the community, both to the general open source community, but more specifically the Infosec community using notebooks. So this was back in 2018. This all kind of started. 2019, coming up to the 4th birthday of Mystic Pi. This was the email I got from like the so in Microsoft we have a kind of process for creating GitHub repos. It needs to go kind of through legal review and stuff like that. So we're not publishing kind of random stuff that's going to get Microsoft in trouble. So I still keep this email, which was a very special day for me. And then a couple of months later, we had the first version of Mystic Pi on PyPI. And as it says at the top, there's a newer version available, so don't install this one. If you do install it, you'll find there are only like a few modules, handful of modules that do things like extracting IOCs and a virus total lookup and a few things like that. So it was kind of pretty basic at that stage. I want to take us back, and Roberto said that all of this is going to be recorded. Also, last year's was recorded. It's still a big block of a video, like a whole day. But if you go through, like, I think it's maybe about 3 hours into the first day, you'll see John Lambert's keynote, which if you haven't seen, I'd really recommend you have a look. It's a great kind of motivational talk for the use of notebooks in InfoSec. And I want to steal one of his great kind of central metaphor, if you like, for the use of notebooks. And just kind of remind people about that. So we had this graph of like the time invested in notebooks against the amount of productivity, like the usefulness you get out of notebooks, and how people are, you liken this to a hike where you're going on a kind of fairly difficult trail, and where people got to along this trail. So the first thing is a lot of people would never get out of the parking lot at the trailhead. There's like, usually the first reaction to notebooks is people go, wow, is this possible? This is amazing. Quickly followed by, this is actually kind of quite difficult. There's a lot of like technology here. I'm not really a programmer. I don't have the time to invest in it. So a lot of people don't really make it beyond the parking lot onto the trail. It is a bit of a rocky trail with lots of ups and downs. And a bunch of people kind of, do take the plunge, go through it, but often get stuck early on. So, I can see how this works, but, this is less productive than my normal SOC tools. How do I get any real benefits out of it? Some people kind of make it to the first sort of plateau, start to see a bit of a nice view, they're using it, but not everything is kind of quite there. It's still not the full story. And a few people even make it where they're now very comfortable using notebooks and all the kind of technologies around it, but still they might be kind of isolated within an organization. Like, I can use it, but most of the people around me don't understand it, and I can't really use it in a kind of cooperative, collaborative way. So stealing John's great graphic, I'm going to impose some kind of Mystic Pi related stuff on it. So we found, particularly with like Sentinel users, that the majority of people early on were just firmly stuck in the parking lot, just didn't, compared to a lot of other stuff in the portal, notebooks were just a bit too much of a technological leap. We had a few people who made it into the early stages of the trail, and some people who kind of made a big use of it. But if you think about it, notebooks and kind of raw Python are a little bit like you're planning a difficult hike and you have all the raw materials to build your hiking gear. But you don't really want that. If you're on a difficult hike, you don't want to have to worry about creating your own backpacks and poles and stuff like that. So what could we do to kind of project people further up on the trail, to give them the equipment so that they could like concentrate on the hunting tasks they were involved in or investigations without having to worry about like making their own boots. So the beginning, like the very beginnings of Mystic Pi, was very like Sentinel specific. It was a lot of the components were quite Windows centric. We had a fairly limited set of data sources. And in the Sentinel environment, the online environment, it was hard to get going. Like as I said, a lot of people couldn't get out of the parking lot. So phase 2 was more about trying to correct some of these things. And that should have, yep. And this was like around about the sort of version 1 up to like late version 1 point something, nearly up to version 2. We did do a lot of things. So we added lots of additional data providers for Splunk, Microsoft Defender, Sumo Logic, and a few others. We broadened the support to make it more Linux friendly with Linux queries, and a lot of the things would now work with like Linux process trees and stuff like that. A lot of threat intel providers beyond VirusTotal, and some interesting Infosec related visualizations like timelines, process trees. It was at this point as well we nailed down a little bit the configuration file, so you didn't have to like have credentials and whatever configuration information in the notebook itself. And we also built this initialization function in Notebook, which allows you, it does a lot of the automated setup for typical notebook usage. It imports things, sets things up. And in the case of Sentinel, like the Azure Machine Learning environment, and as we're about to kind of preview the Azure Synapse environment, it does some extra sort of source to get things kind of going. So where were we on the journey in phase 2? So we built a lot of functionality, but it was often still bewildering. We were still kind of in the chasm, if you like. So if you were using Mystic Pi notebooks, you needed to know what a function was called or a class was called, where to import it from. You needed to know component-specific syntax, which differed between different components. And often to use something, you required some kind of preparation, like instantiating a class, maybe formatting or converting the data into a special way to use it. And often the output as well was in an unpredictable format. You know, it might be a data frame, it might be a tuple, a dictionary, and you didn't really know beforehand. So this wasn't doing a whole lot to get people out of the well that they were stuck in. I'll give you an example of that. So this was a code snippet from one of our mid-period notebooks, and it takes a list of IP addresses and just plots them on a map, plots the geolocation on a map. And let's just walk through this a little bit to explain what I mean by the kind of cognitive overload, like this, lots of things you had to kind of know. So if you were to construct this tiny bit of code, you first of all need to know where these things are, where to import them from, what they're called. You need to know that these classes can't be used directly, that you need to instantiate the classes to use them. You have to know the specific parameter name. In this case, the lookup IP has a special parameter to deal with lists and a different one to deal with a single IP. You also have to know that this function produces not just a list of geolocations, but it returns a tuple of like raw results and IP entities. And you only needed one of these in this code. And then finally, you needed to know, you create an instance of a Folium map, use this not particularly maybe intuitively named, but like slightly obscurely named add IP cluster method to add these things onto the map. And finally, to use utility method and display it. So that's a lot of stuff. I counted at least 11 items. There are probably more than that. You think, I just want to draw a map, and you've got to remember all of these things. Kind of, not surprising that many people, other than the very dedicated people, kind of stuck at this level. So the kind of next phase really was about what could we make that makes the ascent easier, this sort of journey of Jupyter notebooks easier when using Mystic Pi, excuse me. So we have two, I think, main audiences that we think about for Mystic Pi and notebooks. First is like ad hoc notebook creation. So you're doing an investigation or you're hunting and you're kind of building the notebook as your investigation tool as you go. And here we wanted to focus on allowing the analyst to themselves to focus on the job, like the investigation or the hunt, not on how to use the tools and all the complexities that come with those. The second audience is people writing reusable notebooks, like senior SOC engineers, SOC engineering, that kind of thing. And here again, the ability to bring in functionality with relatively minimal distraction, not having to every line have to look up documentation about how it's used, and importantly, to keep the blocks of code as succinct as possible. So do things in a couple of lines rather than 50 lines. So, as I said, phase 3 was all about getting out of the chasm. And these are the kind of the things that we took as our kind of guiding guidelines. So we wanted to simplify entry points. This was reduce the number of entry points and reduce the number of things that people needed to remember to bring into their notebook, and also to make the entry points more intuitive. So to have all of IP address functionality, have that grouped around an IP address class rather than just scattered randomly across the library. Second thing was to remove or at least simplify initialization steps to avoid instantiating classes. We use the init notebook function to automatically import things that you're likely to be using. Third area was aiming to simplify function behavior, so allow functions to take flexible input types, so not having to worry about whether it's a list or a single value or a data frame. Normalizing parameter names as much as possible. We're not quite there yet, but trying to regularize so that we don't have like weird, the parameter names don't differ between different kind of functions. And have predictable output. And we chose data frame as our kind of universal output format. And finally, built-in help. We've always had fairly good, I think, built-in help with trying to document the functions and classes as we go. So they're available in the Python online help. And over this period as well, we built, rather than when something goes wrong, you get like a typical Python stack trace. We have in notebooks these friendly exceptions, which give you like steps. Like I don't have an API key for something, and it will tell you about that and the steps you need to go and fix to take to correct those things, and usually links to documentation that will explain it a little bit more. So a couple of examples of like things that we implemented to make this stuff easy. So we took the decision very early on, like the very first early days of Mystic Pi, to treat pandas data frames as sort of a universal interchange format for bulk data. So the first thing was, why not add data-related processing and visualization as what's called pandas extension methods? So you can write a bit of code to wrap functions and make them appear as if they are pandas functions. So in this example here, I have like df, which is our data frame, and there's an extension, Mystic Pi plot, MP plot, invokes folio map. So this does the same thing as the example we saw a couple of slides ago. My data frame has a column with IPs in it called columns called destination, and we so in a single line of code we can use these to do something that previously took 20 lines and a lot more lines to think about. We also have sort of data processing analogs for this, is like an MP extension, which has things like IOC extraction and stuff like that. So if you have a bunch of data, you don't really need to do anything but type a dot after your data frame name in order to get to this functionality. The second example is something like we tend to think of everything in our work as like entity related. So something to do with an IP, who owns it, where does it come from, an account, what are its logon patterns, hosts, URLs, that kind of thing. So it seems natural to kind of group functionality around these things on entity classes that relate to these entities. And while we're at it, why not make the input parameters the same kind of format, the same signature, have the functions that are attached to these entities support this like multiple input types, make the output always predictable, data frame, of course. And while we're at that, we can add queries that may be related to a host, like host processes, add that to the host entity as well. And we wanted to let users add their own functions. They might have their own kind of preferred libraries or like local code. We wanted to make it easy to add those things as well so they become methods on these entities. And I have a session a little bit later on in the day where I'm going to explain how you can do that to add your own pivot function. So this is a bit more complex than the pandas extensions, and there's a bit of, I'm not sure it's dark magic. It uses a coding pattern called decorators, and decorators are things that wrap functions in other functionality. So here we've used, you don't really need to know this, but just to explain it. So we had like an original function that maybe like gets the location of an IP address. And we've written codes to wrap that function so that no matter what you send it a single IP address, a list of IP addresses, a data frame full of IP addresses. It will handle that and pass that on to the underlying function in the format that it's expecting. So if it's expecting just a single IP address and it gets a list, the wrapper will iterate, will call that function multiple times, gather all the results and send it back as a single block. We have a second wrapper which handles the output. So no matter what the function returns, it will put this into a data frame format, even if it's a single value. So you might see some of these things that just return a single row data frame from like an IP address or a URL. And then finally, once we have this like doubly wrapped function, we attach it to the entity that it belongs to. So for geolookup for an IP address, it's attached to the IP address. And then we have the functionality that we call mystic pivots. And to show you a little bit what they look like, the top cell is just a general initialization thing, importing Mystic Pi. And all of the entity classes have this pivots function, which just shows you what the lists what the different pivots are. So this is an example for IP address. It shows some risk IQ things, some virus total items, more generic things like geolocation, who is, and so forth. And you invoke them like the example in the bottom, where this is passed a list of IP addresses, and it returns the data frame with all of the locations in. Excuse me, my voice is a bit kind of croaky. Still a bit early in the morning for me in the Pacific Coast. Snowing as well today. So that was kind of where we are at the moment. There are still a bit more things in the future. So some of the things are, still quite hard to discover. They don't really fit into either the data frame or the pivot paradigms. I'm trying to think of some examples, but there are some areas of Mystic Pi that we still need to find a kind of convenient way to expose without having to worry about how do I find this thing. We still haven't really sorted out fully the whole consistent parameter names. Pivots helps a lot with that, but a lot of the native functions still might be used like group by as opposed to group underscore by, or that kind of variation. We'd like to try and sort that out. And we still have challenges with infrastructure, like people just getting going with notebooks. And it's difficult to imagine how we might be able to solve that in Mystic Pi itself, because you're kind of inside the infrastructure. But we're thinking about that. It could be just documentation, but there may be things in Mystic Pi that we can do to make that a little bit smoother. On the new rather than things we're going to correct, the new things we wanted to try and explore more, these are a couple of like main examples. I said everything in Mystic Pi understands data frames, like outputs pandas data frames or inputs pandas data frames. So it seems logical, and we already have implemented this, but we haven't really explored the possibilities of it fully, that you can tie a lot of those things together. One thing that outputs data frames is pipelined to another thing. So let's give an example. So like an IP address, you could imagine an IP address pipeline that does a whois lookup to find the ownership of the IP. It does a geolocation lookup, then does threat intel lookup, and then maybe just maybe correlates it with like recent logons from those IP addresses and perhaps displays them on a timeline. And this is the kind of thing you could build into a pipeline and just invoke as a single operation. So that's something we want to explore more. All the plumbing is there already in Mystic Pi, but we haven't really developed that so far. The second thing is letting users extend the functionality of Mystic Pi a bit more easily. So we have an idea for configuration-based threat intel providers, where you just provide a YAML file and with the URLs to the various API endpoints, and you can build your own TI provider. Similarly, we've always had the ability to add custom queries, but to make that easier to do in a more dynamic way. So you can just add a parameterized query in your notebook, and then you can use it over and over again without having to like copy paste and just changing the parameters like time ranges or the host name or whatever. So in conclusion, and I forgot to start the timer, so I have no idea where I am in the time at the moment. So in conclusion, I mean, notebooks are amazing tools for InfoSec hunting and investigation, but the journey is still pretty challenging. The core functionality is obviously a key requirement. You need to have the things there, but it's not enough on its own. So if you're using Mystic Pi or you're writing your own functions, these are some of the things you need to think about, like the easy discoverability, like how do I know what's there and how easily can I invoke it? Predictability, that functions should work or classes should work in a predictable way, so I'm not kind of surprised that I get a tuple when I was expecting a data frame, and be simple to use. Have a not have a bunch of steps you need to follow before you do the operation. Ideally, a single line to invoke an operation. If you're trying to evangelize the use of notebooks in your own organization, then you need to be aware to, you need to put time to help people out of the parking lot. So particular attention to like setup, install, onboarding, because just the whole process of getting notebooks working is usually the biggest barrier. Like once people are in them and they're somewhat comfortable with using Python code, then they're away. But that starting point is like usually the biggest kind of hurdle to get over. While we're talking about helping people out, would very much welcome more people to help out making Mystic Pi a little bit more friendly to the InfoSec hikers. So we always welcome kind of feedback, criticism, ideas for making things better. We definitely welcome code contributions, and we've been lucky enough since over the last year to have like some fairly regular code contributions that are not just me and Pete Bryan and Ashwin, who are the kind of main maintainers of Mystic Pi. Also, even if you're not a coder, documentation. We have some weak areas in our documentation, particularly around tutorials. So if you're a Mystic Pi user and you want to write a tutorial about like how to use timelines or how to do threat intel lookups, that kind of thing would be super valuable. There's a very small number of us, like me and some part of Pete's time, some part of Ashwin's time. We don't really have enough time to do this properly. So anybody who wants to help, feel free to reach out, GitHub, whatever. And I will leave you with first of all, the extensive detailed instructions for installing Mystic Pi on the first line. Secondly, how to find us on GitHub. Please visit us there, have a look around, poke around the code. And if you like the code, give us a star. We'd definitely appreciate that, because it's one of the measures we use to have like feedback on how how much people like the code. And we have to justify ourselves to Microsoft as why are they paying us to write all this stuff that we're not selling and why we're giving away for free. And if things that you don't like, add an issue or start a discussion for things you want to improve. You can reach out to us on the Mystic Pi channel on this Discord server. We're somewhat responsive. I'll try to be as responsive as I can. And if you want to do old school, you can also email us at mysticpi@microsoft.com. And with that, I think I'm just about done. So if there are any questions, we're using Discord for the Q&A.
Yep. Awesome, man. Thank you very much, Ian. It's pretty cool to see the process. I guess that the whole also like idea to go from. For example, I like the idea of the parking lot and like where we kind of like are. Like a lot of people are there because that's truth. I mean that. So even myself, I feel that there is a lot of use cases that I have put together, but still, like I still don't understand some of the more complex use cases, I guess. And some of the automation pieces also with Jupyter notebooks. I'm still trying to figure some of these things out. So it's pretty cool to see, right, that there are certain steps that the community is kind of like taking to get to some of these objectives. But now, one question for you on that kind of like context of the being in the parking lot and then taking the journey to go to the different stages of like using Jupyter notebooks. Do you think that it's okay for some people to stay in the, let me see the first stage that you were talking about, the name was, 1 second, I have it here.
The chasm.
The chasm, yes. So it's like, I feel less productive. How do I stick with it? Right. So I feel that, no, actually before that, the parking lot. So in the parking lot, like I feel that there is the concept of you don't need to be a programmer to be in security. And there is, of course, the comment that says, no, you actually need to know some programming to be in the industry, right? Like, what is your take on that? Is that okay for some security researchers just to be in the parking lot and maybe not use a Jupyter notebook? What is your take on that?
Yeah, sure. People are comfortable with all sorts of things, like just like a query interface, or people might be wanting to write stuff in C++ or JavaScript. I think there's also I spoke about these two different audiences, like ad hoc notebook users and kind of writers of notebooks that were kind of like for reuse. So I think even people who don't want to use notebooks are a potential audience for that second type. So, I might have like an automation job that runs Jupyter Notebook on every incident and does some sort of triage. And people can use that output even if they're not into writing notebooks themselves. Obviously in the parking lot, you're not likely to be directly using something like Mystic Pi, but maybe you can still benefit from it because you'll have like a much more approachable output in your notebook where it's like you're not kind of buried in code. You can see the results rather than all of the different like how the results were made.
Right. And quick question on that too. Like I have another one before we jump to the other ones in the channel. I think Joyce is going to share. I think we have two. Yeah, we have two questions in the channel. So Joyce will share those in a little bit. So, so my question on that also is, it's interesting to hear that, right? That necessarily a Jupyter notebook can also be you can be the consumer of the notebook. And right, like it's okay to be at that stage where you're not using something like Mystic Pi, but at least understanding the benefits and the potential of using a Jupyter notebook in some areas in security. It's pretty to me it's pretty useful in your career. So for example, the website for this conference is built in Jupyter Book, which you can have embedded Jupyter notebooks so that you can have interactive visualizations that are being backed by some file or maybe something that could be updated and then be statically shown in the site. Like there are a lot of things that you can do. So understanding, I guess, the benefits of that, right? How you go from maybe a PowerPoint to a similar interface that it could be more interactive, for example, right? So I think it's super important to not just think that using Jupyter notebooks in security, right, means you have to be super technical and dive into all this, code, to automate certain things, right? Like, I feel that there is room for others, right, in a Jupyter notebook ecosystem applied to security, right?
Yeah, I mean, I don't think it's quite rare to find like a SOC where everybody's like a high-level Python programmer and comfortable writing kind of code, but a lot of people can use the outputs of notebooks. I have like one or two people who are experts at creating things, or like taking templates and manipulating them, adding kind of customization, and people can still benefit from that stuff as part of their workflow. Like, oh, I have an incident I don't understand. Let me just fire a notebook off and like triage, get more information about this IP address or this user account, what this user is doing, and the results come back in a notebook, and it's just an HTML document, and that you can see it. You can have a certain amount of interactivity still with it, like as you showed on the maps. I was like, oh, that was awesome. Your introduction, I was like feeling, oh God, my presentation is nowhere near as good as Roberto's opening remarks.
I think that I think this is super cool, man, to see once again like some of the where we are, like how useful it could be in certain areas, notebooks, and also the thought process of Mystic Pi and how you went through defining the initial steps all the way to now the future, right? So there are two questions in the channel. Joyce, would you let me add you to the, where is Joyce? There it is. Joyce, I enjoy the stream. So whenever you're ready, Joyce, do we have two questions?
Yeah, I think we have a couple more questions now. The first question is, are there any plans on making Mystic Pi more interactive? For example, adding context besides the data that is loaded into the data frame. Is this possible via Jupyter notebooks?
Or could you kind of repeat, like making? Yeah, so I'll try to answer it. I'd like a little bit more context behind the question, but so we do have a few like interactive tools. So things like data browsers and things like the pivot functions I was talking about before. There's a bit of browser for like looking through. It loads up all the different entities and shows you all the different functions for for each of those entities, all the different pivot functions that are available. So it's kind of somewhat interactive. You can't really execute it from that. You need to copy and paste that stuff into Python code. It's an interesting kind of thing. And if we had like a couple more developers, it would certainly be possible to do that, to make things much more kind of widget based. We have got a couple of examples like that, but they're not very. We don't have that many. But I think it makes it more possible. The fact that we're kind of regularizing things like the pandas extensions, the pivot functions. The fact that these are kind of very predictable kinds of in the way they work means that we could potentially automate them in a more widget-like interface, so that you that would certainly be nice. There's a colleague of mine in another part of Microsoft Security Research who's just open sourced. I can't remember the name of it, but it is a kind of a cool pivoting interface. It's kind of built in JavaScript, so it doesn't directly relate to Mystic Pi, but that's I'll try and find out the name of it and the GitHub location, which does give you a lot of that kind of interactivity and uses behind the scenes kind of queries and stuff like that to pivot from IP address to logons to processes run in that logon session, that kind of thing. We'd like to get there in Mystic Pi. We're just a bit short on resources to write the code, and I'm not the world's best Java, and I'm not even the world's I'm worse than the world's worst JavaScript programmer, so I'm not super good on UI.
Sounds good.
The second question is, are there any plans for implementing support for Elasticsearch?
Yeah, there are. And we did start to work with one of the speakers last time, Neil from Elastic, on an Elastic driver. So we've got half an Elastic driver already in the code. It's not really working yet. We have fixed a few things that make some of that easier, because the Elastic queries are in JSON, and it's kind of difficult. The way we did queries made it difficult to use JSON to kind of substitute parameters. So one of our collaborators, Florian, who's done some great work on Mystic Pi this year, so he's got just done some work on Cyber Reason that also uses like JSON-based queries. So we should be able to get that. I'm hoping that we can get that done in the next couple of months, but that's definitely, we've had that on our to-do list and in progress list for quite a while.
Awesome. The next question is, how do you feel about the current state of IPyWidgets and its derivatives as a way of encouraging users who are more comfortable with a GUI?
Yeah, I like IPyWidgets, although their most recent version broke Mystic Pi, so we're stuck on pre-version 8. But yeah, it's a great thing, and we try to use them a lot. So we use them for like things like setting date time ranges, for getting input, a lot of the browsers. So I think it's a little bit kind of clunky when you look at like a modern kind of UI interface, but it's still a much nicer view. And we'd like to move more to having like, and it relates to the first, like the interactive question. It would be nice to have more things. So one of the things we're planning, for example, is a timeline, like to be able to display multiple simultaneous like events on the same timeline, and have that kind of, to be able to build that interactively, like add a data frame for logons, add a data frame for like process events, to use that, to do that kind of interactively through IPyWidgets. We normally start by writing the code underneath the API, and then we'll kind of build the UI. So I really like that, and I'd like to do more of that. And if anybody out there is a big fan of IPyWidgets and likes working with them, we'd certainly appreciate some help in making our UI a bit more accessible using that.
Sounds good.
Awesome. There are a few more questions, but maybe for the sake of staying on track, they get answered in Discord.
Yeah. There should be a couple of these slides on the Infosec Jupyterthon site. So if you look you might need to go to GitHub and look at the docs section. I'm not quite sure how it appears through the web interface, but the slides should be up there. They might not be completely up to date, but they're more or less the same content.
Yep.
Okay.
Yeah, all right. Thank you very much, Ian. And yes, and it's great to see like more questions in the chat. So if you have some time, we created a thread for your talk. So maybe you can go ahead, please, and start going through some of those. We are going to take a little break. We have our next speaker, let's see, at 11:35 a.m. So only a 5-minute break, and then we go back with your first graph neural network, detecting suspicious logins with link prediction. So keep an eye on the abstract in the website. I think this is going to be a really good talk as well. So I'll see you all in 5 minutes. Okay? Thank you. All right, I need to put the what's it called, the banner. So 1 second. Let's see. There you go. Cool.
Hey, so I think we're back. It says 8:35 here. I guess that's 11:35 Eastern. I go straight from, I don't get to go have beers after my presentation. I get straight back to introducing somebody I'm delighted to welcome back to Infosec Jupyterthon. Has talked to at least once, maybe a couple of times. So Leo, who I've known, or Dr. Mayerovich, I've known for quite a while now, and always love his talks. So Graphistry is like both beautiful and amazing to watch in operation and what it does. So we're going like several levels above Mystic Pi here to
Yeah.
So
yeah. One thing that I wanted to add in there also is that Leo has been a big supporter of the Jupyterthon conference since like the beginnings, right? Since we just decided to say one day, hey, let's just have a talk virtually, right? Because everybody was working from home, I guess, and it was just a way to share knowledge, and Leo was super cool. I mean, CEO and founder of Graphistry, saying, hey, I would love to participate and share all this stuff. And one of the I would say coolest CEOs, very technical to dive into all these topics. So you go from running an organization, but at the same time being so into the product, and that's just amazing. And you will see in the beautiful presentations that you usually do, man. So thank you, Leo, for everything.
Yeah, thanks very much. Much better introduction than I did. So without any further ado, let me hand over to Leo to show you some awesome. Latest developments in Graphistry.
Thanks, Roberto. Thanks, Rian. I appreciate you raising the bar. No pressure, right? Let me share my screen here.
Mm-hmm.
So we might have a bit of browser reception while I jump over. And can folks see my screen here? Can someone confirm we're good on sharing?
Yes. Yeah, we're good. Yeah, you're good there.
Awesome. Yeah. So welcome, folks, and hopefully fun session to start really drilling in. So as introduced, I'm Leo, the founder over at Graphistry. Today's talk is actually pretty, a lot of it's actually coming from Alex, our head of data science, and Tanmoy. This is actually one of the first projects that he's releasing with us, where on one side, for Graphistry, beyond just the GPU visual graph analytics that we're kind of known for, we've been trying to make AutoML for Graph AI really easy and accessible. And so this is actually one of the first pieces that Tanmoy is releasing. And so this notebook, I'll actually be simplifying a little bit later today, but you'll see kind of the complicated version today, but then you'll be kind of seeing what's the easy mode that comes out a bit later today. So this is kind of a fun place to share what's going on. I'm going to be talking about your first graph neural network, detecting suspicious logins with link prediction. So this is, I'm going to be looking at login events from massive Windows logs, but we've actually been building this with use cases like account takeover and kind of other identity data, and actually even non-identity data. So talk about that as well as we dig in. So jumping in a bit further. So you'll have all the notebooks and data sets and things like that accessible. So no worries about those. So as before we jump into the notebook, I do want to set up a bit about what we're doing today. I always, and many of us really like this quote from John Lambert: defenders think in lists, attackers think in graphs. As long as this is true, attackers win. This is just kind of like, I think in the security community, the whole graph thinking has been growing over the last few years. And so I want to kind of jump into one fun example of this. And this is kind of a good part of the reason I want to share this is just to get you start thinking about graph modeling of your event data. Everybody has logs, but the interesting thing is as soon as you have logs, you have events. And so I want to kind of walk through a quick example here. So on screen, we have a bunch of, in this case, we're just looking at honeypot events, but it could have been any host level events, network events, anything like that. And in this case, I'm doing something I'm going to color them for you on the fly, just so that you have a sense of what's going on. And this actually, and also for the record, this was generated from a Jupyter notebook. It's just a one-liner in Graphistry, so you can find this in our demos folder. So in this case, and I think this looks maybe, I guess it's like an IDS alerts from the honeypot. So we have vulnerability names. And so we have a few types of nodes on screen. So we have attacker IPs. We have our honeypots. Looks like we have a couple of honeypots. And we already, if I just focus on, like I'm going to hide the vulnerabilities for a quick second. So let's just get rid of all the vulnerabilities. Right now, we just have like a network map, 2 honeypot nodes, a bunch of attacker nodes. Maybe I get a timeline, and I can kind of sort of see over time what's going on. If I bring back the vulnerabilities, now those are actually nodes. I can actually start understanding a little bit. Let me kind of recluster, let it settle. I can start understanding a bit of what's going on as well. So for example, this honeypot is primarily getting hit by this net API vulnerability. This honeypot is primarily getting hit by this MaxDB event. This vulnerability, whatever this guy is, this LSAS is hitting both of these honeypots, and et cetera. And then if I want to do temporal correlation, I can kind of keep digging in. Maybe I start playing with some of the attributes, color them, things like that. And so as a defender, I can kind of get a sense of what type of activity is happening. If this wasn't a honeypot, but it was actually internal assets, this would be even scarier, right? But I'd be kind of being able to start playing out these timelines. And so as an analyst, graphs already let me see kind of all events across all time and kind of just start doing lots and lots of correlations on the fly. So imagine you had to write SQL or pandas or something like that to kind of do all these correlations really quickly. It's a little hard. So graphs are awesome as an analyst tool. What we're going to be talking about today, we are going to be talking about a lot of event data and log data, but like I said, I want to focus on just really the identity data. And so I'll talk a bit about that. But as a kind of a little teaser, when we evaluated the method we're doing at the end, we looked at it for something about like 400 million events or so. We can catch about 96% of a red team's activity, and only 10% of what we detect as anomalies were false positives. So that was kind of ridiculous. So hopefully, like that's maybe the real bar for the talk here. And I'm going to be talking about primarily graph neural networks, and then as a little bit of a foreshadow for tomorrow for Alex, UMAP. So when we're talking about graphs for identity data, what I'm in my mind in this talk, at least, I'm thinking of a few scenarios, and these are things that, when we work with U.S. government agencies, enterprises, startups, tech companies, well, we'll see this both on the security team and actually the fraud team. And so we think about things like fake accounts, like when there's a sign up, like is it a strange identity? Or then when we see the identity taking actions, maybe like if it was an internal account, maybe there's like malware, or maybe if it's a customer account, maybe there's credential stuffing. Was there an account takeover and all of a sudden is behaving weird? Or maybe it's an insider threat and then there's like a help desk or a rogue admin. So government, like for example, the whole Edward Snowden thing of like, if you have a rogue admin or someone with privileged access, is all of a sudden they're acting strangely. And on the flip side, when the strange behaviors are happening, isn't resource getting accessed in weird ways? And so for folks who are kind of in the security industry a bit longer, you've probably been smashed over the head by vendors with the whole UBA acronym. And in our case, what we're thinking about for these kinds of logs, for the fake account scenario, we can start all the way at the entity resolution level of like who that identity is, who their assets are, what their contexts are. Then once they start to authenticate against the system, so we'll actually start seeing things in like the win logs or SSO. And then a bit later, when they start to authorize, we'll have all of that data. And so probably another thing you're getting hit over the head with right now is the whole zero trust thing. But from the perspective of data mining, this is actually really cool because we actually now have end-to-end telemetry about this full identity lifecycle. And so this is the kind of what we're looking at as how do we use that stuff? We're going to be kind of looking at two sides of the same coin. One is, could we get good enough results that we could do a low false positive identity detection, alerting or detection scenario? And the separate is, even if we get kind of these medium confidence things, could we actually get good stuff for investigations? So I kind of want to focus on both of those today. So from the perspective of techniques, I'm going to be primarily talking about graph neural networks, but then also, like I said, something called UMAP. Both are types of graph AI, and so you'll kind of see how they're going through there. And so I'm going to kind of just briefly introduce what's going on there. So, so first, I just want to introduce this notion of graph neural networks. And it doesn't really matter if I say I think they're cool, but I think what is cool is that science, which that's science with a capital S, they think they're cool. And so for the 2021 Breakthrough of the Year, they gave it to something called AlphaFold and the broader community around it. One of the things that they're talking about is protein structure predictions and the ability to predict these things, and particularly the new area of graph neural networks, or like the now popular area of graph neural networks that finally tackle and solve the protein folding and protein prediction problem. So that sounds really complicated, but I think this picture, it gives you a good intuition for what's going on there, and then why it's kind of interesting for us. So on the left here, some molecule, I barely remember this stuff. Actually, I don't really remember this stuff, but basically, kind of like how I was showing you the graphs before, we might have some structure with some interesting types on it, maybe some interesting values on it, very familiar to the graphs I was just showing you with the honeypot logs. And then we're trying to make some predictions on it. In the case of the drug discovery area, they might be trying to figure out, hey, will this shape fold together in some way? And then that is a kind of a viable drug, something like that. In our case, what we might care about is something more like, hey, instead of getting like an X and Y and Z coordinate of it, like being a likely shaping position, I want to know, is this likely malicious or not? Or I want to know if this is anomalous or not. Maybe I want to know if a computer is anomalous, or maybe if someone is logging in, and so that's what we call node classification. Like, do I paint a node red or gray? Or maybe I'm actually interested in the linkages. Like, let's say somebody is logging in from one server into another. That's something we call link prediction. And that's what we're going to be talking about today. And that's where we want to know not the node is red, but the edge, like, login event. Another variant could be, for example, is this entire subgraph? Maybe we can classify that. So, for example, I might want to know, is this a kill chain that this entire behavior anomalous instead of just one individual node? And so being able to talk about graphs in a AI or ML context is very powerful. This work, as you see, is very recent. It's kind of one of the first big wins of the whole graph neural network world. But now graph neural networks are basically one of the top areas in the AI conference scene. One of the intuitions for what's going on here is, and I'll get into this a bit more, is beyond just having the graph shape, we can now, kind of like how we're trying to predict the X and Y and Z positions for the folded proteins, we can now talk about attributes in the data, like the timestamp or the number of bytes, things like that. Maybe the subnet range. So instead of just the graph shape and connectivity, we can also do the normal AI stuff with all these other useful columns that we might be staring at as an analyst. And so this is pretty exciting. So given that, we're able to now, at least in theory, this family of algorithms for doing these, like, think of those as sort of like building blocks for actual use cases. We can now start think things like anomaly detection. So if we think for example, a login event is very low likeliness, we can then say that we can actually build an anomaly detector that says, hey, there's an event with low likeliness, let me trigger an alert. Or when I'm doing, maybe we were in Mystic Pi and we want to kind of pull out some enrichment, could we just have all of the events sorted by the likeliness? The way I actually got into this is when we were helping with some misinformation investigations around in the medical community. And I was very interested in the abuse, content abuse scenario of like, and I'll get to that actually in a second, but where we can actually do ensemble methods of using the graph structure to blend scores. Anyway, I'll just leave it at that. But the basic insight here is if we can make a GNN work for some task, we might be able to reuse it for other tasks. And the goal of today is basically, can we, without a lot of pain, write our first GNN. We're gonna be focusing on something called RGCNs, or Relational Graph Convolutional Networks. That is a mouthful, so I'm gonna kind of present it in a slightly different way. So, and at the end of my notebook, I have a couple of YouTube videos of one of the best actually introductions to the stuff that I've actually seen. So that it's basically, it could be a talk in itself, just to introduce the ideas of like GCNs and RGCNs. But I thought this would be, this picture here might be a good intuition for where we can work through some of that. So I'll explain this in a second once I set up the coloring here. So what we're looking at here is a botnet on Twitter. And I'm actually, yeah. So we're looking at a botnet on Twitter, and each node here is some Twitter account. And ahead of time, we've just computed some statistics on it just to make it a bit easier. And so imagine an influencer buying retweets, something like that, or trying to buy followers, that kind of scenario. So if we're going to think about identifying strange Twitter accounts from just like from a phenomenon perspective, and we want a, oh, looks like our graphs are getting butchered here. I'll try to click around a little more slowly here. So if we want to think about what we want from a graph AI algorithm, like what work we'd want them to automate for us, this is a pretty fun example. And so as an intuition, if I was investigating one of these Twitter graphs, and I see these interesting shapes, in this case, we know we have to be investigating, again, somebody buying, getting their tweets amplified. I might be, and I want to start classifying these different nodes as being different kinds of content manipulation. I might start like want the algorithm to know about certain phenomenon. So the first thing is, if I'm trying to decide if this account is strange or not, one of the things I might think about is like, well, what if I knew that some of the surrounding accounts are strange? And so I'm actually going to let us do a little trick here. So when I hover over nodes now, we're actually going to look at not just one hop away, but actually 2 hops away. And so, for example, when we're looking at this node here, I might want to say if all of its neighbors are suspicious, then maybe this account is also suspicious. So that's something called label propagation, where if we already have some scores, we might want to start propagating them along the graph. And as an analyst, that's sort of like, you go to virus total, and then you kind of see like how many weird things something is connected to. So it's kind of like that. But when we talk about something like a graph convolutional network, we might actually do this multiple times. And so maybe we want to get data 2 hops away, and maybe the further it out, like maybe the more complicated we do, or like the more or less weighted, the further it out it is, things like that. And so when we talk about layers in a graph neural network, that's kind of the intuition there. So another intuition that's kind of interesting with this stuff is we might have a lot of features on the data. So in this case, the reason these nodes are really big and I was able to highlight them is I pre-computed something called the betweenness centrality. So sometimes we might externally want to compute some of these features. Maybe the data has something like the degree ratio. So maybe it looks like somebody just has lots of accounts, or like it looks like somebody's tweeted, like 5 billion times, and it's very unlikely somebody's ever done that. So features and data are really useful. Same thing in files like severity scores, like signatures, things like that. Those features might be on the node. Maybe it's on the edge. Like maybe it's just like a timestamp. That's kind of interesting. And so what we're interested in is kind of two related things. One is, can we use the features in the data as part of also, so instead of just having just the graph shape? And the other part that's kind of interesting, and we'll kind of touch on a bit later, is not all relationships are the same. So let's say somebody responded to somebody versus somebody followed somebody, or maybe somebody blocked an account versus somebody followed account. Both of those are relationships that we might want to have our algorithm kind of think about. But we'd want to have it weigh them in differently. Like if someone blocks somebody, that's actually a vote against them. Well, if somebody follows somebody, it's a vote for them. So not all features, like if we kind of treated them all as like the same kind of thing, our algorithm would get very, very confused. So these are the kinds of things when we're looking at a graph AI algorithm that as an analyst, you kind of just know to look at, but we need to, it's actually very hard until very recently to get those supported in graph algorithms. And in my theory, that's one of the reasons that until recently, they didn't really make much sense in practice. So we're not going to go deep into the theory here. I think that's actually about it conceptually. There are 2 really great YouTube videos on GCNs and RGCNs. You know, if you ever have like 20, 30 minutes, I'd just sit on and watch those. They're really great. So with that, I'm gonna jump in. So now let's get into the fun stuff. So the data set here we're going to be using is, I think I have a link to it, and I did not have that open. Can we open this up? This is a pretty fun data set. If you're ever looking for fun, real data and you can't use your production data, this is a cool one. So it's about 12 gigabytes of win logs. So it's 1 billion, looks like 1 billion win logs. This is a real government cluster. So it's about 12,000 users, 17,000 computers. So this is sort of like a nice, like medium-sized enterprise. So this is pretty real. In particular, we're going to be looking at the Windows authentication data. So you can see it's like super cleaned up here, like, and it's anonymized a bit, but like a lot of the interesting login events are here. And then also a bit interesting is we have about 400 or 500 red team events. So this is about, I think, a 2-month period. And then somewhere within that 2-month period, there's a red team, and there's about 500 logins, 400 or 500 logins that are logged in here. And so our question is basically going to be, without any supervised learning or anything fancy, could we write a graph neural network that detects most or some of these and have very few false positives when we're doing that? So that is the goal, and we'll see how far we get. So for this example, once you get your data, just to keep things a bit snappy today, we're working with a 40 million subset of the authentication logs. So the kind of, once you actually load it in, looks kind of like this. Some of the interesting fields here are, for example, the domain users. So as we're logging in, like who to what. And then we also have the computer names, like which computer to which computer. I think we're actually going to be using these mostly. And then we have different kinds of like the authentication type, like is this NTLM, Kerberos, and the login type, things like that. So pretty normal. To give a bit of a intuition, I wanted to share kind of a slightly different view of the data. So here we're going to have a graph of basically everything I just showed you. We have now the computer names are the nodes, and the edges are these events. And before we try to do something fancy, I think it's always useful to ask, could we just do something dumb? And if we could do something dumb and it works, then we can call it a day and do something more interesting with our time. And so what I wanted to focus on here is something like, let's take a look at all of the red team edges. And we want to, and so we have two clusters of computers for a sample of the red team events. And I want to kind of get a bit of intuition for what's going on with those to say, hey, could we do something simpler with them? And so one of the things we had computed in a notebook ahead of time is a conditional probability. And what that is a really fancy way of saying, could we just do like a counting to say, how often does somebody from one computer to another log in? And if it's very unlikely, like it happens very few times, could we call that an anomaly? And so that's what we're going to call this probability score. And so what we're seeing is if we just do like an anomalous event, just like imagine standard deviation, or again, in this case, we're just doing the conditional probability and we could just sort on it. We're seeing these like for this computer to log into that computer, that's only happens about 7% of the time. That's kind of a weird thing to do. And so what we might ask is, well, if I go back to the full data set, like I undo my filter, and we try to, we think about, like, if I look at all the probabilities, and if I looked at all the probability 7% things, how many do we get? Well, for the probability 7%, we have about 15,000 events. For probability 3%, another 23,000 events, and for probabilities like very small, we have about 60,000 events. So if I tried to just do something like the standard deviation or just like anomaly on like just like one of these very simple things, and then I automatically filed a Jira ticket or whatever for each one of those alerts, I think I would probably either, I don't know, I'd first have to delete it all and then maybe I'd get fired. Like, it's just like the false positives are so high. You just can't have 100,000 tickets. So it's a good intuition though. So we're going to get back to it, but just on its face, doesn't quite work. So we're going to go a little more clever. And so this is where the whole GNN stuff comes in. It's kind of fun here is we've kind of got it down to just a few lines. And so I'm going to share basically these lines. So the first piece of code is we just need once we have our data frame of our events, we're just going to load in the data frame of events. And then the source here would be something like the computer name, just the name of the column. The desk would be that column. That's our graph. We now have this graph history object. That's our graph. Later, I'm actually going to have some other columns. I'll get back to what those are. But for now, just think of it this way. And then once we have that graph object, we're going to compute we're basically going to do something called compute an embedding. And I'll get to that in a bit later, perhaps. But basically, this is our training loop. And I'm just going to give you an example. Like if by default, actually, I want to share one more thing here. Well, okay, yeah. Like most of these options are actually optional. I'm going to start playing with them later, but I'm just going to run this really quick. So once I have that graph and I do the embed call, once I start playing with the parameters, you'll kind of get more of a feel for it. We're going to do multiple iterations of training. In this case, when you see the notebook, I just made a quick flag is GPU. So if you don't have a GPU set up, you can just run on. It'll just flip it over to CPU. It'll just run a lot slower, but that's fine. This will actually, if you have multiple GPUs, this will actually automatically use those too. So this is, again, this is pretty like auto mode. And what's going on here is it's going to do multiple iterations of trying to find basically a good model, and it's just kind of be randomly permuting things to get there. And so what you're going to see is two numbers going down during every iteration. So you kind of want, hopefully both, you want loss to eventually get to the level of it's like 1 or less. And then the score is basically how well we're doing it. And that's going to be generally, ideally we get like, I don't know, like wonderful world, we get an A, we get like, a 95, but chances are even like a B could be interesting. So right now with a very simple GNN, where you're seeing that like every iteration, we kind of go down like maybe 1% or 2. And so even like 20 iterations can actually generally go far. About 20 to 40, I found kind of converge it just takes, you're not going to really get much more juice out of this one. So let's let this one finish up. As a quick note here, the GPU is kind of pretty important for each iteration step. So right now on my box, it's taking about 5 seconds. On a beefier GPU, it might actually go even faster. On a CPU, it might go about 10 to 20 times longer. So it depends. One of the other things that I'm not showing you, but actually when we're using it, I basically always have this sidebar open, which is telling me how much memory is getting used. And so in particular, I have on the top my GPU memory utilization, and on the bottom I have my CPU memory utilization. And so basically, as soon as either of these bars go over, it's game over, and my browser has crashed. So okay, so like once we've run that, I want to jump to a couple of functions here just to see how well we did. So the first one, what we're going to do is and keep in mind, we now have this like trained G2 object. So now what I'm curious about is for our existing data, if we run it through, and then let's say we want to find everything with a score of like less than 3%, something like that. I'm curious about how many of the honeypot events did we find? And so we actually did find, in this case, actually in the sample I'm working with, we have about 10, red team events. We have about 8 red, I think we had about 10 red team events, and this found 7 of them. But an interesting thing about it is, let's see, this actually worked really well. So in terms of like, if we're looking at 3% of the data, there's about 900, anything with a score of 0.03 or lower. We flagged about 900 logins. And within those 900 logins, we actually found 8 of the 10 red team alerts in the sample. So this is actually pretty good. But on the other hand, from a false positive perspective, that means for maybe it's like a 10 to 1, something like that, or 100 to 1. It's like, in one sense, it's cool we found most of them, but in another sense, I wouldn't want to make a ticket out of each one of them. And so this is where other variants of the model get interesting. Very, very, very briefly, I'm just looking at time. One of the coolest parameters in this model is that you can define different relations. And so what I'll kind of show you a bit earlier in the table, what we compute is actually a few options here. So let's go take a look at them. So on this table here, when I did that initial run, we weren't differentiating different types of edges. We just kind of treated them all as the same, and we kind of learned the same weights for all the kinds of edges. But maybe we want to treat Kerberos events different from NTLM events, or like there might be other, like I think there's 17 different types of authentication types. And so by specifying the authentication type column for that relation, that means we can actually let the model know, hey, I need to really spend time differentiating these beyond just looking at who's talking to who, kind of like in the original conditional probability case. Could I also split it out on the different authentication types? But we have like lots of these columns. And so, for example, maybe the login type is also interesting because we do have 10 login types. And so we could play around with it, for example, trying one or the other. But because we now have this one column that we can put as a parameter, we can start doing other tricky things. Like, for example, maybe I just concatenate them together. So I'm going to have 17 of those, 10 of those. And when I combine them together, we're now going to have, if I just, for example, combine them with the string concatenation, maybe I have now 38 types, and I could just let the model figure it out. If you put enough of these in, and so, for example, we're doing a thing with the cyber command a couple of weeks ago where, I don't know, I think we had like, thousands of these things. You might want to start just picking out the most common. And so there you can do something like a topic model. And there you can kind of see here, we're kind of picking out the most interesting words. And so even if there's a whole lot of values, you can actually compress it down. And so there are a bunch of tricks like this. So that's one of the things that we play with here. Another one that I want to bring up, but again, interest of time, probably we don't want to go too deep on it here, is we can also use the features. And so you just flag on, hey, I actually want to use features, so that for my node table, which again, when we made that original graph, we passed in, let's say, enriched IP addresses, something like that. We can actually specify which columns I wanted to use there. It's like, so for example, maybe I wanted to use the domain name or the, I don't know, like last login date, something like that. We think any of those might bias or improve the model. We can just throw those in, and this will actually automatically convert them to ones and zeros, things like that. And you can see elsewhere in the notebook where we actually do some pretty fun, fancy versions. But again, our goal here is to make it pretty AutoML, and so just trying to really get it down to that one call, and then you could just play with the input parameters. So I want to, so then when we change them, we can rerun it and see where we get. But I want to jump actually to a bit of a preview for tomorrow. Alex in the morning has a session where he's going to be talking about something called UMAP. In his case, he's going to be looking at alert volume reduction, where given, I want to say is like 1 million or 10 million alerts from several like MSPs and universities over a week. He was able to kind of reduce it down about 97% to kind of go from alerts to kind of more discrete incidents, which are kind of buckets of alerts. So he's using UMAP for that in a pretty interesting and scalable way, and also actually visual. But we were actually able to reuse that technique for this data. And I'll kind of show what's going on. And it's kind of, once you see it, it'll make a bit more sense. And it's actually going back to that original idea of like, hey, could we just look at the outliers? So let's load this guy in. 1 second. Hopefully it loads in. Yeah. Oh no. This is really unfortunate. Oh, here we go. Okay, cool. So what I'm going to do, so now we have a, let me clean it up a really bit, and then we'll kind of explain what's going on here. So what's going on here is basically, I'm going to color based on whether it's red team or not, and then I'm going to give you a bit of intuition for what's going on. And what's kind of cool with this is like the previous thing, it's if you've got a GPU, it'll use it, and then the other part of it is like the previous one, it's pretty darn automated. So let me dial down the point sizes too, so let's make a bit more sense. So now the points are a little different. We're now actually treating each point as one of the events, and so we're just trying to kind of like map out the different login events, and then we're gonna the observation is that when instead of just looking at one attribute at a time, what we're going to say is if any two events, let's say in purple we have all the red team events, if any two red team events are kind of across all their different columns similar, so maybe they're logging in at a similar but not exact time from a similar computer, things like, and like anything like that, we're going to connect them together, and we're going to place them next to each other. This is what the UMAP algorithm does. Graphistry will actually add the edges for you so we can kind of see them. And what we observed is that, you know, except for a few of these blueberries in the middle, basically here, that most of the red team activity, and so we have all 800 red team logins. Most of them don't really land in that main area. And what's more, each one of them is kind of in a small cluster to itself. So we kind of see that it's not part of any of these big main blobs that you see every day. And so if I was going to make a decision procedure, I might say, hey, could I look at like all the last hour's events, whatever, and then if anything is in a small cluster, or if it's in this region I've seen before, I want to kind of mark that as anomalous. And do I have a score? It's actually, the algorithm's a little bit smarter than that. So I'm going to show one last thing for that. So let's color, we actually have a confidence for each one of these. And so we're going to, I'm going to color each point now based on the confidence that we get from basically this UMAP. Maybe, I don't know. Okay, there we go. Let me like bring the transparency down to, so what's kind of cool is you can think of this as sort of, if you've ever heard of like the floor is lava game, you can kind of think of, when I was mentioning embeddings in the beginning, every time we get a login event, you can think of us as like mapping it to some XY position on the screen. And you're noticing that each of these clusters, we actually might have multiple points, and all the points near each other have the same color. And so think of it as like floor is lava. So like, when the event lands over here, it's not actually that the points themselves are let's say cold or hot. What we're actually saying is this entire kind of subspace or subregion is that color. And so when we're seeing alerts, first of all, when we talk about an embedding, we're actually saying we're able to take events and kind of map them down like that. And then when we see new events, if they also land and we kind of project them down, if they land in that same place and they have that same color, then we're pretty sure that like everything else that landed there, that they're also anomalous. And what was kind of ridiculous to us was when we ran the UMAP, and again, like Alex will go much deeper into it, when we looked at basically all the small clusters, we found that 96% of all the red team activity was actually in those small clusters. And the more, and that means that's a pretty good way to kind of find them. And what's interesting is that there's very little non-red team activity there. So if we looked at like all the kind of, were there any sort of blue stuff in those, maybe for every, maybe 1 in 10 was actually not red team. And so that meant this is actually might even be good enough to build a alerting system where you wouldn't overwhelm. We're still evaluating this, but we actually might have hit state of the art for that data, for this kind of government data set, which is kind of cool because honestly, we just spent about 1 or 2 days on it. So that was while researchers have been spending on basically years. And so this is, I'm not saying we're definitely going to get that, but it's definitely, I think Alex's talk will be pretty fun. So stepping back, hopefully you got a sense of a bit about why we're doing GNNs, and while there could be a lot of interesting theory about it, it's now something that basically you could just basically load in your regular graph history graph that you do just for plotting, but you can now actually, as soon as you do that, you basically could run embed and you have your first GNN. These are all kind of optional parameters generally. The only one I think you really need is relation. The rest should have pretty good defaults. So, and then you can start using it for things like predictions, as I talked about. In the case of identity data, we are focusing on that one a lot as we're tuning this model. The kind of our next phases, and feel free to reach out in our community Slack if this is your thing. We're looking at how do we turn this into more of like a like once you have a cool model you've done in a notebook, how do we turn this into something that like automatically retrains? You could have it go imagine into your hourly or daily Splunk, maybe in a detection level. We are focusing a lot on kind of the identity data you expect of like Windows data. We're going to be looking at stuff like Okta, and other side is on the website of like the account protection side. So like web accounts, things like that. And there is more to do. Kind of, you saw that I was doing the GNN side. We're also looking at UMAP. The reality is in a lot of these pipelines, you want to combine stuff, or there's certain phenomena you want to take care of. We actually haven't done anything really with time data yet. And so that's one thing that we know we could do. Likewise, we think there's going to be some common false positive scenarios that we're going to be working with some of our partners on. Alex's talk is actually interesting because once we have these models, we can also use them in investigation contexts where we can actually use them to do correlations. And so he's going to talk a bit about how we get correlation IDs, kind of if you use like Zeek or Bro logs and they give you correlation IDs. Even if the tool doesn't provide them, we can actually generate them. And so you'll see a bit about that tomorrow. I think I might be way over time. So thank you for the patience from the organizers here. All these notebooks are going to be we have a couple of repos. One is Graph App Kit if you do dashboarding. It's kind of a wrapper around Streamlit. But if you just want to do the raw notebook stuff, it's already in the branch. I'll post it in the Discord, hetero embed, and then we're going to be landing that pretty soon onto the main. And the idea is we put the notebooks all into these demo folders, so you can kind of find them all here. So that was a lot. I have no idea how I'm doing on time. Hopefully we're good.
A little bit over. But
a little bit over.
Since you're a friend of the show, then we'll try and pick up some time in the interval. I in the next break. I just had a kind of quick question. What's the best place? I know you pointed to a couple of repos, but to get started, it seems like even from somebody like myself who's like somewhat familiar with Graphistry, kind of a big thing to get started with. Like, how do I?
Oh, definitely PyGraphistry. And just the GitHub repo. We actually try to make a lot of the things basically one-liners. So as soon as you have the data frame, you could bind it in and dot plot it. And so a lot of the examples on the main one, and then I'll post a link in the Discord. So we do have one notebook that is kind of your like that honeypot example. That's a really nice starting point of just going from an arbitrary log file to a graph in just a few lines.
Okay, cool. I think we'll have to take other questions like in Discord, and if Leo can kind of answer those online because we were a little bit behind time, but I wanted to thank him for another amazing presentation and a lot of stuff to think about. Kind of blew my mind a little bit to see that. Particularly I'm really intrigued about this kind of application of a kind of graph neural networks, which I hadn't heard about before. It's kind of fascinating area, really, and something I worked on a long time ago. Is like, how do you predict anomalies from a series of graphs, like a lateral movement pattern? When does that become a weird thing? And it turns out to be a kind of difficult thing to do. So this is like really exciting. Fantastic talk. Well, thank you very much, Leo. We're going to have to kind of move on. But please, questions in the chat. We'll look forward to talk tomorrow as well. I wanted to add Saksham to the stream. And Saksham is a kind of lead threat researcher at Cred India. Going to be talking to us today about use of notebooks. A lot of interesting kind of technologies like Plotly, Virus Total, about kind of painting a kind of, I think it described it as a canvas for understanding threats using notebooks. So with that, I'll just hand it over. So welcome.
Thank you, Ian. A lot of interesting and very advanced talks. I'll try to pull it back a little bit to understand how this notebook actually fits into a defensive arsenal, and also would address the users that you have shown in your chasm state of your graph, right? It's working, it's not working, that kind of phase. So where does defenders or basically security analysts can use Jupyter notebooks to fit in their workflow? Let me just try presenting my screen. Yeah, do let me know if it's visible. Ian, can you confirm if it's visible?
Yeah, that works. Can you hear me?
Okay.
Yeah, it works.
Yeah, I can hear you. Yeah.
Thank you, man.
Thank you. So yeah, as introduced, I work as lead threat researcher, detection engineer here at Cred India. I love all the things about security. Most of the things about threat, be it tactical or strategic. It involves detection, analytics, intelligence, hunting, and all things about threat that you can really think of. I am a huge admirer of automation, so I love automation and coffee everywhere I go. So yeah, that's all about me. But let's quickly dive into the topic for the day: exploratory threat analytics using Jupyter notebooks. And one of the first questions that you get into your mind is why notebooks, right? Why not use a SIM or an EDR or a tool or a data lake just for doing the analytics that you might perform or want to? Yeah.
Can I just interrupt? Could you zoom in your notebook a little bit? So
Sure.
One thing I'd point out as well is if you can make sure if you're watching the YouTube stream, you're watching it as like high resolution as available, because it makes a huge difference from the default, like particularly intricate graphics and stuff. But hey, thanks. It's great.
Thank you, Ian. Okay. Yeah. So one of the questions that you might generally come across is why use notebooks and why not use SIM or EDR or any other tool that hosts a lot of your data to use or accomplish the analytics that you might have designed, right? From a defensive perspective, that would make sense. But let me define how this tool actually fits into the arsenal, and how do as an analyst, I picture this tool into the workflow and the entire workflow. So what I really understand is, and this is the perspective that I share, is log analytics, log collection and detection makes more sense on SIM, right? You have a lot of logs collected from various sources, various data generating nodes, all of that into a single repository. That could be a SIM. right? Case management makes sense for notes, annotation, evidences, trying to figure out what happened. All of that data and evidence goes into a case management, right? But where the intersection of all of these is where I see Jupyter coming in, right? A single canvas or a single notebook where I can do all the investigation at one place without context switching from one tool to different tool a lot of times, right? And I have a I have a I from the experience of working on multiple tools, multiple sims, what I've really developed is there is a bit of friction when you change from one tool to another tool, right? For example, if I'm using say Splunk to query language today to run my queries today, and if I change to Elastic, there's a difference of query language, right? The all of these query languages keep on stacking on each other, where you have a lot of context switching to be done when investigating a case for across multiple tools, right? Every query language is built differently, offers you different kind of capabilities, and they are not the same, right? Some might offer you a very simplistic filtering language, some might offer you SQL, some might offer you very advanced query language, some might offer you just a UI with some drop downs to find and input keywords that would give you results. So all of this introduces some amount of jitter and friction while you're doing your investigation, while it might lead to a deviation of what you really want to achieve. So having a sense of Jupyter here actually brings in the power of programming language, that is Python, and this gives me enough capability to run on my investigation on a programming language while querying all the tools that are available to me in the environment without context switching a lot. Another thing would be I see, as I explained, I see notebooks to be at the intersection of code investigation and annotation. So it's one single place where I could run my code. I could get the insights as investigation and evidences, and also annotate using Markdown. Simple as that. Another thing that I really love about this is why we have programmatic control over data and logs, right? Programmatic control means I can loop through the data, I can parse, extract, convert, transform, do conditional statements, even call in several libraries that are available at my disposal, and use them to actually have a greater control over data. So these three are basically core drivers of where I see Jupyter fitting in a defensive arsenal. But there's more, right? Enrichment and context on the fly. So by enrichment and context on the fly, I mean it's up to you where you want to enrich and what you want to enrich. There's a whole lot of data available, be it reputation websites, be it your threat intelligence platform, be it data that you want to just scrape out of GitHub. All of that is available at your disposal and wherever you want, and you can enrich your data on the fly. And this also offers an orchestrated approach, right? I'm doing an investigation cell by cell in a human driven analytic form, where I am only focusing on what I want to achieve as next, and skipping a lot of rabbit holes, right? I'm really skipping a lot of rabbit holes and jitter, while not context switching amongst various different tools, doing various different documentation. So I'll try to explain all of this via a simple investigation use case. Let's take a investigation case of finding suspicious partial executions. This is a very simple demonstration of how these use cases line up and where do they actually fit. And I've taken the liberty of actually defining the use case wherever I see it pertaining to the action that I want to do. But before we jump in, there are very two common use cases that every security analyst or a detection engineer faces. Is the problem of bulk alerts that you get, right? There might have been a spike in data volume, or there might have been a case where you are writing a new detection in your environment and it just throws a lot of alerts for you, right? So investigating those in these scenarios, you don't want to just close all of these alerts as false positive without analyzing what actually triggered them or the root cause, right? Because these are the parameters you take into account for fine tuning and improving the detections performance, right? So calling all of that data into your single notebook and then try performing statistical operations or enrichment or step-by-step playbook over looping over all the alerts here at one place would give you a lot of sense about what's happening on all of those alerts. And makes a very good fine use case for me to use Jupyter in day-to-day detection engineering operations. Okay, let's go from calling the data. For this demo, I'm using Elasticsearch. I have Elasticsearch local instance that I'll be using. But by the way, since you have programmatic controls, there's no limitation to what kind of data you can call, right? So you can call data from any security tools that offers you APIs, that you from S3 storages, your online data sets, Git repository, from wherever you want. And in today's era, most of these security tools are driven by APIs, right? They claim to be driven by APIs. APIs are one huge big selling point. So, and it's great to see a lot of tools are providing Python supported libraries for you to work with. So I'll be using Elasticsearch Python library. So here, Elasticsearch and Elasticsearch DSL, and calling that for calling the data set from my SIM or the Elasticsearch instance. Another use case is, since I've got the data, I already know that I'll have the data. Let's assume we have the data. What next, right? We need some data analysis capabilities, and what comes really straight out of mind is pandas, right? Pandas is a very popular data analytical library that gives you huge amount of capabilities and speed, right? With very low code to be written. So we are importing pandas here again. I need more than this, right? I need more capability, more analytical driven approach to solve this case, right? For example, I need SQL, I need intelligence, I need visualizations, right? Graphs, maybe a lot more than this, right? And that is where we realize that the capability of just using Jupyter is just not limited to tools. It expands to host of different Python libraries that are available at your disposal. For example, I can use just PySpark for getting analytical capabilities of Spark, or I can use Seaborn or Plotly just to create visualizations, graph frames to draw graphs. And all of these capabilities are here available at just the single canvas, right? So I'm importing PySpark here just for the SQL capabilities that I really want to use. I'm creating a Spark session so that I can create an SQL table view on top of the data that I can call through Elastic. And I'm also setting some of the parameters for Jupyter Notebook so that the data is not truncated. Okay. I have created an Elasticsearch object that basically reaches out to my Elasticsearch and does a simple HTTP authentication. And I've also defined the index from where I'm calling the data. And since calling data and getting data from a SIM could be a repetitive object, a repetitive task, right? What we really do in a programmatic world is define it through a function. So what I've really done is written a function that actually accepts Elasticsearch query. And through this query, it will search for last 120 days of data and return me back some response, right? I can use this response to just normalize it into, by the way, this will be a JSON response, so I'll normalize it into a data frame and create a Spark data frame out of it so that I can run my queries on top of it, right? Again, you need some more capabilities of data sanitization, right? Because there could be friction in how a data is presented from different tool. For example, a tool in my arsenal could be calling source IP to be source.ip, and a different tool could be calling it source underscore IP, right? So having the capability of wrangle the data live here is enough for me to correlate multiple data sets from multiple different tools or multiple different locations. So in similar fashion, what I'm really doing is, for a Spark data frame, I'm replacing the dot with underscore here. And I'm also removing @ symbols. So for example, Elasticsearch returns timestamp in @ timestamp. So I'll remove @ and just use timestamp here. And I will return a clean Spark data frame to work with. Nice. Cool. So what we really have here now is basically a function that returns me data. Let's query for Elasticsearch EDR data index. I'll get all the partial events. I'll call for this query. And now I'll create a basics view on top of the events that I got, right? Partial events will become the SQL view on which I can do a SQL query. So now another use case that you get really that is really offered here is statistical capabilities at your disposal, right? A lot of query languages offer this built into your sim. A lot of them don't, right? And that is where you have a habit of actually doing statistical operation or data summarized view on one tool, and when you want to do it on a separate tool, you lack it severely, right? But here, when I'm interacting with all the APIs of different tools, Python doesn't limit me to do anything, right? Or Spark doesn't limit me to do anything until unless the data is formatted and is available, right? So I'm running an SQL query to figure out what the process parents were, processes were, and figure out if there are any suspicious ones. We do have certain suspicious entries, and what this calls for again another round of say statistical stack counting. So what I'll really do is also factor in process command lines and group by it to figure out what happened, and you can really format it. So it's this format is coming because I have actually zoomed in. If I zoom out, you see all of it makes sense, but for the sake of presentation, I'll just zoom in again. Cool. We have encoded commands here, right? This is really suspicious. mshta.exe calling this. Also, auditing. You can take your time to audit all the command lines that you have here. That doesn't make sense or represent a very suspicious behavior, right? So, for example, you see there is an initial dropper.ps1 being executed from the desktop. These two seems interesting to me. I'll just call in again to audit them in a view where I'm not truncating them. So we have encoded command line, partial except space 64 encoded commands. Truly suspicious here. This could be a case or an investigative lead that I really want to pursue, a rabbit hole that I really want to chase. This one seems okay. Let's keep on moving. We have initial dropper.ps1. This one is again suspicious that we really want to investigate. So we have a few leads here, right? Let's dig in a little bit deeper. Let's convert the base 64 to regular payload, a string. So we have a payload here that actually gets the property from an registry key stored in S value, where it splits it on space, performs some conversion, and performs an execution of the variable. Looks like some kind of a payload that's using registry to defense evade. Cool. Let's dig in a little bit more deeper. So another use case that this really represents is now you could have a different tool altogether to query, but since this is a lab environment, I'm just using a different API in Elasticsearch, that's SQL API, to query directly SQL data from Elastic. And this time I'm querying all the network events to identify if partial is making any network connections as well. So what we'll really query is source IP, source port, destination IP, destination port, for last 90 days, limited by 10,000 records. And we will again normalize it into a data frame. And since this time it was already SQL, we are not using Spark again. We got 10,000 records. The data frame looks like this. And let's do a unique source IP to unique destination IP count to figure out if there are any suspicious destination IPs or the number of destination IPs to which the connections are being made. This is really interesting, right? Because you have so much of capabilities here, and this doesn't limit to just stack counting, right? You can do a lot of different things. We could build graphs where to figure out if there are outliers or not. We could do a lot of different. We could do a scoring of different IPs based on the amount of data that we have and the reputation websites. So there's a lot of different things that you really can do and identify if there are more investigative leads or not. So what we have really done here is clustered them, and interestingly, we have one source IP that's communicating to only one destination IP in all 1,000 records. Okay. Now I need some kind of an enrichment power, or I need to query, say, VirusTotal or any reputation website to figure out what's the really this, right? What's the external reputation of this IP? So for this, I'm really building an VirusTotal function and passing the IP to get the malicious score of this IP. Now, since I've got this, and this looks very simplistic, right? This looks very simplistic as a use case. But imagine a case where you had 10. This is imagine a case where you have 1,000 different destination IPs, right? Doing bulk analysis becomes a challenge when you have data sets that are very large in number, that has very unique points and are large in number. So this problem could be easily solved via this environment, where you could loop in through data sources again and again to figure out what's the malicious score, store it in a separate column for your investigation, do a filter on top of it, and that would give you a very good investigative lead if this lead has to be pursued or not. Okay. We saw that data enrichment gives us it's a malicious 14 score. Definitely a lead that we should pursue. So moving on, let's explore another use case where I want data visualization power, right? So I'll use again the same data set, the SQL API of Elasticsearch, but this time I'll call just timestamp, process name, and process command line. And what I'll really do is get all of this data and normalize it again into a data frame. But this time, just normalizing is not enough. I will need to parse it, because Elasticsearch returns data, as you can see in the top. Elasticsearch returns data in timestamp format, which is not ideal for me. My requirement is I need a date format for performing these kind of operations, for plotting it per day. So what I'll really do is I'll do some data transformation, and that's another use case, right? An environment that doesn't limit you to convert data from one form to another, or consume data from any format and normalize it, right? So what we have really done here is created a new column, timestamp passed, and we have converted into datetime object. And now we'll use datetime object to return date, which we are storing into a new data frame that we'll use for plotting. Data visualization could be done via a host of different Python libraries that are available at your disposal. Some adhere to some use cases, some adhere to more of a generic environment. For this use case, I'll just use Plotly. Plotly is a data visualization platform, a library. So the data frame that we'll use here is this. It's basically a reset index was performed on this, so we have index that is resetted, and the zero column actually indicates the count, right? So this partial command line was executed 4 times on this day. Okay, so we have called Plotly, and now what we are really doing here is just plotting it, right? It's as simple as that. X is timestamp, Y is count, and bar stack is command line. You get a beautiful graph out here that shows that there is a baseline of a command line being executed every day. You could easily ignore or choose to even chase this, right? Because this might be a beginning activity that you really want to chase, or there are outliers or anomalous executions of suspicious commands lines that were never observed, right? And you could really want to chase them as well. Okay, so we have done a lot of different things, but what we really want to do here is, before exiting, I want to create some escalated use cases for my other shift people to actually work on it, or these cases to be pursued later. So without context switching, again, what I can really do here is call in a case management API. For example, the Hive. I'm using the Hive here since it goes best with Elasticsearch in a lab environment. And I'm creating a new case, right? I'm giving it a title, I'm giving the description, some tags, defining what was malicious, defining what was suspicious, and putting it all together and executing it so that it goes as a case, and I'm good to go. So this is how different use cases actually tied into this notebook, and this is how I have learned to amalgamize the different tools that are available in your defensive arsenal or your defensive layer program to bring the power of all the tools into a singular place and use it as an human analytic driven tool. But what you have really achieved here is we now have noted down a notebook that denotes what was the investigation route that was really taken to actually achieve at the results, right? This notebook could really be just downloaded or exported and shared, and it's that easy to share a tactical report of what happened and what was the investigation performed. Also, if you develop this notebook carefully without using a lot of constants, you could use a lot of variables to run this notebook again and again as a reusable component or a report to generate your weekly report, daily report of anomalous or malicious behavior. And this would actually give you ability to draft your own notebooks, right? There could be different notebooks that you can draft out of this data analysis, investigation, response, be it anything. A lot of reusable code could be wrapped into a Python function, separate Python function based on your environment, right? We learned a lot about different Python libraries available. I love Mystic Pi, offers a great deal of library functions that I can use in everywhere. But suppose, say, I want to write in my own library into my own environment that suits for a different set of tools altogether. You're free to do it, right? It's a non-limiting environment. What you really want to do is basically make this Jupyter notebook an API-driven service, right? You can use SageMaker services on AWS, for example, to make it an API-driven notebook, right? Now, when you have an event, this notebook could be called as in a pipeline. You can do more correlations, or I can simply call in, say, an EDR tool to do containment when a certain threshold is met, right? So all of this is just limited by your creativity, and that is why I feel it's truly a canvas at your disposal that you can use to achieve whatever your analytical goal is. With that, I would wrap up this talk, and it was great being here. Thank you.
Hey, thanks very much. That was like awesome talk, and I think it really illustrates one of the great things about notebooks is the amount of things you can bring in. Like you compare it to like traditional SOC tools, and you're kind of stuck with what you have. But the fact that you can bring in APIs from whatever you want, really, facilities, libraries, that was like a fantastic talk. I'm also delighted that you're a fan of Mystic Pi. I think, I could see, Virus Total. Maybe we could have a Mystic Pi thing doing that bit. Yeah, that was awesome. I'm just going to check. I've been trying to solve some resolution problems. We're trying to see if we can stream this at 1080p, but I don't think in the live thing we can change it. But maybe tomorrow we can try and increase the resolution. Let me just check for questions.
So I do have a question. I think that's the one that is in the channel. So maybe I can just ask it directly. First, sorry, what? Yeah, what was that?
No, please go ahead.
Yeah. So first, thank you very much for the presentation. I think it definitely I like the how to use one interface for a lot of these things, from the exploration, visualization, cleaning, all the way to case management, and how you're linking, how easy it is to do it with tools like the Hive, right? For example, super cool. I think that a lot of security products are trying to do that, and it's hard to accomplish. And it's just interesting to see something like this happening with an open tool, right? Like a Jupyter notebook. So my question was, what other tools or libraries do you use to scale some of your like data exploration and visualization. Does Plotly do well? Like, does that do like a good job showing what you want to do when you are actually querying a lot of data?
Okay. So one of the approaches that I really take when I'm working with a very large data set is I tend to first figure out the statistical summary of that data before I'm actually trying to plot something. So for example, when I have say 1,000 records of IP addresses and plotting a network graph out of it would take up a lot of. It's a very data intensive process, right? It requires you a lot of to have a lot of resources at your disposal to at least plot it and scale it into an environment that's really realistic, right? I could have say 25,000 endpoints. So in those scenarios, what I really do is take out a statistical summary of that data before plotting it. So for example, as shown, as I showed, I really had just one IP address that was unique, right? And in that cases, that is how I reduce the amount of data to something that's more processable and is more scalable.
Got it. Awesome. And have you used the so I used to use when I used to work on the Helk project, I used to work with the Hadoop, I think it was called ES Hadoop library
Hadoop,
for
yes.
Elasticsearch. Do you use some of that to kind of like automate? Because I know that the Elasticsearch Python libraries, like the DSL ones, I think they do some paging, like pagination, I think it's called, right?
Pagination.
Pagination, right?
Yeah.
But then the other concept is like distributed data, right?
Distributed data at scale.
Yeah.
Right?
Have you used that with
Yeah.
Elasticsearch?
Yeah, even to be honest, I really tried your project, the Helk project, and I have used the Hadoop ES component out of it, but I
Nice.
haven't, to be honest, I haven't tried it on a personal setup.
Got it. Got it. So you could say that based on your experience, by using the tools that you showcase in your Jupyter notebook, that's a good way to tackle real scenarios like in an organization, right? As long as you, of course, are a little bit targeted when you try to scope your analysis, right? Because if you want to show 10,000 endpoints, data from 10,000 endpoints, let's say, or 100,000 endpoints, that is going to be kind of crazy, right?
You really need a lot of resources. So what we really do is scale all of that using cloud, right? So all of this computational power, we use instances on cloud to build our Jupyter VMs, and that is where how we scale the computational power there.
Mm-hmm.
Got it.
Yeah, we've experimented a little bit with Dask, which is a kind of a even if you haven't got like clusters of VMs available to you, it at least allows you to use like multiple CPU cores on your machine, which Python is not typically very, very good at. I'd also say like libraries like Plotly and Bokeh are actually surprisingly good at doing visualizations with thousands and thousands of nodes. It doesn't, I mean, once you get into the hundreds of thousands, it starts to get a bit kind of creepy. That's probably where you, not creepy in a weird sense, but creepy in a like creeping along sense. It's where like visualizations like Graphistry are kind of, that can obviously handle, because it's got a muscle of like GPUs at the back end that can handle like, unfathomable amounts of data, things that would bring your notebook to a crawl. I also had a question about the kind of language agnostic query stuff. I was really interested in that because we have like in Mystic Pi a bunch of different data providers. Some of them use KQL, some of them use SQL, some of them use their own kind of like query language. And we haven't done anything about trying to normalize that thing. And I noticed you had a couple of cases where you brought stuff into Spark or used the Elastic interface to provide like a SQL interface to. But do you have any more kind of thoughts about that? I mean, we thought about that. It'd be nice to have like a general query language that would just work for everything. I mean,
yeah, absolutely. That would really be awesome. But what I really see is there are a lot of different query languages, but the lowest common factor, if I take the LCM of all of that, is basically just an ability to run a single search, a keyword match, right? And running a keyword match would return you a lot of data that really don't want into your pipeline. But now when you have a data set back into your pipeline, you have enough capability to actually process it however you want, because now it's in a Python environment, right? So I have the capability of just running a simple keyword search through the API. And now since the when data is returned back into the pipeline can do the processing that it needs, or remove a load of chunk of data that's not required. And that is how I really try to work to make it agnostic platform, right? Not depending on a single tool's query language.
Yeah, I thought that was really nice, like bringing it into a kind of an intermediate store, because like if people know any query language, they probably know SQL. So that's like as a lowest common denominator. That's a kind of a nice thing. I wonder whether we could think about doing stuff like that. I mean, currently we have like, you can use the raw query languages, or you can use like built-in queries which are sort of parameterized. But obviously, you can't build a built-in query for every case. So it's how do you handle those cases? But that might be a thing where you could just say, well, given a table, I just want to find a keyword match, or maybe this column, and maybe that's generalizable. You could bring it into some intermediate store, and then use SQL or maybe pandas to query it. That was cool. So somebody's asking, can we get a link to the code?
Yeah, I'll just put it on share with you guys, and maybe you can put it on the website.
Yeah. Maybe do you have it in a GitHub repo, or you have it just as a document locally in your computer right now?
Currently, I have it locally. What I'll really do is pass it on.
Okay. Yes. So if you can pass it to the Jupyterthon speakers channel, right, and then we can put it in the. Which reminds me of what we need to show in here in a second. So thank you very much, Saksham, for your time and for willingness to share your research, man. I really appreciate it. I'm pretty sure a lot of people that wanted to jump into just the analysis first and walk through a process. I think that this is a really cool, walkthrough, right, with the notebook. So thank you, man.
Thank you.
One thing I said before you upload your notebook, like you might want to reset your VirusTotal API key, and
sure. Anyways, I've already changed that for demonstration, so it's fine.
Yeah.
Okay, thank you.
Yeah,
okay,
thank you.
Awesome. Thanks very much. That was fantastic.
So now we need to take a break for 30 minutes. But before that, I wanted to share, I know that we've been talking about like there are notebooks that could be shared through the site. So as I mentioned before, the Infosec Jupyterthon site is hosted in GitHub. So there is a GitHub repo behind it. And the way how you get to that is by on the top of the site, you can see repository, and you can also open an issue if you want to share something that probably could be fixed. And then in here, right, when you go to docs and then 2022 sessions, there is where we're going to be adding some of the notebooks after the presentations, if our speakers would like to share some of that. And if there is any data that also could be shared, then it could be done through this GitHub repository. Okay, so just FYI, for example, Ian already has his talk for later today. So just keep an eye on that. And as I mentioned before, a break starts right now for 30 minutes, and then we go back at 1:30 p.m. Eastern time with Ryan from SecureWorks. Pretty cool. He showed me a little bit of what he was doing in here, and it's really cool concept that even myself I'm not as familiar with, and this is something that I believe people might find very useful while using notebooks. Magic tricks with IPython magics. So see you at 1:30 p.m. in 30 minutes.
Okay, one thing just before everybody disappears, one thing people might want to think about over the next day, and then maybe we can talk about it with the speaker panel, is Roberto and I talked about under the Open Threat Research umbrella having a kind of place where people could put notebooks. So like notebook examples, maybe have some kind of indexed way of searching through them for, inspiration or like, code examples. So have a think about that and think about what that, what you'd want that to look like, because I think that's sort of an interesting idea. Like people like from conferences like here, or occasionally you see people posting stuff on Twitter, like, I've got a cool notebook with this. It'd be nice to be like, rather than to have to search through your history of Twitter, like to be able to, go to somewhere and find that and retrieve it. So yeah, kind of share your thoughts on Discord, or come back to the final session where we can maybe revisit that. Anyway, let you go on with lunch or whatever.
Thank you very much, man. Appreciate it. Yes, we definitely need to talk about that.
Yeah, yeah. In the spare time we have, we can do that.
All right.
Okay.
Awesome. Thank you. And would you mind playing your music, Ian?
Oh, right. Yes. Let's do that.
Yes. Thank you. All right. See you in 30 minutes.
Okay. See you. So we're heading back. Got a minute before we kick off with the next session. I just realized that I left my player happening in another room. I'm just going to close the door. Excuse me, not very professional. Okay, back in the studio. Okay, and to Roberto to introduce the next speaker.
Oh, I'm introducing the speaker. Yes. sorry. I thought that you were introducing the speaker, but yeah. So let me open my stuff in here real quick because I had a couple things that I wanted to mention as well. Meanwhile, there you go. All right. Sorry. Also, I was trying to make sure that I have all my tabs available. Yeah. So, welcome everyone. First, there was actually a comment about the music, which is actually very soothing, right? It's like a very slow music that, if I'm not mistaken, Ian, that's your music, right? Like I wasn't sure if that's something that you created or.
Yeah, well, we were looking for copyright-free music to kind of play at the intervals, and
Yes.
it is my music. The bitter irony is like there's tons of copyright-free music, but it's all available from services you have to pay for to get the music. So that's not really proper open source, is it? That's
awesome.
So my stuff is open source.
So
the danger of sending people to sleep, but at least it has something.
Man, I felt like I was in a massage session. I closing my eyes and feeling comfort. Yeah,
it's good to have people relaxed.
yes. But thank you. So now we know. So Ian is the one behind the music as well. So, so now let's move to this next talk by Ryan Kopp from SecureWorks. He's a principal information security researcher, and he actually works for the Counter Threat Unit, CTU, for the Secure Works company. And Ryan, I didn't know much about Ryan in the past, but when I talked to him I would say maybe a year ago, when I met you, like actually personally met you, Ryan, it was cool to hear that there was a lot of concepts that, you know, we were kind of sharing open source, maybe even like talked about certain things in the past, and it was great to hear that, you know, those concepts were super helpful also, you know, for you and for others in the community, and vice versa. Like myself, hearing some of the things that were super useful, it was pretty cool. And Ryan is also someone that I enjoy to talk about, not only, you know, let's say about Jupyter notebooks, but anything in general when it comes to development, attack simulations, infrastructure, automation of things with Terraform templates. Like, the amount of knowledge that Ryan has in several areas is very impressive as well. And I'm super lucky to be able to also talk to him almost every week on Wednesday. So, you know, really happy that you're, you know, also able to join us, Ryan. And I'm so looking forward for this one, because I'm not that familiar with how to create your own, I guess, Jupyter, you know, magics. So take it away.
Thank you very much.
Yeah, I just need to apologize to Roberto. It was meant to be me introducing you, Ryan. So,
Well, I think you did
I'm really looking forward to
Loved
this.
it. That was extremely kind.
I
Hope I'm coming through loud and clear.
Yep.
Good.
All good.
All right. So let's get started here. For some background, I've been working at SecureWorks doing DFIR work for about 10 years now. Also focusing a lot on threat hunting as well. I'm very passionate about open source. I contributed the resource graph driver to Mystic Pi, the Azure provider to Stratus Red Team, and some other forensics tools to popular open source projects. But Jupyter really is one of my great passions and areas of focus. So I'm here today to talk about sort of a lesser known kind of arcana, a weird feature of Jupyter notebooks that you've probably seen and typed in during a tutorial and never really understood what was happening behind the scenes. So we're going to dive into these little mysteries here over the next 30 minutes or so. This talk will kind of be in three parts. We're going to do the really high level overview of what IPython magics are. We're going to explain how they work by route of creating our own. And then I will hopefully demonstrate three concrete use cases for using IPython magics to automate your security analysis workflow. I think everyone will find quite helpful. I did put a link in the Discord to Binder Hub for this project. It's up on GitHub. I pre-built the image before the talk. It seemingly is working just fine. So if you want to follow along at home, feel free to go check it out on Binder as well. So without further ado, if you've ever noticed that a Jupyter Notebook file extension is .ipynb and wondered where that came from, that's because in days of old, Jupyter notebooks were called IPython notebooks. They were kind of synonymous with each other. The I in IPython stands for interactive. And really the mission of IPython, and by virtue, Jupyter and notebooks in general, is to have a very interactive experience. It's not just software that you run like a tool. It's more of something like your shell, a place to be and to interoperate with lots of other things, native, Python, or otherwise. So Jupyter notebooks and IPython magics implement a special syntax that tell the interpreter whether some line of code should be evaluated like normal Python, or if it's the special IPython syntax or command that you want to run that will leverage these sort of features that unify the browser, Python, and the system you're running it on. So I'm sure everyone here has at some point in the past used the bang character to interact with your native shell from inside of the notebook. This is in fact just a special kind of what they call a magic. This is that, again, a special syntax that indicates to the interpreter, hey, we're doing something different here that's not actually syntactically valid Python, but I want you to treat it like it is and start interoperating between things like your shell and Python objects as if they were one and the same, right? So you can not only just call them from notebook cells, you can also use them in things like variable assignments, anywhere you can otherwise do a valid Python statement. You can usually do a corresponding magic. And also like a shell, another one of the special magics or syntax are these question marks. which is the IPython version, like a man page, right? It pulls up a doc string for you from whatever Python object you're looking at, and will present it in your notebook to give you that very interactive back and forth experience. You can answer questions about what it is you're looking at without having to leave the comfort of your notebook. But the part that's the most interesting are this special syntax here, which is the percent signs. Kind of looks like a macro syntax from other languages. And these are user-defined magics. This is really where the fun happens, in my opinion. There's really two kinds of magic that are available in the notebook. The first are what they call line magic, and they use the 1% sign syntax. This, again, just tells the interpreter, hey, we're about to run something that's unique to our notebook. And in this case, if we do the percent sign and the word magic, you get the giant man page, effectively, of all the different magics, what are available, and so on. It's so large, in fact, that VS Code does not want to render it. Similarly, there is the 2% sign syntax, and this is called a cell magic. And the only real difference is that instead of working on a single line of source to evaluate, cell magics work on the entire cell in the notebook. Most of the time, these will be implemented in or interact with things that are sort of meta Python or parts that are part of the notebook ecosystem. So your browser manipulating JavaScript, manipulating the DOM, whatever that might be. So anything inside the cell body will get evaluated and then we'll render for you in your notebook. In this case, for the HTML magic, which is pretty cool. But most magics as well, the cell magics at least, they kind of operate on both. They will generally look at the top first line of the cell and then interpret this kind of like a command line tool. And then everything else that follows is kind of the body of your cell magic command. So in this case, we're going to write a file called foo.txt, and we're just going to put in some arbitrary text from whatever is in our cell. Nice and simple. So how does this work? Well, the function signature for a magic could not be simpler. You either send it a line of text, string, you send it a cell, which is going to be a line and the cell content, or you can have ones that I'm calling combo magics because there's really no terminology for it, but these are the same magic term or command that can be used as either a line or a cell, and your behavior will change accordingly. So the easiest way to create your own magics, it's really quite straightforward. Any function that has, again, the signature that's kind of described up here can be converted into a magic via a simple decorator. So we can say from IPython core magic, register a line, a cell, or a line cell magic, put it on any arbitrary function that you want. You run that. Magically, you now have a magic. And again, it will behave the way that I was just describing, parsing the line, parsing the cell. And you can see based around the return values that, again, what you put in there will get sent to your function. You can do arbitrary things. Anything you can do in Python, you can do there. And then ultimately, it's up to you what you want to return and present back to the user. Those can be Python objects. You can print a screen. You can display something in a cell output, kind of whatever you want. It's kind of like it's like a middleware where you have Python you're going to call from the notebook, do something arbitrary, and then return it. And before you do, go back into your Python function to like manipulate the output or the return value, and ultimately return control back to the notebook. So if you look at it in the form of a function, it's, again, pretty straightforward. But magics are much more powerful when you create them via a subclass. So there's a series of classes and decorators inside IPython that you need to kind of work with here. But the basic premise is that you define a class that's for your magics, and you can define certain methods of that class as either a line magic, a cell magic, or both. But the benefit of doing it as a class is that you get class attributes. You have state that you can work with. Most interestingly, when you create any of these magic subclasses, there's going to be this special object, self.shell, that actually has the lexical scope of the Python namespace of the notebook that you're in. So your magics can reach out from the cell it's in, read from other variables, set and assign other variables, do almost anything that you need to do on the Python side, and access that, again, from inside this magic here. So that's exactly what we're going to do in this case. We'll define a line magic. It is going to basically take whatever the value that's passed to that line, look it up in the notebook namespace if it already exists, and kind of print it back to screen. And the only difference between this and the function version, again, besides kind of the state, is that you then just have to tell IPython, hey, I made a new magic class for you. Can you please register this so it can be used? We can do that and then use the load or reload extension syntax here to load it up. And now we have that as well. So our variable here is foo. This could have been defined in any other cell in the notebook. We're going to say to our magic, hey, I'm going to pass you the string foo. Now it goes and looks it up, proves that it can read, interact with other arbitrary Python objects in the notebook, and then returns back our nice little text here. Right? Nice and simple. So I mentioned that IPython is more of a shell than, say, just a custom programming language on top of Python. It has generally a Unix-like philosophy in that it kind of expects things that you pass to magics often to be command line, as if you were using it in a shell, but you're calling Python instead. So it does provide you some convenience functions that will, decorators here, that will handle argument parsing for you based on argparse. You can do it this way. You can also use regular argparse or more sophisticated CLI parsing libraries if you want. They all work just as well. But ultimately, we're just showing here, like, yep, these magics can effectively become their own little command line tools that we can use in our notebook, and everything works kind of the way that you'd expect. So to be very clear, like, why am I showing you all this? What's the point? From a pure software development perspective, IPython magics are an anti-pattern. And that's because this is a meta-linguistic syntax. It's not technically valid Python. That macro is not a real operator in Python world. So you're already kind of escaping the bounds of normal, regular, expected behavior. And there is some of this behind the scenes machinery that interacts with your notebook, the Python interpreter, and again, whatever else you want your magic to do. But ultimately, the most important thing from the Zen of Python is that practicality beats purity. And from my experience, I think the same for many folks. Having access to these magics actually enables an incredibly convenient, intuitive, low-code type of experience for users in notebooks, which really gets them to harness the power of the notebook in a way they might not be so comfortable to do it as a regular Python function call or otherwise to write and implement themselves, if that makes sense. So when magics make a lot of sense is going to be for anything that's like interactive, highly iterative and ad hoc. So data analysis being kind of the obvious one. If you've used Mystic Pi before, then very likely you've also used things like KQL magic, which give you this sort of ability to just pass in a search query in the native query language into a cell and get back results as a pandas data frame and not need to know what Python classes behind the scenes are being instantiated to actually serve that request. It is like, I put in my query, I get my answer. And for a lot of users and security analysts, that's more than enough for them. That's what they're trying to do. It just gets the job done. So what I'm calling attention to here in the table is there are some areas where the magics are particularly useful, and I want to demonstrate a couple of these over the next couple minutes here. So there's a really amazing open source library called Road Tools that was written by a researcher named Dirk-Jan Malema. And Road Tools is an Azure AD enumeration toolkit that basically queries a bunch of internal APIs in Azure Active Directory, pulls back information about the tenant, so users and service principals and devices and role assignments and all that stuff. And it nicely kind of collates all this into a SQLite database that you can then use for offline analysis. That could be for forensic purposes to like analyze a tenant for an intrusion, or for offensive ones to find service accounts, service principals rather, that you want to use as part of your attack, whatever that might be. But by virtue of saving all the data from Road Tools into a SQLite database, we can leverage the really incredible IPython SQL magics to interact with that SQLite database from inside of our notebook and to great effect, in my opinion. So what you can actually do here is if you open up a terminal, we could authenticate to to road tools, and then we can use road recon gather to go actually fetch the commands, or fetch the data from Azure Active Directory. Let us do its thing here. All right, so took 6 seconds. It made almost 2,000 API calls. No big deal. Azure AD will not throttle that, weirdly. And then we can load up our SQL magic and connect to the database that Road Recon creates, which by default is called roadrecon.db. From this point forward, anything under the cell magic for SQL will be interpreted as a SQL query, and then results can come back to you as Python objects. So in this case, we are listing all the tables in the database for Road Recon. So these are things that should correspond to Azure Active Directory objects and the linkages and relations between those. Pretty useful by itself. But the IPython SQL magics have wonderful support for things like pandas data frames. So you can actually very natively and quickly convert that result query into a data frame object that you can then explore and use like any other pandas data frame if you are more comfortable doing your analysis in the pandas API versus in, say, SQL query syntax. So to set up the next example and to highlight one of those use cases that's like very tangible for things like road tools, let's look for any service principals that have had either a password credential or a certificate credential added to them. This is a relatively popular offensive technique that was made really popular by SolarWinds. Effectively, you're adding a backdoor secondary credential that lets you impersonate that service, or actually log in as that service principal in the victim tenant. And road tools stores nested arrays as just a JSON string. So we can say, hey, any service principals where they don't have an empty string, these have credentials added to them, which is probably bad. We should take a look at that. You can find that all out. You can do your kind of detection logic and exploration here from in the notebook and using the magic to fetch that data. So the next example has to do with report automation, which is not particularly sexy, but it's extremely important to scale and have consistent outputs from your SOC or your analysis process. So what we're going to do in this example is we're going to create a new magic, a custom magic that's called Jinja magic. And this is just going to render a Jinja template as you would kind of normally for using a templating language like Jinja. It's going to produce markdown text, and then we're going to render that text in the notebook. And we're going to combine the service principal data from the previous example to actually render a nice little report that highlights the fact that, hey, these service principals were compromised. You should look into it. Here's what you can do about it. So again, this is the class version of creating your own custom magic. We have one argument we're going to pass in, which are just the names of the variables in the namespace in the notebook that we want to pass into our template to render. We parse those arguments. We fetch those variables from the namespace. We pass them into our Jinja template. We render it, and we display the markdown. And again, we register our magic class. And then what you can end up doing is have notebooks that kind of look like this. You'll have a Jinja magic line that's going to say, hey, these are the variables I want. Everything in here, this syntax, this is all what's called Jinja, right? So it's a templating language, but it's going to have access to this object that had our service principal data from the previous example. So this here as just a nice little template. We run that, we'll spit out a prettier markdown summary of the service principals where you can add instructions and do anything else you want to really call out to the analyst. This is what you're looking at. This is why it matters. This is what you can present to a customer, add it to a ticket, whatever you want. So we get a lot of mileage out of a magic, literally not that much bigger for our internal version than this. But you can then turn notebooks into some sort of data fetching and report generation sort of end-to-end workflow by using these magics very trivially. And if you want to modify the template, you can just fiddle with it in the cell here, rerun it, and now it'll update and show you what your new template looks like. But the last thing I wanted to share is a little bit more novel. So Road Tools is super powerful because of the data that it can bring back and store for you, and it's really incredible. Super great tool. But Road Tools is actually limited to just the information that's available on the legacy Azure AD Graph API. Wouldn't it be really cool if we could have something kind of like Road Tools, but that used perhaps the Azure CLI instead to fetch things from from Azure Resource Manager or from the modern graph that we could then interact with and store and analyze in the same way we might with road tools data. So that's exactly what we're going to do. We're going to do here. Luckily for us, the Azure CLI is actually implemented in Python and is built up of all the constituent Azure SDKs for Python for each of the various cloud services that Microsoft supports. And it's a massive command line tool, so much so that Microsoft had to create its own CLI library, parsing library called knack, in order for the many, many, many layers of nested subcommands in the Azure CLI to function. This offers to us a kind of a quick win, a kind of a cheat for writing a custom magic that wraps the Azure CLI, leverages the already in Python argument parsing from knack in the Azure CLI, and then just consistently will return pandas data frames for every Azure CLI command, as opposed to just returning JSON or whatever other outputs that it kind of supports here. So for this example, we're just going to use the function version of our magic. It's a line magic called AZ, just like you type on the command line. All we have to do is take our line. We then will grab the argument parser object from the Azure CLI. We will then invoke it, do some light handling on the status codes that come back, kind of some quirks of how these command line tools work. But importantly, anytime we get back a list of dictionaries, i.e. from a JSON response, we're going to return a data frame instead. And this just makes it really easy to quickly iterate on our result set and get it into Python and into pandas for us to kind of do the work that we need to do or collect the evidence that's relevant. So we can run that and register it. Again, all you have to do now is type AZ to invoke your magic. Hey, it's the Azure CLI, just like you'd expect in the command line. You can use it to authenticate. So we can do a device code login here. I realize that you guys won't see this on your screen, but I'll log in very briefly. All right. Regular device code login complete. Hey, these are the subscriptions I'm currently signed into. And then what becomes really fun is that your Python commands, so your IPython magics here, they're identical to your Azure CLI commands, except you can now use them anytime or anywhere you can do a Python statement, and you always are returning a data frame. So to get almost the same information as what road tools fetched before, we can just do an AZ80SP list, so list all service principals. Very convenient. We now get back our data frame, and we can now do with it whatever we would want to, because again, we have this pandas object as our results here. There is a little bit of extra special syntax above and beyond the magic stuff that's kind of useful to know, but again, kind of hacky. And that's that any variable that you pass into a line magic, if it's prefixed by the $, this will do variable expansion like Bash would. So in this case, we're going to iterate over all the app IDs in this data frame. This is a trivial case. You already have that data in the same data frame, in fact. But then we're just going to pipe it effectively. We're going to connect it to a different Azure CLI call here to go fetch more verbose information about that service principal. So you can reference variables in things like loops and all that from techniques like this. But again, the benefit of doing it the Azure CLI way is that you also get access to anything the Azure CLI can do. So to prove some examples of that, hey, if we want to go to a tenant, list all the cloud providers that are registered in that tenant or in that subscription. Again, it's just like any other Python call here with the command. Now we get back our nice data frames. So a really common use case, hey, what's happened in this tenant? Let's go to the activity log. Why are we going into the portal? We could just do it from the notebook now, right? It's just by passing in what would be the command line command for it and get data frames back, do your analysis. And then one of the lesser known features of the Azure CLI as well that makes this super duper useful for forensic purposes and all sorts of research. Even though the Azure CLI does not really support the modern beta like Microsoft Graph, for example, under the hood, there is this utility function command called AZ-REST. This is just an arbitrary REST API call with some additional logic on top to like exchange tokens for the right resource. But in this case, we can say, hey, Azure CLI, go read directory audit logs from the Microsoft Graph, pass in whatever filters you would normally kind of want to do, And now, even though the HCLI doesn't really have the ability to do this baked in, it's very trivially easy to do by, again, just knowing kind of how to construct your magic command. So that's kind of a whirlwind tour. I hope you kind of see what the advantages are of magics as a way of blending things that behave kind of like command line tools or literally are, but the ability to wrap those and return objects that are way more conducive for analysis inside the notebook, and otherwise just make your life quite a bit easier for ad hoc and explorative stuff. So that's it for me, Roberto. Are there any questions from the Discord?
Hey, thank you, Ryan. That was awesome. I kind of enjoyed every minute of that. We do have one question.
Sure.
Might have one myself. So it was like, are magics actually a middleware, or are they a feature of the IPython kernel? Can other kernels implement them?
So that's a great question. The IPython magics here are implemented by the IPython kernel. If you were to use a radically different kernel, like, for example, the new interactive notebooks from Microsoft, because you really want a notebook in F# for some reason. I don't know who those people are, but I'm really glad they can do it. Then it's up to that kernel to implement the same behavior from that special syntax that wouldn't necessarily translate to other arbitrary kernels. That being said, if you are writing your own custom kernels, like using like meta-kernel or something like that, they usually will support out of the box the magic syntax if you were kind of using a lot of the boilerplate stuff. So no, it's up to each kernel developer to do it. But for 99% of the users probably in this call here, who are only ever going to be inside IPython, just know that this is available to you. And again, but it's not part of the language, but it's unique to the notebooks.
Okay, that's cool. Just checking.
So I had a question, if you don't mind. I mean, well, I guess we have maybe some other questions coming, but so maybe kind of thinking from the basics, I guess. So it seems that a magic also, like, it becomes this, like, wrapper around functionality, right? That you want to have right as when you are writing code, your Jupyter notebook and all that. What is the difference with a Python library that you have multiple functions that become also wrappers to, let's say, to the Azure CLI, for example?
Yeah, so if you want to compare how you'd write something in pure Python versus how you might write it in a CLI, and how you then write that CLI in a magic, going from a CLI to a magic is almost for free. Any CLI tool can trivially be converted into a magic if you just send it to subprocess and get results back, right?
Okay.
The advantage would be, like, if you're an end user and you want to make a KQL query against Sentinel, you don't have to know what to import from the, Azure Monitor SDK or the log analytics library or anything like that. You just know, I just do this magic, and now boom, any command I send in here will just magically return your results you'd expect. So it's great for ad hoc and iterative stuff. If you're writing actual software that you want to run and be really stable, I wouldn't build my house on top of magics, but for exploratory work, they're invaluable. Big time saver.
Yeah, magic houses are fun though.
So the way that we actually author our reusable notebook templates at SecureWorks, we do in fact use quite a lot of magics. So we use Jupytext for a plain, for just a straight up markdown document is actually the notebook that gets run. And all an analyst really has to know to add new content to one of those playbooks is, do you know the query language, the query that you want to make? You put it in a cell for our query our magics to go fetch that for you. And now that's it. They don't have to worry about, again, any of the other Python plumbing to, semantically fetch and manipulate the data that they want. It's great.
Yeah.
Awesome,
So,
man.
I saw a few things in there that I know you've already made like really valuable contributions to Mystic Pi, but I saw a few other things like, God, that would be really cool to have. Having that, also thought, I was talking about pivot functions in Mystic Pi earlier on. It might be nice to kind of have those automatically create magics, so you could just have like an IP magic that has all the functions.
Yeah, and in fact, I mean, you guys in Mystic Pi already do have a bunch of useful magics I didn't explicitly call out. So you have the IOC magic, which is a text extraction one where you can just paste in arbitrary text from a report, and it'll spit back out a Python object that's, here are your IPs, here are your hashes. Trivially easy to do that for things like lookups for virus total. Anything that's kind of cyber chefy, you could probably do as a magic pretty trivially, which is nice. Other ones that we didn't implement in this example, but we talk a lot about doing things like a Jira magic. So like if you have a user runs into a bug or a problem, right there, make a new cell, tell us what your problem is, have the magic package it up for you, send it somewhere else, and you start diagnosing or debugging or add it to a work queue or something. Like, it's just nice to have, like a shell. It's a custom command that you can run, which is great.
Very cool. Very cool. Yeah, you ever experimented with kind of like pipelining magics? So I know you can, from a magic, you can persist stuff back into the namespace. So like create a data frame inside a magic. But that might be quite a nice kind of syntax for, oh, I want to do this, then I want to do that. And they kind of like one just says, oh, there's a result already in the namespace. I can use that. That might be a nice.
We have an internal magic as well that we use for evidence kind of management. So let's say you have a data frame. You can do in our language XDR investigations attach and point it to the variable of your data frame. It will then look in the data frame, find the appropriate column with the unique identifiers for whatever data is relevant there, and then we store that somewhere off in the side. Think of it kind of like a git add, right? But for your investigation. And you can keep doing that iteratively until you get to the end of the notebook, then just do XDR investigation create, and it will read all those from that persisted state, create your, all your evidence is linked to effectively our case management component of our application. So it's super duper useful as a workflow driver for sure.
Cool. Yeah. Something we should investigate more. We did experiment a little bit with some magics, but haven't. I can see. It would be, I think, relatively easy to programmatically create magics based on some API set.
Absolutely,
this might be a nice thing to explore. We still have a little bit of time. So if there's anything else you want to kind of talk about, everybody was kind of fascinated. I think we got like 5 minutes to the next talk.
Yeah. So I have a question, if you don't mind, be real quick. So one of the things like this conference was also put together to bring different like ideas, like creative ways to use notebooks in our field, and of course that involves part of the threat research methodology involves some of the attack simulation, right? And when you start talking about how you can start even identifying some discovery, I guess, queries, right, that you can use with raw tools, but then you can also have like your Azure CLI magic. So I hope that if people that are watching this, and some of them have some of the the offensive background, like the offensive security research background, I think that it's also pretty useful, right? Because a Jupyter notebook would allow you to have the magics that would allow you to have your process that if you want to do discovery, and then you can save like all that, and you can use it for training, for showing a flow into how something could be done. So many possibilities, right? That this could be used for, not only for defensive side, right? I think
for also offensive stuff, what we've done in the past is we've had effectively an SSH magic, which is things you run the magic execute on a remote system. So your notebook is sort of in one place, but you can drive it again from inside the notebook. And the second would be a Docker magic. Basically, you're piping to Docker run. So you just pick your image, anything you send in the cell will get run by the container and come back. So let's say you want to run AAD internals, but you're running Python, and maybe you somehow containerize that or something, right? You can have that interop without having to change kernels. You can just call to it from, in this case, from your magic, bring it back, and then just move along with your notebook the way.
Exactly. Yeah, I love that because for attack simulation plans too, like there is one. For example, I've seen some people using, containers, right, to do, for example, like initial access techniques. Like how can you simulate the sending an email, and that requires to have like a server, like a couple of applications that probably are not directly integrated with a Jupyter notebook, but it seems to me that when we talk about containers, then you open that door to so many different possibilities when it comes to how can you drive even your own initial access attack simulation with your notebooks, right? So yeah, this is pretty cool. You see, this is kind of like the idea that you can push this to do whatever you want. In our field, there is a lot of use cases, right? Besides the defensive side of the house, right? Now, of course, I'm not implying that, this needs to be used to attack, but I'm pretty sure that it has the capabilities, right, to do more than just.
We use notebooks for offensive stuff all the time. It's very great for any type of reproducible stuff that you want to run and drive from code, which we all share in common, right? Good or bad people or actors.
Exactly.
But for the initialization stuff, again, you'd have to use the class version of the magics. Whenever you do that load extension, that's going to call the init function. That's where you do things like prompt for authentication, connect to a database, do whatever you want. And then so long as you don't restart your kernel or otherwise reload the extension, the magic, that will then be available as just a class attribute for every subsequent call. So you could do that to define, again, what subscription do you want to connect to for this notebook? Okay, you do that when you initialize, and then boom, everything else just knows implicitly what the state is or scope for that magic command.
Right. Awesome, man.
Did you also mention using magics to access CyberChef? Because like CyberChef's available as like a node application, and we talked to the developers, kind of maintainers of CyberChef, like how maybe we could like wrap them somehow in, like make them available in kind of Mystic Pi in a way to Python. But this seems
it's entirely possible. So again, if I was making the statement that magics are hacky, trying to leverage magics to do JavaScript interop would be the hackier of the two, which, by the way, you have to do from time to time, and it's a nightmare every time. But the basic premise of CyberChef-like functionality, again, stuff that actually Mystic Pi already has some of, like the base64 unpack, right? Like if you want a little utility that will do like config extraction or something, you paste in or JavaScript, a JWT parsing. And now you don't have to go paste your JWTs to random websites. You can do it right in your notebook, get a nice little printout of all your claims. Like there are tons of those little, again, text manipulation and parsing utilities that magics just make super convenient.
Cool. Okay. That was just a lot to digest, and all of it was great. Fantastic.
Thanks so much for having me.
Yeah,
thank you very much.
That was great. I think
Appreciate it. It was
really
good
on the chat.
Take care, all.
Thank you.
Okay.
So what I like about this also like format is like I just love you just bring your notebook and walk through a whole flow, right? Like not too many slides, because usually even like to present, this is to me this is like a very unique insecurity like conference, right? Where you're bringing that thing that you use to do your work, take your notes, share it with others, like reproduce work that you've done before, and you want somebody else to do the same thing. I think that this is kind of like, I love to see these type of presentations. Slides are great, but sometimes that's like a barrier for a lot of people, right, to kind of go and present right in a conference. So I think that this is very flexible. Hopefully people are seeing the value of this too.
Yeah, it's great. It's producing like an enormous to-do list for me, like next 3 years of I think, I could do that. Yeah.
Yes. All right. Cool. So we have G.
Yeah.
Yes. Hello, everyone.
Yeah. Sorry.
Just double checking if you can hear my audio.
Yep.
All good.
Okay, great. Thank you. So yeah, hello, everyone. I am Chi Nguyen, and I'm going to be one of the hosts for the talk today. So just a little bit about myself. Currently, I'm a product manager for several threat hunting features in Microsoft Sentinel, including the native integrations of Jupyter notebooks with Sentinel and other Azure services. And with me today, there are James, Duncan, and Amripar, and I have the pleasure to collaborate with both James and Amripar in the past in one of the hackathon projects within Microsoft. So, and we thought that what we worked on is super applicable to other security teams as well, and teams that are especially short in resources, right? But still trying to accomplish more with less. Like, who doesn't want to do that, right? And we're going to share what we learned and what we built from the project, from the hackathon project with you. So allows me to introduce maybe briefly a little bit about Amrita and James as well. So Amrita is currently a security data scientist in Microsoft Threat Intelligence Center, or AKA Mystic. You've probably heard of this before. And he's currently part of the R&D team. He's focused on researching and developing machine learning techniques for threat intelligence, hunting, and detection. Amrita has previously worked on mathematics and security research fields in both industry and government, and he holds a master's degree in mathematics from the University of Oxford. And personally, I actually had the opportunity to work with Amrita's multiple customer projects for Microsoft Sentinel. Yeah, we had a lot of cool, machine learning analytics that built, utilize the Microsoft Sentinel notebooks that are also available for everyone else to try. So that is about Amrita. And for James, so James currently is a Security Cloud Solutions Architect, or CSA, at Microsoft, and he's working alongside with many customers to help them, improve their security posture in the cloud by providing architectural and technical expertise. He works primarily in Azure, but has wide range interest in security and development, including adversarial machine learning science, bachelor in computer science. Please take it away whenever you are ready.
Absolutely, yeah. So I'll just quickly present my screen. So you should be able to see my screen now. Let me just enter slideshow mode. So I'm going to take you through some just basic slides at the beginning and take you through the intro to why we did this project in the first place. And Amrit directly after me is going to take you through the notebook and the technical side of things. So our project was really focused around Microsoft Defender for Threat Intelligence, as it was previously known, Risk IQ. And the idea of it was to take threat intelligence and to try and footprint and fingerprint the attacker. And we'll kind of get into why that was important and why that was needed in a minute. So we've been working with a lot of bigger customers recently about their threat intelligence and threat research methodologies and everything. And one particularly large customer was using the Mandiant methodology of observe, identify, craft, and monitor. And these 4 steps kind of link into each other, and I'll just take you through them now. So they would generally get some actionable intelligence from places like Twitter and known data sources that are trusted. They'd then look at known but shared attributes of these data sources, so like certificates, JARM hashes, URLs, anything that they can find that kind of matched and shared. They then craft a individual query, a shared code query that they can throw into a threat intelligence platform of their choice. They were using Shodan, and then after that, they get out a load of additional results that those attackers those nation states or attackers might have had control over. So it's basically an infrastructure search across the entire of that threat intelligence. And after they've found all of that, they'd monitor these. They'd search in their SOC and they'd look at their existing infrastructure and then continuously monitor to see if they appear in inventory. And then they'd go around and around and around again. Now, the trouble with this is that their composite querying, where they created their query and crafted it in that craft stage, was not accessible in Risk IQ. So one of our core things in the hackathon was to create that functionality in Risk IQ or Microsoft Defender for Threat Intelligence. But this entire process itself is really slow and repetitive. It takes a lot manpower and to go in and actually do these individual things. And it takes a lot of manual intervention at the same time, especially around creating that query. And it also often takes time away from the researchers and analysts that are trying to prioritize their time and make the best use of it. So at Microsoft, we created 4 kind of core requirements to try and fix this process and create a solution around this process. Obviously, the first one we thought about was creating the composite querying and everything, but that's listed as requirement 2. So that's creating that composite search against the Risk IQ or Microsoft Defender for Threat Intelligence database. But to do that, we really needed to determine the indicators and find those indicators to create the query. And we started by finding all of the individual attributes of the of those known hosts, correlating them together, and then doing the things about composite searching. And Amrit will take you through that in a bit. After that, we thought we can take this a little bit further. It needs to be, this information is useless to them if they can't attribute it back to something, and they can't return it back to those initial hosts. So one of the things we can do is perform attacker attribution towards it. So we essentially can use unsupervised machine learning to kind of cluster these attackers together, individual areas, so these relate directly back to the customer's initial threat, initial input, essentially those initial hosts. And finally, one of the more important bits is we wanted to import this all into Sentinel and use this all in Sentinel and have that value of the instant enrichment within Sentinel. So that was a big thing. Return all of this back to the Sentinel and let the analysts prioritize all of their data and all of their threat research that's being done by this program. So this generates 4 core attributes and 4 core use cases. So obviously you get the first one, which is the composite querying. So we use 3 algorithms for this. The first one we use is the established commonalities, which pulls all of the Risk IQ and Microsoft Defender for Threat Intelligence data we can on each individual hosts and compares them to find rare but shared attributes and those commonalities. Now, due to the size of Microsoft Defender for Threat Intelligence and how much data it's pulling every day, there's no feasible way for us to directly query the entire data set. So instead, what we do is we explore out like a big web into the initial hosts. So how many hops out can we get between that host and the common hosts in that area? And that generates a much smaller data set that we can query against. And that starts to go where we use the ML filtering. And the ML filtering algorithm filters down those exploratory algorithm results into the most attributable and useful ones for the customer using the established commonalities that we've generated. After that, we move into use case 2, and that uses the Sentinel integration to completely enrich the incident with the attributable, maybe not so attributable data. And Amrit will get into that later. But if we take this a step back, we can start the clustering these hosts together to create what would be that attacker and position that attacker. And that's where the clustering comes in. We do less filtering here because we want it to be a lot more of a wide data set. But if we take all of these algorithms that we've done together and put them into one singular use case, we get this proactive threat hunting use case where you're doing your individual research and that's all being filtered down and you're doing individual hunting on these hosts that you've done that research on, and it goes back and forth, and then you get the reactive and proactive side working together, all from the information that's been generated from our Jupyter notebook and our algorithm. So this generates quite a bit of business value directly. So the core thing is it decreases the load on threat analysts, leading to faster time to response. So your mean time to remediation, your mean time to detection are potentially affected by how fast you can get to this, especially if you've got a lot of analysts working on these things. It provides additional context in the early investigation stages due to the incident enrichment, so that the analyst can prioritize which incidents are potentially more threatening than others, meaning it supercharges the proactive threat hunting and actively allows you to go and hunt for these incidents before they even arise. It kind of enables this inter-organization security capability, because once you've found a single bit of intelligence that's attributable to something, then you can start sharing that information with potential other companies, and then you can have that back and forth, sharing that core information to help protect each other. And as I said, it helps aid analyst prioritization, but most importantly, it reduces the amount of human work required in that whole scope and reduces the dull work, so the analysts have that faster time to response and that load is reduced. Actually, metrics-wise, our data with a couple of customers we've been working with analyzed 2 areas of gaps when we were looking at the methodologies. First of all, is that the creation of the composite queries often required developers to do the research and also the finding commonalities and create that query. That's developer time essentially, and the more people you spend on that, the more people that are querying and creating those queries, the more devs and more people you're going to need. And using our solution, we can auto-generate those queries, so we're using a lot less resource for that. Now, on the other side of things, you get the skill gaps. The data that you have generated and gotten from that manual process requires senior analysts to confirm and go through that data, whereas ours tries to do ML clustering and feed that all back into Sentinel without the analyst having to necessarily touch it. So you're saving so much manpower and so much use for all of this. So you're ultimately doing the same, but with less resources. You're doing more with the same resources. So my last slide before I hand it over to Amritpal. Why did we use Jupyter Notebooks for this at all, not just things like a logic app and things? Well, Jupyter Notebooks itself is language agnostic. It doesn't require KQL, but you can bring KQL in if you need to. It can handle very big amounts of data. So RiskIQ or Microsoft Defender for Threat Intelligence takes in terabytes a day. We need to be able to handle that very quickly. It's data agnostic, meaning we can take on multiple data sources, not just Microsoft Defender for Threat Intelligence, but maybe Showdown, like our customer was using. Its native use in Microsoft Sentinel means that we can integrate really, really easily and effectively and provide it to a wide reach of different customers. And it's customizable. It's really customizable. So you can customize any cell and use those cells within Jupyter Notebooks. And finally, is that visualization. So as defenders, we think in graphs, and we need to try and have that snapshot very quickly about where something is and how it interacts with each other. And being able to have that visualization really helps analysts prioritize. So I'll hand this over to Amritpal now. Yeah, if you have any questions towards the end, please do tell. But Amritpal, over to you.
Do you have the right mic selected?
Really quiet, Amritpal.
Quiet, yeah. Do you want to check your mic settings and see if you have the right device?
Hey, is that any better?
Oh, yep.
Okay, great. Switch to a different headset, seems to have fixed it. Okay,
Awesome.
I'll get back to sharing my screen then. There we go. Okay, so I'll talk you through the actual details of what our notebook solution to this customer problem does, and talk about some of the cool techniques that we've used in terms of some of the ML, some of the data science, and some of the kind of broad structure of the notebook itself. So there's really 4 stages to this. So first of all, we want to input our user data, and this is where notebooks are really great, right? So as developers, we love flexibility. We don't want our solution to be just scoped to one input or one workflow. And with notebooks, we can bring our own code and we can take input data from any source that we can reference in our notebooks. So in our case, we're taking input from the Sentinel Threat Intelligence Indicators table, and we're extracting known suspicious IP addresses or host names. And again, as developers, we love openly documented APIs, so Sentinel's great for that. But if you want to use some other data source, if you're using another platform, for example, you can do that too. So once we have our input, we want to use the RiskIQ API. So what's now, you can use MDTI, Microsoft Defender for Threat Intelligence as well. And we want to basically expand that graph of what attributes, what entities are related to these known hosts, and then can we pivot from those to find even more related entities and recursively do that until we've built up this broad graph of things that are potentially interesting for us to look at. So at that point, we've got this vast network of possibly interesting things. And we then really get into the data science stuff where we kind of start filtering this down, start doing some clustering, and that's where the threat intelligence really comes from, where we can say we've got these original set of hosts or IPs or domain names, and we can link them with high confidence to these other groups of IPs or domains. And then we don't want to just end our threat hunting workflow there. We want to make sure that we close the loop and that we're feeding back this useful information to either the SOC team or in some form that we can then actually action that intelligence. So we output the top related entities, whether it's hosts or something else, and we send those back to, in our case, Sentinel, but again, via the open APIs. Again, you can use any platform of your choice really here. So I'm going to switch over now briefly to just give a bit of a, not so much a demo, just show what the maybe threat hunting workflow looks like. So in Sentinel, we can register Jupyter notebooks as native notebooks. And when you click on this, it takes you to your notebook. In this case, it's opened by default in Azure ML Notebooks. But if I want to switch to Jupyter or Jupyter Lab or even VS Code, I can just simply select editors from the menu here and easily switch. So if I run through the notebook, we have some setup with the passive total API, which we're the passive total package, which we're using to interact with the RiskIQ API or what's now MDTI. And we're also using the Sentinel APIs to pull down interesting data from wherever we want in Sentinel. Again, here you can switch it out for either manually input host names or hosts from another platform of your choice. So when I say hosts here, by the way, I mean either a domain name like google.com or an IP address. So at that point, I'll maybe switch back and talk through what the next steps are going to be before I show that in the notebook. So first, we're going to kind of just query everything we can about these initial set of hosts. So we look up things like who is data, resolutions, are there any RiskIQ articles, web components, cookies, trackers, everything we can for each of these hosts. And then we look at, what's shared between these hosts that we can maybe pivot on. So if I bring back my notebook, you can see if I run some of these cells, we've got a really efficient implementation of querying the RiskIQ API, which allows us to quickly get, gather all this information for potentially large sets of hosts. And that will just run in background. But once you get that information back, you've got this really wide data frame of you start with just these IPs, and now you've got a ton of extra information. So the first bit of filtering down that we do is we discover what do these known bad hosts have in common that maybe is of interest. So there'll be some stuff which is just generic and not that useful, but maybe there's some particular registrar or service name that's really common between these hosts, and we can plot that and have a look at that. And we have these discovered commonalities here. Now you'll notice, obviously, there's a slight pitfall here. Some of these are common just because they're globally high prevalence attributes. For example, maybe Cloudflare isn't a very interesting registrant name from Whois. Cloudflare as a Whois organization doesn't really tell us much. So that's where we get to the next step of our algorithm. So in fact, what we want to do before we start filtering down, we actually do this exploratory algorithm recursively. So we start with that input. We found the common shared attributes for those initial set of IPs, but then we can take those common shared attributes and in particular look for the shared attributes which are low prevalence, and then we pivot on those to find even more related hosts, and then you look at what the shared common attributes between those, and then you use those common attributes to pivot again, and you recurse n times until you've built up this wide graph. And in practice, we found 5 levels of recursion works well. So like I said, the obvious pitfall you'll notice here is that the number of nodes that we end up with in our graph explodes exponentially with the number of times we recurse. So we'll massively filter this graph down in the next step, but to try to cut down some unnecessary queries early on, we only pivot on low prevalence attributes. So for example, if we notice that all of our hosts have a really common registrar like GoDaddy, maybe that's not something that we want to pivot on because that's just globally high prevalence. If there's some really uncommon attribute, however, that all our hosts happen to share, that's a really good candidate for pivoting. So again, if I switch back to the notebook here, we can see the next step. This is the recursive querying, which allows you to build up that graph. And we've got an example of what the algorithm looks like here.
Ripal, can you zoom the notebook in a little bit?
Sorry, yes, I'll do that. I think this part of the algorithm it's actually hard to understand from code. So I'm going to switch back to the slides once again because there's a sort of nicer demonstration of exactly how we start doing some of the filtering. So at this point, we've got this wide graph of related hosts. We've done some basic filtering in terms of, we don't want to pivot on really high prevalence attributes, but we can do a bit more. So as an example, say we've got this graph here. Okay, obviously this is quite a small one here, but if you bear with me, so we've got these nodes here represent hosts, so domain names or IP addresses, and these links are shared attributes. So in green here, the shared attribute is a shared registrar. In purple, we've got a shared service port that this host exposes. In yellow, orange here, we've got a shared certificate issuer. So in reality, once you build up the graph, there'll be like a huge number of nodes and loads of connections. So how do we filter that down? So the first thing we do is that we downweight some of the higher degree connections. So I don't think it's shown up very well, but so by higher degree connections, we mean second order connections. So if we just had one starting host, this would be a second degree connection here because it's not directly connected to the original node. It's a connection of a connection. And similarly, this purple one here would be a third degree connection. So we downweight some of these. Okay, so you can see the downweighting sort of happen in the slide deck at this point. We also downweight attributes, some of these shared attributes, some of these links, which are globally high prevalence. So if you imagine maybe this shared certificate issuer in orange here is not high prevalence globally, but it's more high prevalence than maybe the shared registrar or the shared service port. So we downweight those, and you can see that visually as this link becoming a bit thinner on the graph. And then conversely, we want to increase the weight for attributes that occur with high frequency within this graph. So you can see this green shared registrar appears in 4 links in this graph compared to the other shared attributes which only occur twice. So we increase the weight of these links here. And then finally, we increase the weight for certain high fidelity attributes. So this is done based on heuristics that we've discovered from our own internal threat intelligence and based on various heuristics. So maybe a shared service port or a shared registrar, isn't that good an indicator of something being a link between 2 hosts, but maybe a shared certificate issuer is a better attribute to pivot on. So you can increase the weighting of those links. And then finally, once you've done all that weighting, you can remove the links which fall below a certain threshold. And that's really what allows you to prune this graph that you built and do this filtering. So what you're left with is a much pruned down graph, which is what you then take forwards as your set of related hosts. In this case, it's fairly small, but in practice, you get really complex graphs. So once you've done that filtering, we can, in Jupyter Notebooks, the great thing is you have all these interactive visuals. So you can have widgets where you're building this graph and showing that visually. But in terms of being able to share this data in a more portable format, we can output that data as a data frame, and we've got this composite score, which is a kind of broad scoring of how strong links between a given new host is with one of the hosts in your original seed set. So again, this is ordered by the composite score, and maybe you set some thresholds based on your capacity as a threat hunting team to investigate some of these links. So what we've done so far, so we've started with our seed data set, and we've built up our graph, and we've pruned that down with some machine learning, which I explained at a broad level, but the details of it, if you've, for example, done any natural language processing, it's similar to the TF-IDF method in terms of how we actually implement that and the equations behind that algorithm. So what we haven't done yet is any sort of clustering of these hosts. And the clustering is what really allows us to do attribution. So, when we do clustering, what we're really aiming to do is draw a border around certain groups of attacker infrastructure and really footprint what part of the infrastructure belongs to a certain attacker or is involved in a certain attack. And that allows us to do attribution in a couple of ways. So maybe we've seen that cluster before and we've been able to attribute one of the entities in that cluster. Maybe one of the hosts in that cluster we know belongs to a certain attacker. Maybe we already know that we've got the shared attributes within that cluster are indicative of a certain actor group or a certain adversary. So there's lots of potential stuff we can do here. But what does the clustering actually look like? So if you imagine we've built up this graph of related of hosts which are related to our original seed set, we then link them together, use our ML clustering algorithm to prune down that graph, and we end up with this. Now, in this dummy example, you can see that we've clearly got a couple of clear clusters there. Admittedly, partially down to how this has been drawn with the clusters already separated out. But behind the scenes, what we're doing is looking at two things, really. So we're looking at the number of links within a cluster. So you can see within this cluster, these nodes have lots of common shared links between them, compared to maybe this cluster and this cluster. The number of links between these two clusters is relatively small. But also, all links aren't built equally. So links in this case are shared attributes. So it could be, a shared low prevalence but suspicious registrar. It could be, a particular service port which is open, which is unusual, that's shared between two hosts. And those different attributes don't carry the same weight. So we weight by the type of link between nodes as well. And that allows us to build these clusters. So we can do this in our notebook. If I quickly switch back, we can do this inline. We can also run this algorithm. This algorithm parallelizes really well. So you can do this in a plain old Jupyter notebook, or you can use something like Spark to parallelize this very easily as well. In this case, we haven't needed to, but in this case, we've got our composite scores, and we can just, with a relatively good efficiency, just cluster in a plain old non-parallelized version of our notebook. And the final step is really about closing the loop. So we want to make sure that this data can be used. And I briefly alluded to the fact that we're storing this in a data frame, so it's more portable. Whereas, we could use all sorts of visualizations within our notebook. But one of the really cool things is being able to use APIs like the Sentinel API to then feed this back to your SOC or SIEM platform of choice, and then feed this data back into your threat hunting workflow so that you can actually action it. And as an example of what that might look like, I've created some, from our demo notebook, I've created some dummy alerts in Sentinel, for example. It doesn't have to be Sentinel, but you can do things like send that information back, say, what hosts are useful. And this is just one way you might do it. But I think for us, and for our customer, one thing that was really important was to make sure that we are closing that loop. And again, what this basically amounts to is within a threat hunting platform of your choice or any workflow, you can just plug in a Jupyter notebook that basically allows you to execute arbitrary ML algorithms or arbitrary analytics at scale or in as flexible a way as you want. And that for us really was the power of Jupyter notebooks. And that's why we went for Jupyter notebooks as a solution. So not only do they allow you to execute really cool stuff that maybe your platform of choice natively doesn't, you get all these benefits like the visualizations, the interactive workflow as well. So I will switch back to the slides. So again, an overview of the kind of overall process of how this links into a practical threat hunting workflow. I've talked about all these points already, I think. So I'll leave it there, being wary of time. And I'll say thanks for listening. And if you have any questions, happy to take those as well.
Okay, let's get people back on the screen. Thanks very much, James and Amritpal and Chi. I was going to look, maybe Joyce could help me look, see if there are any questions on the Discord. I had a couple of questions myself. So last year we had Mark from Risk IQ talking about use of the, and it showed us like the use of the passive total Python API. And I understand there's kind of like a new API happening, but that's still something in the kind of the workflow, how you would use the data in a notebook. You can use the API to gather all of that host information. So this is something that anybody could do at home, assuming they had like a Risk IQ subscription, right?
Yeah. So I guess the prerequisites for this particular notebook, we're depending on the Risk IQ API. So therefore, you need an MDTI or Risk IQ license. Having said that, that's just because we're using Risk IQ as our threat intelligence service of choice. If internally within your organization you've got another feed of threat intelligence, the algorithm is to some extent independent of where that information is coming from. But yeah, for this particular notebook, which we hope to share soon publicly via Sentinel, our Sentinel Notebooks GitHub, will be targeted at Risk IQ/MDTI.
So you could use kind of like IP reports from VirusTotal or OTX or something like that to get like maybe passive. I don't know. There's obviously a more limited like VirusTotal, OTX work in a slightly different way, but certain kind of attributes, which leads me on to my second question. Is like, how do you talk about like weighting the different attributes? So the way that you build links between or edges between hosts is the kind of shared attributes, and particularly the rarest attributes. How do you weight which attributes are kind of like higher value? Is that something you just like trial and error, or is it something you can like use unsupervised machine learning to infer?
So we can internally we've done some research using some supervised methods. So we have lots of threat intelligence about groups of related hosts, related IPs, and we can empirically see, well, we know these are related. Which attributes do they happen to share? If these related hosts never share, this isn't the case, but if they never share or very rarely share the same registrar, then maybe you realize actually using registrar to link different hosts isn't a good idea. Conversely, if every time in your internal or open source threat intelligence you have your known group of hosts, and that within those groups they always share maybe the same certificate issuer, then you realize actually that's a really good attribute to be pivoting on. So you can apply that in two ways. You can either use sort of analyst-driven heuristics. So you might have threat intelligence expertise within your team, and they can tell you, as experts, these are the attributes that we find most useful to do pivoting on. Or you can use supervised learning methods to, from your data, infer what those weightings should be. There's actually a third way to do this as well. So it might be that, for example, as part of your threat hunting workflow, your analysts, because of their expertise and their background, prefer linking hosts or other entities by certain attributes because they have maybe internally in your organization, you happen to have more intelligence about those certain attributes. So if you know that your end user analysts aren't going to be interested in shared registrar, however useful it might be at linking stuff together, maybe you want to downweight that because that's what your end users are or aren't interested in.
Yeah, okay, that makes sense. Obviously, there are some things you pointed out earlier on that, like, if you see something that's like Cloudflare that has like a massive global prevalence, you can just automatically eliminate maybe either certain values of a given node, or maybe edge, or like the edge entirely. Have you also looked at like domain name construction as a sort of like a pattern for like pseudo random domain names? That's also been interesting. Like if you could, obviously it's a little bit difficult, so you may be able to, sort of like language-based analysis. Anyway, sorry, you answer rather than me speculate.
Yeah, I mean, that's something that it's not part of this notebook, but it's certainly something we've looked at in the past, and we have other algorithms that build on that. In terms of how that could fit into this, so if you think about what the algorithm's doing, it starts with hosts and basically expands that data frame horizontally. So it's adding on columns. So attributes might be what registrar is it using, what certificate issuer. One of those attributes could be, for example, is it a domain name? And if so, is it a gibberish domain name, i.e. does it look randomly generated? So one of your links between hosts could be, these are both randomly or appear to be randomly generated hosts. Or it could be, does this host match this specific pattern that as an analyst I know to look for? So that's not built in, that's not a feature that's used currently in our notebook. But if it were added as a feature, the rest of the algorithm could proceed in much the same way.
Okay, so you could, and how would you add that? It's just like obviously you'd need some kind of function algorithm.
Yeah, so I guess at the initial step when you're doing your enrichment, so one source of enrichment is, for example, query risk IQ, pull down a bunch of who is data, other various lookups. There are a couple of open source Python libraries which, for example, do basic natural language processing and will tell you, does this string look like it's structured language or does it look like gibberish? Off the top of my head, I can't remember the names, but I know we've used some previously. So those are quite easy to use and quite powerful actually, because you can just call them call the appropriate function with your domain name as input, and it will return true or false. Is this string randomly generated, or is it, does it look like an actual word or similar to an actual word in some one of the supported languages? So then with that output, you can add that as a new column onto your set of hosts. Is this gibberish? Again, if you want to do more advanced natural language processing, you need to build out those functions yourself. But what we see nowadays is with Python, there's so many open source packages that do a lot of this stuff for you. And being able to bring that into your threat hunting workflow by using the power of just notebooks, you can actively use all of those libraries within your threat hunting workflow. Whereas if you weren't using notebooks and you were limited to what's available in the UI for your platform, for example, it becomes a lot harder to do all these complex transformations and call these complex functions.
Yeah, that's what I was talking about before. Like you're kind of building your own hiking boots in order to go on a hike, rather than just finding that somebody else has already built some that fit perfectly. Let me use those. Yeah, it sounds like I could use the gibberish detection. Maybe next time I do a presentation, run that over my presentation before giving it. So we've got a couple of more minutes. James, Chi, did you want to add anything? Anything else? I was going to try and look while I quickly look at Discord to see if there's anything happening over there. Or Roberto, have any?
No, there is nothing in Discord, it looks like, but we're already in the break time, so maybe we should take the conversation to the Discord.
Okay, I'm sorry. I thought we were ending at like a bit earlier than we are. Okay.
Yep, all good. Yes, it's only a few minutes, but nice presentation. I think that there is definitely a lot to explore in like, for example, if you can share the notebook, is that something that could be shared as well, or it has to or that's part of the Sentinel notebooks that come with a solution or something, or not?
Yeah, so it's not we haven't pushed it to our Sentinel GitHub yet, but we do want to make it open source. So because it's a notebook and because as we built it, by default we're interacting with Sentinel. Again, it doesn't have to be Sentinel, but we're planning to push this to our Sentinel GitHub repo. I'm sure Chi can probably link to that in the Discord. But then you can either use it directly from GitHub, or it will also appear as a template notebook in the Sentinel UI if that's something you prefer.
Sounds good. Yeah, I think that so open sourcing it through GitHub, I think it would be nice, right? Just to get it like as a link to the GitHub. Yep.
Yeah, that would be awesome. Sorry for I thought it was like 2:45. 2:55 the break, or 2:50 was meant to be the break, so we don't actually have any time. Now minus 5 minutes. Well, thanks very much, everyone. That was a great presentation. Fascinating. We talked about it for a long time.
Yep, thank you very much.
Awesome. Thank you, everyone. I'll drop a link of the GitHub repo in the chat in the Discord channel. So keep an eye on that. Thanks, everyone.
Sounds good. Thank you. Thank you, guys. Thank you all.
Thank you.
See you after the break.
Yep, see you all at 3 p.m. 05. Eastern time, of course. We're coming back in almost, I would say 5 minutes. 10 minutes. Almost 10 minutes.
Better than time zones.
Oh, good. All right, so I guess we can go on break, and then you can play some of the music, Ian. That would be nice. If it's possible. All right. So we're back. And let's see. We have, let me make sure I have here. So we're going to be looking into this next presentation. Cybersecurity data holds the answer. And with us is Christian Camilo Ursuki, Urkuki, in
Urkuki.
Spanish.
Yeah, that is a good pronunciation.
It's right. There you go, Ursuki. Ursuki
No
Lopez.
worries.
Yep, Ursuki Lopez, and I believe Christian, we met in the
Echo
Echo
Party.
Party, right?
Yeah,
Echo
right.
Party. Awesome. Yeah, so that was the first blue space. So that was the first time the Echo Party was creating its own defensive kind of like you know side of the Echo Party, which is called Blue Space, and I think there is where we were able to meet. And I believe that our presentations were in Spanish, right? I think it was also
Yeah,
also
yeah,
100%?
it was.
There you go. All right, so that's awesome, and really happy to see you here in this conference. Very interesting to see that you, with others, wrote a book while being in the university, or the university it's part of this research as well, because I think that there is some like, kind of like education side of this book, right?
Yeah, the idea to show you in this presentation is a set of results that we are we doing in research, specifically in cybersecurity, in different bachelor theses and graduate theses from our students.
Okay.
So we launched the book a few months ago. It is to show you the things that we can do
Nice.
using data science in cybersecurity.
Nice, nice, nice. Yeah, it looks pretty cool. I think that it has a lot of different concepts from the defense side, offensive side. So yeah, it looks pretty interesting, and I'm happy to see it's a resource that was just released a few months that you're trying to talk about in this conference is really good. And I could see also that you've been in the software industry for 9 years, right? So that's a lot of years, developing software or trying to do security on the software development side of things, I guess.
Well, part of the years have been as a software engineer and researcher. Well, my last role was a director of technology, and now I have a full time role as a data scientist.
That's
So
awesome.
different things.
Awesome. Thank you, Christian. Well, take it away. I don't want to take much of the time, but it's super cool to see you here also in this conference.
Thank you, Roberto. Nice. So I am going to share the screen. Okay, awesome. First, thank you for giving me the opportunity to present you our latest findings in cybersecurity data science. Well, the idea is to show you, as Roberto mentioned, is our latest book that we published in 3 months ago that has 8 research projects about the use of data science in cybersecurity. But I would like to first to introduce you the our first book and the motivation that allowed us to develop uh, these new projects that I am going to show you in the next slides. All the code, the presentations, the Jupyter notebooks, the Python scripts, R scripts, Java, C# are here. So please check it out. If you have any question, please. I will wait for your questions and any recommendation about them. So this is an open source project, and all the methodology are available in the book. The first book that we published in 2018, include two principal projects. The first one was my master thesis that was done in 2014, and it was oriented to propose a framework based on static analysis and the application of this information to develop machine learning classifiers to detect Android malware. The It allowed us to, or allowed the inspiration for us to explore the use of dynamic analysis and the integration of static analysis together to develop new machine learning algorithms to identify, in this case, or that case, malicious websites. So the idea for the second project was to understand how to use telemetry information and some features from the website. All of those projects are in our first book that was launched few years ago. But those experiences allowed us to, or were the motivation to develop the new projects that I'm going to show you. Principal because it the first book was a motivation for us in order to understand more about the use of data science, in order to understand the cybercriminological phenomena and in these different derivatives. In other words, in order to detect other cyber threats. And one of the challenges that we have in all the projects was to identify the best data sets and the patterns that allowed us to identify the threat that we wanted to analyze. Another challenge that we had was to reduce the difference between legitimate and malicious activities. In other words, to reduce the number of false positives of false negatives. And the projects that I'm going to show you in our second book includes, or it's all of them start with the hypothesis that at least one record is generated for a cyber attack. Our baseline for the second book was a proof of concept that I did in a cybersecurity startup using unsupervised learning. Specifically, I developed an anomaly detection system based on an application of natural language processing. Specifically, we did a research about the state of the art, and we found open source project. Its name is Apache Spot. It is a cybersecurity big data solution. At that time, the project used the information of telemetry, specifically from net flows, DNS queries, and proxy queries. So the challenge that we had at that time was to simulate the same framework. So we used information from a set of proxies. And the idea was to implement natural language processing in order to create the language of the network that we analyzed at that time. So with the system, we identified some anomalies during the communication from the different proxies. That was our motivation in order to understand more about the use of the telemetry information. Specifically, so the book is divided in two parts. The first one for defensive and the second one for offensive. So I'm going to start, for example, with these ones. So the first project that began in 2017 in explore the application of supervised learning, specifically in order to identify web application attacks, such as SQL injection and subscribe and cross-site scripting. That project was done by Brian and Juan Sebastian Prada. So they tried to simulate the interaction of a set of SQL injection and cross-site scripting in order to attack a vulnerable web server. And at that time, it was a DBWA. So the idea was to get a set of information in different pickup files. So we trained a set of algorithms that are here. For example, the best one was a random forest model with this accuracy, but it was in 2017 and was the first point in order to develop other projects. For example, the third chapter is about the it's about to analyze it's about to analyze malware in Android, specifically using dynamic analysis. So we did the same approximation. We tried to simulate a set of Android application and Android malware in a virtual environment, and we made a script in Python in order to create the simulations or interactions from a user. So the idea was to recreate the same simulations in order to create the other pickups files. We have some Python script in order to get the different features from the pickup. And finally, we developed other machine learning models in order to detect the cyber threats that we studied at that time. All the data sets from Android, the malicious websites, and the web application attacks are not available in Kaggle and IEEE data port. So the idea was to contribute to the different communities in order to start in the cybersecurity data scientists. So the open source project, Apache Spot, allow us to go more in depth in telemetry information because, as you know, pickup files generate a lot of information. So the idea was to understand more how to use net flows in order to identify other threats. So, for example, we propose some machine learning models in order to detect botnets and cryptojacking, two new scenarios that were proposed in 2020. So the challenge here was to transform the different pickups that we got from a research institute that its name is Stratosphere Lab. The challenge was to transform the pickups file to net flows. We, with the students and me, we developed a set of Python scripts that allowed us to transform or pre-process the different pickups file that we got. And finally, we implemented the same approximation using the data science methodology. The same approximation was used in the detection of cryptojacking, but the difference was we included a set of information or another data set that had features from hardware, for example, CPU, RAM, among others. So because we have two scenarios that are different, but the most important thing here is because we found the use of net flows in order to identify other two different cyber threats. Those experiences allowed us to implement or to develop different proof of concepts in an oil and gas company in 2020. The idea was to understand the different operations, the information that the company has in its security operations center and its CM, specifically from Splunk Cloud. The idea was to understand its information and how to use them in order to propose machine learning models. And moreover, that company wanted to implement a stack of Microsoft Azure and how to innovate in cybersecurity in order to create, for example, new ideas that, for example, the stack of Microsoft didn't have at that time. For example, we propose a proof of concept in order to detect, for example, cyberbullying at that time. And the offensive approximation, that is the second part of the book, includes a set of methodology about the detection of deep fakes, the reinforcement of fairness in machine learning models, and finally, adversarial machine learning in the approximation of white box and gray box approaches. Why? Because one day, maybe, when I was reading the book of Sensu, I, I I wanted to understand more about the offensive approximations in the use of offensive in data science in artificial intelligence. And we wanted to explore the use of artificial intelligence in order to create fake multimedia. Specifically, we began with the use of artificial intelligence in generation of video. So, at in this project in 2020, we began exploring the use of generative adversarial networks in order to create and identify deepfakes. We began doing a research about the different datasets that are available right now. For example, are here in the different columns. And we developed a set of neural deep learning models in order to not only to generate the idea was to identify the deepfakes videos. So as you can see, we explore not only the application of deep learning, we tried to explore other mechanisms, for example, as a techniques in forensic, for example, the error level analysis, in order to improve the approximation that we tried to explore. I am a believer that deepfakes can be analyzed in different dimensions and not only in video. So we tried in the next project we tried to implement was the deepfake in audio. We got two data sets that are available right now. So the first one was from a research institution, and the second one was from a challenge that I don't remember at that time was from Facebook. I think so. So the novelty about this project was the use at that time of convolutional long-term memory in order to identify deepfakes audio. That was a presentation that we present in the Eco Party 2 years ago. So we have here some results. All the results that I am showing you right now, well, are available in the book. I know that it is in Spanish, but it is something that we are working right now. So in order to translate them in English. So if you have any question, please, you can contact me. I think that deep fakes are and the different things that are going to happen are going to increase in different threats, because the interactions that we are going to have in the future, for example, in using the metaverse, we can create using deepfakes different things in order to implement social engineering. For example, blackmail, defamation, gore, and handling. So I think that deepfake as different derivations will be or we are a huge threat that we will have in the future. We have another result that we explored a few years ago, that was how to reinforce the machine learning model against the fairness in machine learning models. Specifically, in a security research project in the capital city of Colombia, we explore the use of generative adversarial networks in order to predict crimes in the capital city. So we develop a set of algorithms in order to reinforce the model that we proposed at that time. This has an article that was presented in a conference proceedings that is here. Finally, the book finishes with a set of results in adversarial machine learning, specifically exploring the use of black box and gray box approximations. Adversarial machine learning is the way how we can hack a machine learning model, or in other words, how we can create adversarial inputs that can that adversarial inputs for our machine model that the model will create bad decisions or bad results in order to create bad results from our model. Secure learning is basically the way how we can improve our machine learning models in order to be reinforced against adversarial conditions. In other words, to have self-learning algorithm. That is the same way that we can see, for example, in penetration testing or in ethical hacking, because as you know, in ethical hacking, we have black box, gray box, and white boxes. So if we know as a data scientist or developer or an attacker, some things about our objective, like the data set or the feature of the data set or the algorithm that we wanted to attack. So those scenarios depends how we can improve the model that we wanted to improve. This last project use reinforcement learning that we wanted to generate a proactive scenarios. As you can see here, let's imagine that this robot that we have in this screen is our defensive models that we created or a few years ago, as I mentioned it in my last minutes. For example, the Android malware model that we developed in 2014. And the scenario is the offensive approximation. How, in other words, is the attacker. So we wanted to create a versus defensive and offensive approximation. So two results that we had right now in the book is how we can use reinforcement learning as a white box approximation and deep reinforcement learning in a gray box approximation. So we have some results right now. For example, in our model for Android malware detection, we implemented the both scenarios, the gray box and the white box. So we found that using them, we can explore the inputs in order to hack the models. But in the same way, how we can reinforce using the same inputs, how we can reinforce the model against other inputs that maybe in the past we didn't analyze. Actually, we are working in the black box approximation in adversarial machine learning. The second project that we are working right now is an assistant for A-pair programming to control web vulnerabilities, specifically using TypeScript and Visual Code, Visual Studio. The third one is assistant to recollect and filter open data for Recognize. And the last one is a framework for citizen equality in AI-based systems. Specifically, the idea is to analyze the laws here in my country in order to have a framework that can be replicated in public and private institutions. And this is a brief of the book with all the chapters. As I mentioned previously, all the books has all the chapters has each of the notebooks that we proposed at that time. The data sets are available, the code are available, and the same way, some of them have some articles that were published in conference proceedings. So please, if you have any questions, we can chat in the future.
Awesome, man. Thank you very much, Christian. Yeah, so that's very important to know. For example, let me share my screen real quick first, so that because we only have a few minutes, and I think that we can show the resources real quick. 1 second. So I'll present my screen just to kind of share what I think it's super cool to dive into. All right, this is screen. There you go. So, for example, if you go to the agenda, right, and then go to the presentation, which, by the way, it was a good way to kind of summarize from the author himself to say these are the sections that are super important that the book is trying to show. But at the same time, I like the resource of the GitHub repo, because if you go to that one, right, which is also in the agenda, you can see all the different areas of research, which I love that you use the 15 minutes to do the overview and then say there is a lot that you can actually dive into depending on what it is that you're interested to learn a little bit. And then if you use GitHub, right, you can use the search basic capability and says, give me all the notebooks that this project has, and then you can dive into, for example, if you're interested on the malware side of things, maybe dive into the notebooks related to malware, and then see how that's being used. And because there is so much information, it makes sense to say, this is the link. If you have any questions, just let me know, right? Reach out to me. I mean, I see you in several communities. I see you that you are also in the Dragon Jar, which is Colombia, right?
Yeah, right.
There you go. So you're Colombia, Argentina, now the US. So that's awesome, man. And I like to see some Spanish in some of those notebooks as well. So that's pretty cool.
Thank you.
Yeah. So any questions that we might have? Let's see. I mean, we don't have much time actually, but if you have any questions, reach out to Christian. Super cool to talk to you also outside of like the conference, of course. So I'm gonna reach out with a couple questions about reinforcement learning actually, and I would love to dive into some of those notebooks as well. So thank you very much, Christian.
Thank you, Roberto. Thank you, everyone.
I thought it was cool. You could tell Christian's like from an academic background. I think every one of his slides had like an attribution of like the background research, and it's like
yes. That's awesome, man. That's awesome. Anyway, so let's. Oh, and by the way, we are actually getting into the 15 minutes talk with a 2 to 5 minutes type of question. So that's why you see these talks being shorter than the ones from this morning. So now we have Ian. Let me just take my. Yep, there you go. Thank you. So now you can add your own screen. So we have already introduced Ian. Ian has been our keynote today. And just take it away, Ian. And he has something else that he wants to share with you all today. Thank you.
So can we actually see that?
Yep, good.
Okay, good. It was showing nothing because I had it minimized. Okay, so this is a bit more practical, I guess, than the talk this morning. So I talked about pivot functions and that they should be user kind of extensible. So how do you go about doing that? So we have our initialization cell. I've kind of already run that, so I won't. Normally takes a lot longer than that if it's a fresh notebook, but I ran that a little bit earlier. So we have, for people who may missed this morning's session, a pivot function in Mystic Pi terms is like a contextual function that lets you invoke different operations on different entity types. And they are wrappers around other underlying functions and exposed as methods of entity classes. And by entities, I mean things like IP address, a host, a URL, domain name, that kind of thing. And these are some examples of how you would invoke them. It's like sometimes they're directly attached to the entity. Sometimes, as in the host, there's like a subgroup. So this groups together all the Sentinel queries that are appropriate for a host. So adding a simple function. So this is a function, we've actually just added this to Mystic Pi, kind of to defang IOCs. But let's say that it wasn't there and we wanted to add this as a function to have it to appear on relevant entities. So it's a simple thing. It just takes a string, it's an IOC, and by default, it will just return any dots, it will just surround them with square brackets. And it has an optional IOC type. So if it's like an email or a URL, it will do some other additional kind of processing. But let's take the simple case first. So we're going to run that, make sure it's defined, and then check that it does what you think it's going to do. Returns a string with these escape dots. That's good. So to add this as a pivot function, there is an API as part of like Mystic Pi Pivot, and you need to supply a few parameters. Obviously, you need to supply it with the function that you want to wrap. The container is just the name of the subcontainer of the IP address or the entity. So it'll be like IP address.util. Our function name. This just takes a value as an input, so like a single string, not a list or a data frame. and the map of entities. And here we're going to assign this to IP address and a DNS entity. And this is the input parameter that the function is expecting. This is optional, but we want to kind of reduce that a little bit, like defang IOC. We can just call it IOC when it's, defang when it's actually attached to the entity. So we just run that, and now we should have a pivot version of the same thing. And we can see that it looks like it's already doing something different. Is it now returning a data frame with the result? So that seems to work. Works on domain names as well. Something the function didn't support initially was working with lists of things. We can see that that now works as well, and it would be the same with with data frames. So we can expand it a little bit with, like in the original function, we noticed if there was an optional parameter to specify the IOC type, and you could get it to do something different. So here we've got essentially the same thing. We're still calling the same, adding the same function, this time mapping it to URLs. But this one additional item is we're going to supply the static parameter IOC type to set it always to URL. And bring that, which is not, it's done the escaping, but it's also neutered the protocol part, as our function did. So that's a kind of simple way of adding a function that's defined in your notebook. But typically, you don't want to have to write functions in your notebook in order to create pivot functions. You want them in some kind of module or package. So let's create a module. We'll take our function that we had before, and here we're using an IPython magic, which just writes the contents of everything after this line in the cell. It writes that to this file, which is going to be our module. So we have the same function we had before. We've also got a couple of like mock functions that don't do anything particular, but say hello and goodbye. But we can add those as well, just to kind of demonstrate. So let's write that file. So we now have a, what was it called? IOC utils. And when you've got a bunch of functions like this, you don't have to call that API over and over again. So we could provide a definition file, which is in YAML. And each of the things in here, you can see look very much like, and in most cases, they are identical to the parameters we supplied to add pivot function. But this just allows you to import a lot at one time. So we've got the two things that we did before for URL and IP address, DNS. Oh no, so this is mailbox. We've done a slightly different one. And we're also importing our two little like, mock utility functions. And we're also importing something that's actually not in our code at all, but part of the Python standard library. So you can take somebody else's functions and wrap them in the same way. This is just doing a URL escape, kind of quoting the string. So let's write that to a YAML file. And it's a good, when you're messing around with YAML and stuff like that, it's probably a good idea to like read it back to make sure you haven't made any syntax errors in the YAML file. So we didn't get any exceptions there. So it looks like it's all good. Now we're using a slightly different API. You can see the help on this, register pivot providers, which does a kind of bulk install of anything in the YAML file that we provide. And it's got a couple of optional functions. So you can specify a container name if it was not specified in the YAML file for all of these functions to be added on to. So let's run that. Hopefully we get no errors. You can see, I think one of the things we had here, a couple of things were mailbox. Sorry, scrolling around a lot. Mailbox pivots. You can see we've got a few additional items. The fact that some of these appear twice is because there's also an option in here to create a shortcut. So this is a kind of thing you might use. You might want something in a general like utils container or a queries container, but you can also add them directly to the top level of the entity, so they're a little bit handier to use. So that's what we've got here. We've got like these things that are both in containers and they're available at the top level. So this is one of our playful functions. Doesn't really do anything very interesting, but we can see that works with mailbox. One of the things I didn't mention before, that pivot functionality, you can, any arguments in the function call that you give it a pass through to the underlying function. So in this case, our function understood the lang parameter, so it can say passes that to the function, and it gives us the return output. And as we've seen, these things can also take iterables. In this case, it's a tuple. It can also take a data frame with a column specification. And as we said, you don't need to just define your own functions. You might have a bunch of like interesting libraries hanging around that you want to wrap in the same way and make them available as pivot functions. And here we took the URL lib quote function and wrap that. And we can see we've got a nice escaped URL. So that's all kind of interesting. What are the benefits? We don't really change in the functionality of any of these functions. Well, like what are the benefits of these things? Well, the first thing is, I talked about this morning, is like reducing the number of entry points that people have to think about. So you can gather all of your URL related stuff into and add them as functions to the URL entity. People really need to. These things with the init notebook function are auto imported, so you don't even have to import them, which is what, unfortunately, Pylance in Visual Studio Code, because it hasn't seen an import statement for URL. It thinks this isn't defined. Of course, we know it is because we've just run it, but that's a kind of a downside. I'm not sure how we fix that with Pylance. Maybe I could talk to the developers and see if they can recommend a solution. Anyway, functionality all in one place is one of the benefits. Flexible input types and standardized output types are the other two main benefits. So that's basic functions. There's another way that we can add pivots dynamically, and that's by defining queries, like Mystic Pi queries. So let's say we have a query here. We want to take that, but we want to generalize it. Maybe make the time parameters flexible, be able to supply different values for the host name. So we first of all need to parameterize it, replace the fixed time with kind of templated things where these start, end, and host name will be replaced when we execute it. And add it to a query definition file. And here again, we're going to delve a little bit into YAML. I think this should be like that. This is a little bit kind of complicated. It really has three main sections: metadata, which is like global stuff for the all of the queries in this file; some defaults, so we don't have to repeat the parameters. These are inherited by all of the queries you specify, and most queries are going to have a start and end. And here we see our query that we created, and we've done a little bit of elaboration. We've added add query items, which allows you to add query clauses onto the end of it, arbitrary query clauses, or query injection. You might know it by a different name. And here is the parameter that's specific to the host, defines the type and the description. Okay, so we're going to write that. We're going to create a subdirectory first. Oh, it's already there. That's good. And we're going to put this in our YAML file into this query subfolder. This is just the same thing before, but it's in actual executable cell rather than in a markdown cell. So we've written that. So now we need to create a query provider that will read these queries. And by default, the query provider will read any queries that are assigned to the instance. So this could be like Splunk or Sentinel or Defender, whatever. There are a whole bunch of built-in queries in Mystic Pi. But here we want to tell it to also load any queries definitions it finds in these paths. Let's just run that, and hopefully I don't need to re-authenticate. And we're also here going to, oh, I do, how annoying. You won't see this, but I'm going to switch away for a moment to see if I can actually authenticate. Welcome yourselves for a moment. And of course, you can't type properly when you're doing a presentation, particularly when it's off screen. Okay. Man, I had authenticated before, but okay. So the reason we need to authenticate, it really is not for the queries themselves. It's that during the connection request is when the queries that are defined for that query provider, when they're dynamically added to pivot functions, if it's appropriate. So we should have now, we called our query something kind of odd to make it stand out. Get logons for host JT for Jupyterthon. We should have like help for it. So it's there, it's attached to our query provider. That's a good start. And it gives us some elementary stuff that it's taken from our query definition, like the definition, the names for all of the parameters and that kind of stuff. So since it has host name as one of the parameters, then the pivot mechanism will say, oh, this is something that's applicable to host. I'm going to add that to the host entity. And we should, I'm hoping, be able to see this. There we go. So there's that's another nice thing about kind of this limited entry points that you can use IntelliSense or kind of tab completion to discover stuff that's there rather than have to know where to import it for. And we should, as long as this host, we should be able to execute it and get some results. I think I put a yes. Okay. So one downside of live demoing is authentication sometimes doesn't work as you expect, but at least the query works. So this is like getting something from a live Sentinel instance. That's about all I had. There's more information about pivot functions in general, the mapping. So if you put account name, that will map to account, IP address, that kind of thing. So what to name the parameters so they correctly mapped, creating custom pivot functions, and also a thing about our data providers and queries and creating custom queries, a bit more detail than I've been able to give you in this short section. Okay, and I think that's about all I had. Let me see if I can find it.
That was great, man.
Okay. Oh, right. I thought I might have gone off the air for that.
No, you still have like 5 minutes.
Oh, really?
Yeah, you still have it's until 3:55. So yeah.
Wow.
The first thing I was gonna say is like that's it's great to see all the functionality, how it has a structure, like how it goes, like when you pick an entity, like just having that capability for a SOC analyst or just a data analyst in general, like in security, right? I think that usually when we start building, some of this tooling, we want to have all these features, and sometimes we just build so many things. And, usually when we think about, for example, analyzing data, we are presented with an IP, a host name, a user, right? Like sometimes that's like the main step number one when you are dropped into an investigation, right? So I kind of like to be able to structure some of that way, by an entity, for example. So that was something that I did not know about Mystic Pi, but I think that's the extension that you guys are adding, or that's already Mystic Pi, right?
That's already there. What I just showed you is here. It's actually been there for kind of a while. This is one of our experiments with widgets. It's not executable, but it allows you to kind of browse around the different entities, and you can see the different kind of functions that are available. Whoa, scrolled off the screen. We bring in the help from the underlying function, so you can see what it's about. There's a bit of a search interface. So it would be nice to be able to, I think we were talking about in the chat with I think it was Ryan actually. It would be nice to be able to use this to assemble like a pipeline. It's like, oh, now I want to do, IP address, some risk IQ stuff, and then add something else, and you could add it to a pipeline, and then you just save the pipeline and then run it against a whole bunch of these things sequentially. Would be kind of a nice thing.
Yep.
Yeah, I don't know whether anybody has any questions, or you can.
There is a question from Discord. Cybermonk asks, first they say that the extensibility is amazing. Are there any plans on adding more extensibility, like plotting, etc.?
Right, for plotting specifically, well, we are trying to make our plotting things more. We certainly could do that. So we're trying to make our. Originally, the first process tree is a really good example. That was originally that only worked with Sentinel data essentially, and then we made it work with the vendor data, and now it's pretty generic. So it's not extensible really in itself. It just have a lot of parameters. You can control the execution. I think it would be certainly possible to add. I think it would be possible to add additional plotting functions to our MP plot pandas extension. It's certainly easy for you to do that yourself. Most of the work in plotting functions is writing the code. There's I showed an example earlier on of 50 lines of code, but some of our things have got hundreds, several hundred lines of code, and it can be kind of quite complex to build. But if you can do it, and if you want to submit it as a contribution, Ashwin, who's going to be talking a little bit later, has just submitted a PR for a heat map. So we're certainly very keen on adding more functionality. There are some areas like threat intel providers that we wanted to make it easier for people to add their own. So if you have an API, it could be an internal API, maybe you're a government agency and you don't have access to the internet, but you have an internal API that allows you to access TI stuff. A lot of our threat intel provider classes were very much kind of boilerplate code. They all did the same kind of thing. So one of the ideas we've got half done is being able to define the provider as just a YAML file, this is the URL, these are the subpaths it supports, or the API parameters for different kinds of IOC types, and bang, it kind of you import that and it creates a TI provider. So there are some aspects, and also we're interested in if there are people have ideas for areas of extensibility in other places, we're definitely interested in that.
Very cool. Thank you.
Cool. Awesome. Thank you very much, Ian. One thing that I wanted to share before we move to the other talk. Let me see if I can share my screen real quick. Oh, here it is. Yeah, so I can just add my screen. So Ian, and then also other presenters that are sharing their notebooks. So, for example, if you wanted to walk through everything that Ian just showed you, go to the Infosec Jupyterthon side, and then on the left you have sessions, and Ian's should be this one right here. I guess that it's capturing this title as your title rather than this title, and
Okay.
that's, this one is like an HTML, I think.
Oh yeah, I just
Right. So,
a little knowledge is a dangerous thing. I mean, messing around with like CSS.
Yeah, exactly. But that's how you can, anybody who wants to follow, or want to walk through again, it's all there. The same notebook. Once again, this is a Jupyter book, so you can, embed notebooks in there. And also we just uploaded the exploratory thread analytics using Jupyter notebooks from the talk from Saksham earlier today. So that one is also there with all the Elasticsearch libraries and how to do all this analysis. So just keep an eye on this. We're going to be adding as speakers share their notebooks, and of course some speakers do have a lot of notebooks like Camilo. So maybe Camilo would just go to this GitHub repo and you have everything there, right? So just FYI. Okay, so let's move to the next talk, and we have Pete. Let me just remove my screen in here. And yes, so we have Pete with us. Pete is also part of our team at Microsoft, and Pete today is going to be talking about how to, I guess, get some information from Intel reports. And Pete is actually a principal security researcher now for Microsoft. In his bio, he says something about security, but Pete is actually, but Pete is leading the threat research side of the house when it comes to solutions such as Microsoft Sentinel now, and there's a lot of awesome work that it's also being applied to how do we use notebooks, right, for automation, for investigations in general. So Pete comes with all that experience that he's done it. So now how he can just use notebooks for some of that. And today he's going to talk about threat intel, right? Data mining for threat intelligence reports.
And by interesting coincidence, we have like in quick succession, me, Pete, and then Ashwin are like the three main original developers on Mystic Pi. So it's like a bit of a get together.
Yes, that's also a thing. So Pete is also one of the main, I guess, contributors and developers of Mystic Pi, as well as Ian and Ashwin. So yeah, cool, man. Happy to see you here. All right.
Yeah, thanks for the intro. Let me just share my screen. We can get going. Cool. Well, as Roberto said, I'm part of Microsoft Security Research as well, and I work with Roberto, Ian, Ashwin, and others on basically trying to create solutions and content that makes the lives of SOC analysts a bit easier and a bit more efficient and effective. And so what I was going to talk about today was something I've recently been working on, just like a small project that gives, I think, a good example of how you can take Jupyter notebooks and apply it to a task to kind of add value really quickly. So if you're an experienced Jupyter notebook user, you'll probably think this is pretty simple and straightforward. But if you're new to notebooks, this might give you a good example of something that you can kind of pick up and go and implement yourself. Also, apologies if you hear some banging in the background. I got contractors in. Hopefully, they're in the basement. I'm upstairs, so hopefully it's not too loud. But apologies if you can hear that. So my presentation today is all going to be in a notebook, or a couple of notebooks. But as Roberto said, I'm going to talk about threat intelligence reports. So threat intelligence reports are great. There's loads of them. I have a huge reading list of threat intelligence reports to go through. The things on my reading list probably represent about kind of 1% of the threat intelligence reports that are generated by all the different vendors these days. So kind of keeping up with them is really a full-time job, probably more than a full-time job. And so what I wanted to think about is how, as a SOC analyst, can you gain value from these reports without having to necessarily read them all, and how can you do that quickly? one of the things that you can do is at least trying to extract indicators of compromise from reports and use them in your analysis. And there's a bunch of platforms that you can integrate that kind of collate all this stuff, but not every indicator is in every platform. Sometimes you receive stuff that's not publicly released. It might come via email from a partner, or if you're in the government space, CISA or NCSC or CCCS might provide you a report that's not integrated with these platforms. So without reading them, how can we extract stuff? And this is made a little bit tricky by the fact that every report is a little bit different. So, sometimes you get indicators in line in the report with these nice defanging brackets. Sometimes you get them in these nice tables with, grouped by indicator type. And sometimes you get them in whatever this is. Like, I don't even know what they're trying to do here. Headings don't line up. You've got multiple indicators in each field. It can be a bit of a mess. And going through as an analyst, finding those indicators and putting them into your system and vetting them is a bit of a horrible manual task. I know I've had to do this in the past, of kind of like take these indicators that we got from these reports that aren't integrated with any other feed, put them into our TI platform and push them in production. So how can we do this with a notebook? So we're going to import some useful stuff today. You're probably familiar with some of this. We talked about Mystic Pi quite a lot. Unsurprisingly, it's in there. So it's pandas, beautiful soup, and HTTPX. So HTTPX is just a kind of HTTP protocol package similar to requests. If you've used requests. And the first thing we're going to do is, like, rather than read the report on the website, let's go get it.
Right. Hey, Pete, can you zoom in a little bit on your?
Oh, yeah, sure.
Yes, please. Thank you.
A bit better.
That looks better. Yes.
Cool.
Thank you, man.
So yeah, I need to import my stuff first. Always forget to do that. But once that's done, we can use HTTPX, and we're going to get a security threat intel report. This is a Microsoft one, a recent one that came out on supply chain leaks. And if we go get the report, we get HTML. Great. It's not really a lot we can do that. But thankfully, Python is really helpful for this stuff. So we can use a bit further down, keep going, lots of HTML, loads of HTML. Cool. We can use Beautiful Soup, which is a package that helps you parse out various formatted data like HTML into more easy to use data structures. So we can tell it to go find all of our text blocks in that and return them. So it goes through, it's taken out all of our HTML tags, and it's given us all of the blocks of text. This is getting us a little bit better, but these reports still contain, loads of SEO, loads of references here, the URL of the blog, all of this effectively garbage. So how do we find the nuggets in even this formatted data? And again, there's a lot of it. So one of the things we could do is write some regex to go through and parse all of those fields and look for patterns of IP addresses or URLs or file hashes. Again, fairly structured items. We should be able to go and find them. Now, I don't know about you, but I really hate writing regex. I can never remember how it works exactly. I can never get it right first time. It's just one of those things that, I've done it for years, but I've still never mastered it. So rather than trying to do it here, I'm just going to use Mystic Pi's IOC extract feature, because handily, someone, mostly Ian, has written all the regex for us. So what we're going to do is get all of the text that we extracted with Beautiful Soup above and pass through it looking for a bunch of indicator types. So things that are common as shared IOCs, IPs, domains and URLs, and file hashes. And here we see it goes find them really quickly. And we get some useful things. These are the IP addresses. But there's a few challenges. Firstly, they've got those annoying square brackets, so I can't just pick up and use them. Secondly, we've got all of this stuff, like CMS domains, links to other parts of the blog and the blog elements, images. Still not really useful for us. Like there's some value in here, right? But I don't want to have to go through and work out which of this is useful and which of it isn't. So the first thing we can do is get rid of those square brackets by using a new feature we added to Mystic Pi recently, which A, looks for those square brackets in the indicators, but B, just gets rid of them as well. So, nice clean IP address for us to use. But yeah, we've still got all of these definitely not useful IOCs. So another thing we can do is go through the report and try and take out bits of HTML we don't care about. So if you think about a HTML file, there's lots of elements in it, like headers, metadata, images, scripts for running, analytics and all the other things. So what we can do is go through and look for these common tags and just take them out. Like we don't care if an IP address or an email or a URL or something is included in a header or in a script. So what we can do is just go look for the main body of our report and run the indicators again. And this time you see much cleaner list. Just got a bunch of those IP addresses, which is actually what we want. If you're really paying attention, you'll have noticed these IP addresses are actually the ones from the first screenshot of the Intel report I had right at the top of this notebook. Now, IP addresses or indicators shared and extracted like this are great. We've saved ourselves a whole bunch of time here. But you can't just take indicators that someone tells you are malicious and start sticking them into production, because bad things will happen. Indicators can be wrong. Indicators can be low confidence, and we're not extracting things like that here. Indicators can be really out of date. I know I've seen feeds from what we would say were very trusted sources of threat intelligence that include things like google.com. So how do we know they're good? Well, one of the things we can do is see if other providers know about them. So again, kind of double validating indicators can be one useful step of doing it. So here we're using Mystic Pi's IOC lookup to see if any of those IP addresses appear in other threat intelligence providers, just kind of giving us a double validation. So here you can see Kestrel live demo. I've hit too many requests on the Grey Noise API, so I've been testing this morning, but some other results from other providers at least. So now we can go through and say, these are the IP addresses that we extracted from that TI report that appear in another TI source. And we're probably pretty happy that these can be used. So we've done a lot of work here, but we now got a replicable pattern that next time I need to go look at a TI report and see if there are any IOCs we want to put into production, I can put in that URL of my report or the body of my report, run this and extract some IPs. But what if you want to take it to the next level? What if you want to kind of make this a bit more exciting? So one of the things I've been working on, which is kind of why I'm talking about this today, is something for Sentinel that is designed to kind of scale this up. So what I'm going to do is just run all these cells. And what this notebook does is you can pass it in a feed of reports. So rather than having to give an individual report, you can give it here the RSS feed for the Microsoft Security Intelligence report, tell it what IOCs from those reports I'm interested in, tell it what time frame to look at. So I want to get all the reports from this feed in the last 7 days. And what it goes off and does is uses something called feed parser, another package to parse out all the URLs of the individual reports in that feed. Goes through and uses, again, Beautiful Soup to extract out some of those IOCs and reports. And you can see 7 reports. It's just done quickly for me. We get the indicators out of it and look them up in TI, which gives us kind of our vetted list. we also go and look up those indicators in our data set, in our Sentinel workspace, to see if, do they appear already? And that's a good way of validating. If an IP address in the threat intel report appears 1 million times in the last week in your own data, it's probably a false positive. We can then also go do some other lookups, like if it's a URL, we can go look up against open page rank to see if it's a high prevalence domain. We can see if it's a known Tor exonode based on the IP. We can go see who owns the IP it is. Like, does it belong to AWS or GCP? And likely just ephemeral infrastructure. And then what we can do is put all that together and get a nice filtered list of results. So we can see here that we've got a bunch of IP addresses and domain names that are included in a bunch of different reports. You'll see that there's some false positives still in here. Infosec Jupyterthon. Don't think that's a malicious URL, or at least I hope not, because I've been visiting it lately. But the reason we include stuff like that is because, it's not in any other external TI feed, but it also doesn't appear in our own data. So we want to include stuff that other feeds might not know about. So we make that trade-off. But again, because this is all in a Jupyter notebook, you can kind of create any sort of additional filtering you want, any criteria you want. So here I'm saying don't include any URLs or domains if the domain's in the top 100,000 open page rank score. But you can set this to whatever you like. And again, I'm saying as long as there's less than 100 results, we're considering that kind of a low noise indicator. But again, you can tune that to what you like. And then finally, we automatically add these indicators into our Sentinel workspace. So we're completing the end-to-end workflow here. And see, it creates lots of indicators. And if I pull up our workspace, this is our Sentinel workspace I've uploaded them to. And if we refresh, we see, hey, they're all our indicators. Nicely populated for me, automatic matching, all nicely from Mystic Pi as well. So what we envisage for this is it's the sort of thing that you would automate the execution of the notebook with something like Papermill, pass in the feeds that you're interested in, it does the job for you, provides you with indicators to go look at. You can also look at extending this a bit more. I wanted to share, this is not my work, so our colleague Varney has done a very cool ML notebook that is taking this next step by not only extracting IOCs and providing them to us, but also using GPT-2 model, I think in this case, language model, to try and, based on the text in the report, infer what MITRE techniques are being talked about to include them in the report as well. So whereas in the indicators we just uploaded, we're just saying what report they're from as a context, we could also start including this context about MITRE attack techniques, or if you wanted to expand this further, you can include extracting context from other elements in the report. So we're not quite there yet, but there's hopefully a place not too far off where you could have a notebook that reads, understands the reports for you using, GPT-3 or GPT-4 when that gets released, and effectively does your TI vetting for you. Now, at this point, you might be thinking, why am I using a notebook for this? I could just do this as a Python script. Absolutely, you could. But what I really like is we can see we go from, here's me just playing around with the data in that first notebook and exploring what it looks like and how it works, then into kind of more of an operational model, and then including ML elements that I can see the output of and understand in the third notebook. And really, this is why I love using notebooks and stuff like this, because you can, develop and expand as you go. And using things like Papermill, it's very easy to kind of operationalize notebooks into a standard production process. And not just for security, but companies like Netflix have pioneered this for years. They use notebooks in production environments for a whole bunch of different things. So even if you don't necessarily need the notebook as the output, they're still a really great place to develop and execute your Python code. And so with that, I will be sharing some of these notebooks, so you can go kind of have a look and steal some of my my development code to use yourself. But hopefully this has given you a good idea of the little things that you can go use notebooks for to make your life easier from day one, without having to necessarily be an expert. A lot of this stuff is very simple, especially when you're using packages like Beautiful Soup and Mystic Pi and all those things to kind of handle the hard stuff for you.
Cool. Hey, thank you very much, Pete. It's I was kind of laughing at some of the questions were about like what's being built in your basement right now.
Yeah. Bad timing. But...
Or is there a dragon in the basement? It sounds like some creature that's trying to get out. Really angry.
But thank you very much for just continuing, not even like stopping your thoughts, because I think that kind of made it easier to follow through the whole thing, right? Because myself, I would have been like turning around, being like, "Sorry, guys." So I really appreciate it. But to your point of like why a notebook, right? I think that being able to structure it, add text, visualizations, code, probably hide the code, even create like a little dashboard, things like that, and then be able to have somebody replicate it as well. I think it's like the reason why it's like super useful. Now you also showed an example with Sentinel, right? But I think that the main components of the notebook could be used against any other sim that allows you an ingestion of the results of the enrichments that you do with your notebook, right? So
yeah, absolutely. So the Sentinel integration is just taking an API at the back end and just formatting the data and passing it across. So Sentinel's there in Mystic Pi because it's our product, but it would be relatively easy for you or even ourselves to extend that out to whatever platform you want to use.
Yep. So any questions? So Ian, you have a question, or maybe one from the chat? I wasn't looking at the chat.
We were having a debate about, or Joyce might have something as well about regexes. I said that I feel like they're the haiku of coding. I really like regexes. That wasn't a question, but it was like also I think about HTTPX. Like we've kind of transitioned from requests to using HTTPX, and request is like in maintenance mode, even though it's a really, really popular package, and one of the most popular on Python packages. But the authors said that they're not going to do any more development on it, so it's never going to be support async and stuff like that. So HTTPX is a plan of drop-in replacement, and more or less to prove that, somebody submitted a PR. I kind of asked like, hey, we'd like to do this, replace HTTPX, and it was like a sort of search and replace where you see requests, just put HTTPX, and it kind of works. And we didn't really change any of the other code. We enhanced a little bit. It was kind of awesome.
Yeah, they've just released their version 1.0 into preview, so they're about to go 1.0, which will find a nice base and a good time for people to adopt it if you're currently on requests.
Yep. Joyce, do we have a question?
There is a question in the chat. One of them being, is this notebook available? And I know that we talked a little bit about making these available, like all the notebooks available. I don't know if there's anything else that you have to add to that, Pete.
So yeah, it will be. So the MITRE tactic inference that Varney created is currently available via the Azure Sentinel Notebooks repo. It's currently in PR, but it's due to be merged. The other TI validation end-to-end notebook I will be releasing very shortly. I've still got a few tweaks to make, but yes, we will be releasing these as all as open source. I can share my Jupyterthon presentation notebook as well if you like. It's pretty basic and straightforward. But yeah, if people are interested, let me know and I can stick it into the Jupyterthon repo.
Yeah.
And there's another question asking, is there a way to add other TI sources to Mystic Pi, like in addition to the built-in TI sources?
Yeah, so I mean, maybe I'll let Ian talk about the recent changes to that because he knows them better than I.
So I could share the code. I mean, it's at the moment, like all our TI providers are kind of derived from the same class, so it's relatively easy to create a TI provider, and it is an API. Like if you've written your own code, a local module, you can load a TI provider dynamically from that. What we were planning to do is have a little bit like we have with queries to be able to define, I think I mentioned some about this earlier, define TI providers as like a YAML in a YAML declaration. So this is like the endpoint, these are all the IOCs it supports, and these are the kind of parameters, and this is like how you get the severity out of the response. So that's kind of halfway developed. I'm not sure it's like a huge saving over writing code, but it's like, for some people, it's like much more approachable. It means that we can have a whole bunch of like TI sources, as long as they have a HTTP endpoint. If they don't, then it's a little bit more complicated. But if they have an HTTP endpoint, they support like common things like API keys in parameters or query string or something like that. You can create one yourself, and you can have your own little private set of TI providers, or you can submit them if they're public things, submit them to as additions to the Mystic Pi code base. I'm sure everybody else would be grateful to have them, because we have a lot of requests to add other TI providers, and we're hoping that would democratize the ability to do that.
Yeah, and I think if you've got as Ian said, if you've got a HTTP endpoint that exposes your TI provider, it's probably one of the easier contributions to Mystic Pi you can make. You can look at the other providers and update. It's basically update the URL that you're hitting, and then update the piece that shows in the response where the various elements of the data coming back are. So it's a good potential first contribution for people.
I also, in the channel, I didn't get to share it in another channel, we've got like a discussion document for this extensible TI providers. So feel free to add some comments to that. And yeah, or if you need pointers around code, contact me or Pete. I'm happy to talk. This is becoming a bit of a Mystic Pi show. I'm trying not to talk about Mystic Pi for like half an hour.
That's good. All right. So I think that we are on time for a break. Thank you very much again, Pete. We do have a break of 10 minutes, so we should go back around. That doesn't look like 10 minutes, but 4:35. So that would be almost a little bit over 10 minutes, 12 minutes. So 4:35 p.m. Eastern time. Let's go back. Let's take a quick break. I'll get some water and go back. We do have two more presentations for the day. So just stay with us. We have two more. All right. Thank you. See you in a bit.
See ya.
All right. Let's see. Ian has his song playing. There you go. All right, cool. Yeah. So I thought that Ian just let it play. Thank you, Ian. Let's see.
I'm not sure who it was meant to be introducing Ashwin. Of course.
Oh, there you go. Yeah.
Yeah.
I was being like making sure that I have the time as well, but
I know I was asleep there listening to. I don't know how like the music's sounding on the stream. I keep kind of going out and checking, but like in the studio, it like he plays like 3 seconds and there's a gap, and then another 3 seconds, like a really weird like lag. I don't think it's sounding like that on the other end, but
it sounds good. I mean, it sounds okay. Yeah. Sometimes I guess there's like a little skip, but it's not noticeable. It feels good. Once again, like it's like a massage, just like closing my eyes.
I was falling asleep there. Well, quite early for me.
Okay. Yeah. All right.
Okay, so to me, Ashwin needs no introduction, but that's because I've known him for quite a few years. So Ashwin's a senior threat researcher in what used to be Mystic, is now kind of Microsoft Security Research, in the same team as me. As I said, he's one of the early kind of maintainers, contributors to Mystic Pi. Does lots of things though, produce some amazing kind of Spark anomaly detection work, and written several really cool kind of compelling notebooks. So very keen to hear what he's going to present to us today. So without further ado, I'll hand over to the man himself. Hopefully he'll unmute himself before he starts talking. There we go.
All right. Yeah. Sorry. I have like a double mute, so
double mute. Dangerous.
Yes. All right. So yeah, thanks for all the introduction. So yeah.
Tasha, your camera, I think, is pointing to your chest. Well, there you go.
That must have been very weird. So thanks for.
Yes. And I think that maybe you can zoom in a little bit. I don't know if people can see that. Yeah, right. I think it looks good. It looks good, right, Ian? I think it's good size right now. Yeah. Yeah. Okay. Awesome, man. Yeah, just making sure that people can see it. Thank you.
Yeah. So yeah. So love this format. I think 15 minutes, no slides, notebooks, and just quick presentation. So yeah, let's start. So a bit of background on this one. I think I took one of the data science course. It was like a boot camp a few years back. And then it was primarily based on R language. And then at the end of the course, we had to pick up a capstone project and then pick up a data set. So I picked up this data set and then did this capstone project in the R. So I thought like it would be a good idea to port it through Python and then maybe show like a similar capabilities. So I think I was able to port most of the things. There are like some cleaning and some data quality issues that I evaluated like this. I have to write like a lot of code and within a short period of time. So this is going to be like a mix up. Like I'm already picking up a clean data set from my already R code and then continuing further this analysis, right? So yeah. So the reason I think it's slightly probably unusual data set as a threat hunter, like you won't be you won't need to basically analyze like lots of passwords unless you're working for like password manager or like some sort of identity based company, right? To understand the trend. But the idea was for me was like picking up a real world database and then basically show like what are the challenges that you can run into, and then how do you get past to that challenges and then do your traditional data analysis and threat hunting type of work, right? So and I think you will encounter like similar type of situations. at least I've seen when you're engaged into an IR engagement, maybe you'll have to do a forensic analysis on a box, and then we suddenly find out, like, let's say some of the logs are not being sent to the your traditional SIEM or analytical tools, right? So suddenly you'll have like this large set of log files sitting, and then you'll have to just manually skim through, or like probably find out certain tools to ingest those, and then do that analysis. So this kind of falls into that sort of use case, which is typically rare, but just wanted to cover this scenario, right? So let's start with this database. So you may have seen like a lot of ongoing news, like every now and then, like somebody has dumped a large database, clear text password dump publicly. So this was like probably 3-4 years back, like when there was like 1.4 billion clear text credentials were discovered into the single database. This was called as a which is like combination of multiple leaks. So I thought like this will be a good idea to just pick up like what we can do with this data set, right? So if you start from here, so in order to so I have these typical steps into the workflow, like starting from data acquisition, uh, doing the preparation, analysis, enrichment, and visualization, and lastly concluding, right? So this database is actually 41 gigs file with 1980 file, 41 gigs size with 1980 different files, right? So in order to get this data, there's this pastebin link that I found. uh, Again, like some of these links are down, but the torrent link is still active, so I was able to download this torrent. Obviously don't do this from your co-op desktops or laptops. uh, do it from VMs and other things. uh, I wanted to pick up the original dataset instead of just doing the compressed version. There are many versions of these datasets into like some MySQL database or SQL, or little bit of cleaner. But I started with the original, like 41 gigs files, right? So if you see the database, once you download these entire datasets, you will kind of have this typical hierarchy where the B stands for like the email IDs starting with B, and then the second letter, and then third letter. So they have this kind of hierarchy, and then underneath that there will be a text file which all the credentials, which are in like basically username colon password type of format, right? So they have also like provided a handy script, like which you can basically do like search if you wanted to do quickly search for specific username, passwords, and other things. And then they have also provided some kind of metadata files uh, which will tell you like what are these breaches came from. So if you see this imported log file, you'll see like a lot of individual standalone uh, breaches with the database dumps. So it has mostly Yahoo, LinkedIn, and some of the famous uh, uh, database dumps. So the first things, so as I was telling, I did not do the cleaning part through Python, but I basically picked up like my existing R code, which you can find it on my GitHub. And then this notebook is also published into my GitHub link. I'll post it into the Discord after this talk. So basically, all of these files are were present without any extensions. So you could, I've seen like there were issues, or like probably it's much easier to load files with extensions with pandas and other formats. So I basically ended up just using this one liner to add extensions to all those files. and then run through the kind of quick stats. We have 1986 files with 1.4 billion records, so that matches with what the news was saying. And then I basically look for some of the data quality issues, to see if it is actually a real breach or something else, right? The interesting thing is I did not find my own username credentials in that, which was funny and also suspicious, if it's even real. So I came up with some criteria to see if this is a real breach, right? So I found few entries with which has a same email ID and same passwords, which is 647k, which is 0.04%, which is interesting, but I've kept it. I'm not sure if there may still be possibility that people can have a same email ID as same password, right? I found there were a lot of duplicates, 200,000 across the data set. So I basically removed those duplicates. There were also a lot of files with just basically null characters. So those were not, we cannot parse it, or we cannot just make anything out of those files. So there were 100 files, which was around 2 gigs, which is 4% of the data set, which is totally unusable. So again, I'm coming up with certain criteria so that I can reduce the initial data set, and then coming up with some kind of real data set that we can analyze for further patterns, right? I also found out some emails which were having no password, and then some emails have less than 6 character, which is again probably not possible, because most of the leading websites have this password complexity to have at least 6 characters password. So even though, let's say, the email ID was saying yahoo.com, it may not be that particular email.com account. It may have been for some other service or something like that. But I basically ended up removing those entries, which were 2% of passwords, which are basically less than 6 characters. So now we have this username password pair, and then I basically passed into 4 columns, basically splitting up into email into email ID and email domain, so that I can run some statistics on high level statistics. I'm basically not interested on user level statistics. So how can we find out certain high level trends from the databases? So let's move quickly. So in this case, I'll show a quick demo of DAS data frame. So again, this is where the pandas will not scale. If we have if we try to load these 1,000 to 2,000 files with more than 40 gigs, you will not have that kind of memory. And then even if we are able to load the initial data frame, as you go forward and then do some certain further analysis, you'll have to make copies of data frame or do some in-place operations. So it will not be scalable. So again, there are many options are there, like Spark and a bunch of other things. I decided to give a try for the native Python libraries like Dask, Wix, and other things. So Dask allows to just basically provide the base path, and then it recursively scans all the files inside it and then load it. So for the purpose of this demo, I'm just basically loading the first part. I basically clean the data set into 9 equal parts. So this is kind of basically 10% or probably 6-7% of my data set, right? So as you can see, in this directory, we have around 74 files. So if you have not seen Dask, and I think I've seen some conversations going around in Discord as well. So Dask basically is somewhat similar to Spark. It's kind of lazy operations. So even though you have basically loaded the file, it's not actually has allocated memory and then started doing operations. unless until you call certain operations, right? So let's say this is the simple kind of like similar to pd.read csv, and then providing all these files. uh, Again, I'll have to add certain kind of parameters, because the database has like a lot of non-printable Cyrillic and other characteristics. So the default encoding and other things were not working out. So I basically use this encoding. Let's move quickly. So this is kind of how the final data set looks like. Again, I'm hoping like this is not one of our passwords or usernames, right? So this is like a sample. Again, I'm just showing like very basic example of how the DAS can be used. So this is like on the bigger data sets, if you want to just filter out certain values. This is similar to pandas. However, if you try to put it out, it will not do unless until you call compute, which will basically kind of collect and do that sort of operations. So once you call the compute, it will basically convert that into from DAS data frame to traditional pandas data frame, right? And then from there you can you'll be able to do all those sort of operations. Again, you can do similar type of group by or that type of operations. Group by again does not scale well. I was not able to scale it on entire data sets. Again, for DAS, I think it needs a good knowledge of your underlying data set, like how to best partition and how to best optimize, and then do like optimized data analysis. I think Spark is much better in that comparisons, which takes care of a lot of that optimization, and certain cluster level settings are also applied, so you don't have to worry much about those things. But then again, just keeping to the interesting parts. So for few group by operations, I basically did some generated certain data sets. So this is one data set where I can basically see like how many, so based on the password length, how many distinct passwords, distinct domains, basically some summary statistics, and then see like how we can visualize this. So you can see like the password length ranges from 6 to 15,000. Again, this looks like either machine generated or like some other garbled data, right? Again, all of this analysis is based on the what data is available publicly. There's nothing that we are doing on our own, right? So I'm just highlighting whatever we are seeing in that public database. The another thing that I've done is basically generated another summary data set, which will be summary by domain. It has like basically summarizing based on the email domain, so that I can generate some high level trends from there. So once we have like a email, like once we generate some group by and some summary data sets, I was thinking about like what can I do enrichment on these data sets to be able to extract some crucial information, right? So one of the data set that I came across was the Fortune 500. So basically all of the S&P 500 companies have these data sets, again stocks or something that you have seen. But the interesting thing that we needed is like, let's say for this company we have walmart.com, right? Again, not every company will have the same email domain, but I wanted to start up with this analysis and then see like what we can find out, and then if we can generalize this to some high level trend, right? So based on the this data set, I basically wrangled and then created this smaller data set, which I can then join with my original summary domain data set, right? So once I join that data set, I basically have this additional enrichment, so that I can see like how many of those domains are from Fortune 500 companies, and then some of these, like let's say which sector they belongs to, and then if we can identify certain common characteristics from those things. Right. So some visualizations, I think these are like some basic visualizations that I plotted, just understanding like the password length distribution across the data set. So again, I've been considering only above 6, so it starts with 6. We can see like it gradually start decreasing, like 6 to 10 is kind of most of the data set. There's a unusual spike into for a 32 character length, which is kind of interesting to see, like why this is causing. Another thing that I was able to do is like basically categorize that entire data sets into sectors. So can we see basically what are the password trends across, let's say, financial kind of domain, right? So as you can see, like in this data set, so before I go forward, I think here when I generated this, when I joined this data set, I was able to join with like around 430 domain, which is basically almost all of the 500 companies, right? Again, there are false positives that I've seen because like some email domains are like basically 2-letter or 3-letter domain names, which may not be true and may match to like certain non-related things, right? So but if we rely on this, almost 67 80% of data set we were able to match with the S&P 500 companies, right? And then excuse me, and then the sectors basically tells us like majority of these companies were from the financial and energy domain, and then followed by retail and technology and other things. Another thing that we can see is like what are the password trends across the Fortune 500, which is kind of like from 6 to 9 or like 11, 15 are there, but majority of those are again in the 6 kind of 6 character length, right? So again, I think I did this very quick demo for from the Python, but if you want to check for the R version, I was able to do some additional statistics, like I can basically extract some more features from the passwords, so such as like how many special characters are there, how many alphanumeric, how many digits and other things, and then try to basically predict like if we can associate that with a certain email domain or that sort of things, right? So you can do like some sort of regression models or something that similar type of things, and then train your data set and then try to predict like based on the password characteristics, can we predict like it could be one of the email domain based on the data set that we have seen, right? So those are kind of like things that we can do based on the data sets that we have available. Again, if we see like the real world data sets are much more messy, like you'll have to do a lot more cleaning and other things. Fortunately, like as analysts, like we get like a lot of powerful analytics tools, so we kind of take things granted, but like if we ever have to get this such kind of data sets, I think Jupyter Notebook and some programmatic capabilities will definitely come in handy. And then you can do like some similar type of enrichment visualizations to get some common insights, right? I've listed some links in here. Again, if you want to check out my whole R code, there's also like a paper which kind of goes into detail, like what else I've done on this data set. If you want to take a further, this is again like 2-3 years old, so just take things accurately. Yeah, I think this is pretty much I wanted to just share with the community like how Jupyter Notebook can be helpful in these kind of scenarios.
Hey, that was awesome, Ashwin. Thank you. And I was super pleased that you showed Dask in operation, because I think it's a kind of cool thing, because it allows you to like virtualize large amounts of data do things you wouldn't be able to do, and also kind of natively utilizes multiple CPU cores. And if you're really ambitious, you can deploy clusters like a kernel VMs. Yeah, that was awesome. It's kind of surprising how many people in the financial sector are still using 6-character passwords.
Yeah, that's what I was thinking.
Really?
If they have like a password complexity set up, and again, like this dataset did not have like any context, like if it's actually their own corporate domain, or maybe somebody is using that domain on Netflix. So don't know.
Yeah, I need to go and check on my online banking passwords, make sure they're using something a bit more complex than that.
Yep.
Just check, will we have any questions?
It doesn't look like there's any Discord messages.
Okay. Other than me saying Dask, yay. I don't know what the Thompson library, somebody said. I'm not sure what the Thompson library is. Do you know, any idea, Ashwin? Maybe somebody. Looks like a Thompson library, I think, from Linux.
Yeah, no idea, probably.
Okay, maybe you can explain that in the chat. That'd be kind of interesting. So we're a little bit kind of behind time. If we can follow up with questions on Discord, Ashwin, later on, do check out this GitHub. Also, a bunch of interesting notebooks on the Azure Sentinel Notebooks repo that Ashwin's written. Yep. So thanks very much, Ashwin. That's awesome. We'll kind of move on to our final speaker of the day, Paul. Let me add you to the stream. Paul Kokkoli, did I pronounce that correct?
Yep, perfectly. Can you hear me okay?
Yeah, good. So Paul's a senior software engineer at IBM, and we have a bit of we don't have a personal past connection, but I believe you joined like ISS, which is where like the X-Force branding comes from. And before they were part of IBM, we used X-Force to do a bunch of penetration testing work on a big UK government project that I was involved in. So I feel like we've got some past connection there.
Yeah, I joined ISS in 2004, 2 years before the acquisition by IBM, when we became IBM Security, and I've been here since. Okay,
awesome. So we did have a talk last year that covered some elements of Kestrel that was really interesting. So Paul's going to be covering a little bit of that as applied to like PowerShell decoding. It's a really fascinating project. You should definitely check out the website and repo for Kestrel, because it's like an awesome open source project that I think should have like a wider audience. So without any more ado, I'll get Paul's presentation on the screen. I'll retire to the background and let you take it away. Thanks very much.
All right, thank you. Yes, I'm the co-maintainer of Kestrel. Last year, Jacques Xu, who's the other co-maintainer, did a presentation on it. I'll try to do something different so no one gets bored. But I want to say a lot of really great presentations today, mostly I've noticed two things. They're all Python and they're all very polished. So my presentation is neither of those things. There's some Python at the end, but there's completely no polish. So let's get into what Kestrel actually is. Kestrel is a threat hunting language, and we've got a Jupyter kernel wrapped around it that I'll be showing. But the point of the Kestrel threat hunting language is that we can capture threat hunting knowledge, express it as very high level, capture it and make it reusable and shareable. This is our GitHub repo. A lot of great documentation there, links to recent presentations. I presented at a Black Hat Arsenal this year. Another interesting thing we have here is we've got a binder set up. So you can go and without even the minimal pip install. You don't even need to do that. You just go click on there, open it up in Binder. We've got some tutorial notebooks that I'll show in a second, and you can give it a shot without even taking up any of your local disk space. Scrolling down a bit, here's our very high level diagram. I know it's probably pretty hard to see in the stream, but in a nutshell, Kestrel tries to focus on the what of what hunters want to hunt for, and we let the runtime figure out the how part. So we want you to think at a high level, think in terms of entities and relationships, and not think so much about query languages and what SIM or data source you're looking at. So if we look at our tech stack here, we've got 3 different ways of interfacing with it. The Jupyter Notebook, which we'll be showing today. We also have a command line tool for batch execution or maybe integrating with scripts. And it is actually implemented in Python. So we do have a Python API, and I'll show you that as well. One of the key features of Kestrel is that it's built on top of another project called Stick Shifter. So Stick Shifter is a tool and Python library that lets you talk to multiple different data sources, so SIMs, EDRs, and things like that, and lets you use a single query language, which is Stix patterning, which comes from the Stix standard, if anyone's familiar with Stix. It's a standardized language for dealing with security information. Stick Shifter uses their patterning language as a sort of query language. And what it does is takes it and translates it to the native query of any of the data systems that you are connected to. So your QRadar, Splunk, Elasticsearch, there's a whole bunch. There's like, I forget how many are supported, but their GitHub repo has the list of all the connectors there. I'm actually not going to use Stick Shifter today. I'm going to be using some canned, pre-made data to avoid any, just to make things repeatable. So we've also got some pretty comprehensive documentation for Kestrel, a lot of background knowledge, a lot of the theory behind it, but we also just have a language spec in here where you can come in and get actual help on how to write your Kestrel statements. So going back to our repo, and we've got our Binder tutorials. Rather than running Binder, I've got it running locally. But here's our very first tutorial step 0. So this is not actually a threat hunt. It's just a notebook to take you through and get you used to some of the concepts in Kestrel. We try to include a lot of links to the documentation so that you can read through the basic terminology here. These links will take you back into the documentation to explain what all these concepts are that we're referring to as you go through the tutorial. The first example is here, the new command, which is a way of creating data using literal strings, basically. So you wouldn't typically do this in an actual threat hunt. You would use other commands, but this is just to get us started and show off a little bit about our data model. Our data model is based on Stix, or what used to be called Cybox, the cyber observables. That got rolled into Stix 2.0. We use Stix 2.0 or 2.1 as our data model. So this is just giving a simple example. Here we're creating a variable. In Kestrel, we use variables to refer to lists of entities that we've gotten from our security data sources. So this example is just creating some data out of literals and naming it proc list. And then after we execute that block, we get a little summary that just tells us what we've done. We have a get command that you can use to either acquire data or, in this case, filter data. Because what we're going to do is get the processes from that proc list that we just created, where the name is in one of these names, either Firefox or Chrome. So if we show both, we had 4 processes. We had 1 Firefox and 1 Chrome. So now we've got 2 in this new variable called browsers. So that's some very basic stuff there. When we want to see our actual variables, we've got a display command, and we can choose which attributes, which you can think of as these columns here, that we want to see. So just a very simple way of actually looking at what we got. And then the tutorials have lots of information for people who aren't that familiar with Jupyter, but also have some exercises in them that you can go through and try out as you're learning. The second step of the tutorial, step one, the first one here is where you're actually going to use some data sources. Again, you don't really want to use Binder to connect to your internal data sources. So we're using some files that are bundled up in the repo and in the Binder instance. So here you see we're getting data from this file rather than connecting to QRadar or Splunk or whatever. But normally right here, you would have the name of your data source that you've configured to talk with StickShifter. And that's how you would pull in data. This file is a Sticks bundle file. So the data's already been put into the Sticks format and into the Sticks data model. So Kestrel is going to take the data that matches in that file and keep it in its internal database. When you're using StickShifter, it's going to return your results from your sim, translated into Sticks and normalized into Sticks, and then store it in its local database so it can operate on it from there. So you're not constantly going back and forth to your data source. Let's jump ahead to another tutorial step. This is the find command. So here, up till now, we're pulling data in and we're giving names to these lists of entities that we found, these observables that we're recording the records that we found and giving that a name. But how do we move around now in our mental model of what's happening in our scenario? In Kestrel, we have this find command that we use to follow the relationships from one entity to another. So these are the types of relationships, especially with processes. You can find the child processes or parent processes or network traffic created by a process. As just a few examples. The documentation has this helpful diagram that I refer to often about what the various relations are and how certain entities are related to other entity types. We try to standardize the language so there aren't too many relationships that you have to remember. So you'll see created overloaded here, used in between different pairs of entities. But I think it makes sense and keeps the vocabulary a little smaller. So here's an example where we're actually using the find command. So we want to find the child processes of another process. So we've got a couple of instances here where we've pulled data back. So we're looking in this data source, we're looking for processes named servicehost.exe. Then we're taking those service host processes that we've got and filtering them further to where they have a very specific command line. And now we've got those in a variable named scheduler. So now we want to find any child processes of scheduler. So we just have a very simple syntax, find processes created by scheduler, which is our variable from here. And then we display that. So this is the list of processes that we got back that are children, they're scheduled tasks essentially, because they're children of this scheduler process. And you can do the same thing. Notice here now we're using created instead of created by, and that's because we want to get the process that created the scheduled tasks above. So that means we're going up the process tree. We want to find the parent. And then we're assigning that to scheduler 2. We want to make sure that that's the same as what we got before, just to verify that those are indeed the inverse of one another. And the tutorial goes on with a bunch more examples. But that, I think, gives you a quick peek at what the language looks like. But now I want to pivot a little bit and talk about our analytics and a specific analytic that I implemented recently that I named PowerShell Deobfuscator. So being a software engineer and not a actual security guy, I don't have a lot of security data that I'm analyzing. I'm building tools, but I need data to test those tools. So one day I stumbled across this securitydatasets.com, which is actually created by the hosts of this Jupyterthon. And what it is a bunch of, they've set up a example network, run a bunch of adversarial simulations, captured the data, and made it available. So if we open up this one example, this is one of the Windows atomic data sets. It's called Empire Mimikatz Extract Kerberos Keys. So there's a description here. It's adversaries extracting Kerberos tickets from memory. And here's the data set download. So I saw this and said, hey, this would be great for testing out Kestrel, but I could take this data and try to get it into my SIM, but instead I just decided to add direct support for the format that you guys are using at securitydatasets.com. So I've done that in our file interface here in our from. So what I'm going to do is, instead of trying to use a SIM or something, I'm just pointing straight at the data file posted in GitHub. And it's a very long path here, but this is that zip file. So I'm going to treat that as my data source to test out this analytic that I've built. And what the analytic is going to do is it's going to look at some PowerShell that's had some obfuscation used, so you can't really see what it's doing. And we saw this in an earlier talk, right, where somebody had in their notebook, they had a PowerShell command with a giant base 64 blob, and they decoded it in Python using base 64, the normal stuff you do. So we're going to show you how this is even easier in Kestrel. You don't have to drop into Python. You don't have to copy and paste. So here's my simple first command. Let me start it up here. Oops. I'm going to get processes from this data file that match this sticks pattern. This is our, sort of universal query language. So I'm looking for processes whose binary or image file is PowerShell.exe. So I got a couple of hits here. We've got some issues still with entity resolution. It's hard to correlate some of the records you get back when if they don't have enough information in them. You see the PID here is the same. So these are actually the same, but I just wanted to show you can see this nasty long string here. If I go way over here, I can see, there you go. The command line is PowerShell. We've got the no profile flag, some other flags, and the -enc flag, which is for encoded. So the giant base 64 string after it is PowerShell that's been base 64 encoded, and it'll be interpreted by the PowerShell binary here. So that's not in and of itself malicious. You might be automating some system administration tasks using PowerShell, and it just makes it easier to push that code around if you first base 64 encode it. So we want to see, what that looks like. And as you saw, you could use Python to take that and base 64 decode it, or you can pop it into any base 64 decoder. What you would get is this thing right here. So you get this big, nasty looking thing. Obviously, this isn't something that, some sysadmin or somebody wrote. It's got some really goofy, there's no spacing in a lot of cases. There's some goofy upper and lower case mixing. There's other weird things like plus signs in the middle of strings. So we know this is bad right away. But maybe an analyst wants to take this a step further and try to, figure out what this is doing. So I'm trying to make that a little bit more, a little easier with this PowerShell deobfuscator. So we're going to use the Kestrel apply keyword. What the apply keyword does lets you run code that's outside of Kestrel itself. It's sort of our extension mechanism, if you will. So in this case, I'm going to run some Python code because I've got my PowerShell deobfuscator that's implemented in Python and sitting on my disk, and I've configured Kestrel to point to it. So this name is pointing to some Python code. We've got another analytics interface for Docker. So if you've got some code that you want to wrap and use with your data that you're pulling from your SIM through Kestrel, you can do that just by Dockerizing it and calling it right here. Your Docker image just needs to follow some conventions on how we pass data around in Kestrel. But here I'm going to just run this Python code through Kestrel on our variable name. So this is going to pass the data that's stored in our variable, our process objects up here, into the PowerShell deobfuscator. It's going to run really quickly because we really only had one in there. And here is the display output. The PSD analytic is spitting out an HTML blob that just gets shown in the notebook itself. And what it's done is stepped through, well, it's done the base64 decode and then parsed all of this stuff and tried to pretty print it, normalize the case, undo some of these string operations and some of the other obfuscation techniques. And we've tried to make it something that an analyst could actually read through, so you can gauge just how bad it is. So you can see various things like it's turning off script block logging. That's probably, obviously that's not a good thing. I don't actually know PowerShell very well, so reading through this is, it's still not that easy to follow because there's a lot of really nasty obfuscation happening in here. We've done the best that we can. We've also seen some things in here, like another base64 string that's encoded in there. So we've decoded that and added it as a comment on the line. So it's a URL. So in this case, since this is a simulation, it's just a private IP address. But if this were an actual C2 URL, you could now go and look that up in your threat intelligence and continue your hunt that way. Let's see. And then down at the very end, it's piping something through IEX. So it looks like it's crafting some kind of URL, pulling something down, and then executing it. So it's pulling down the next stage of the attack. I don't have that next stage of the attack, but I think this is a good illustration of how you can use this tool to at least get the next, another step further in your threat hunt and trying to figure out what's happening with this attack. If we go back to the securitydatasets.com, you can see they're using Empire, and they're trying to run PowerSploits, invoke Mimikat. So I'm guessing that's what this is actually trying to pull down and execute next. So the other thing that it's doing now, this was the variable that we applied it on. So our apply keyword, when it runs on a variable, one of the things it can do besides doing a display output is add new attributes to the entities in this variable. So what it's done in this case is also put the decoded version in there in a new attribute called x_psd deobfuscated. So now you can see this is the same thing that's in the HTML output, but it's got, the new lines in it. It's not pretty printed, but you could, if you decide to export this, or you want to do some filtering now, say some of these didn't have maybe some of your processes didn't have any obfuscation, you could filter that list. Here we're doing a sort of simplified filtering step. We're taking the prox variable where this new attribute matches this string. So the filtering is somewhat SQL-like. So the like keyword is similar to it, how it works in SQL. The % is your wildcard. So I want to grab the ones that had that embedded URL in it and then go study those further. And it's just this, that one instance that we found. The next step, and something that's not natively supported yet, would be to actually in Kestrel syntax itself, pull that embedded URL out of there and continue your hunt by looking that up in your threat intelligence, which you could do using another apply analytic that can run X-Force, can run your observables through X-Force Exchange, which is a threat intelligence, IBM's threat intelligence service. Or you can use whatever other threat intelligence provider you want if you want to write support for it, meaning just a simple Python wrapper. I think we also have one for the SANS IP API, and a good one to add would be Mystic Pi. I would like to put Mystic Pi in here and run it through any threat intelligence providers that were configured that way. So that's a future integration that we could add through Kestrel's extension mechanism. Let's jump ahead to Kestrel embedded in Python. So as I said earlier, Kestrel actually is embedded in Python. So if you want to integrate with it in various ways, say you already have a workflow you like and you just want aspects of Kestrel, you don't have to jump wholesale into it. You can integrate through the Python API. So the way you typically do that is you import the session object, which is what you use to create a hunting session in Kestrel. So here I've created a Kestrel session, and this is just now running in Python 3, just regular old Python notebook. And I've copied that same first step from my Kestrel hunt. So this is the Kestrel syntax, right? I'm assigning to procs just like I did. I'm getting the processes from that data source where the binary name was PowerShell.exe, exactly the same. Just run it in Python. The return here is assigned to, I just called it R. So this is when you execute a statement in a Kestrel session, it returns this list of display objects that contain the information. Like if I go back here, it's this stuff, a summary of what happened when you ran that threat hunting step. So if you wanted to see those, you could just print them out, or you could ignore them. But we have different ways of formatting them. This is coming back as a string, or I think there's an HTML method. You can get them back as Python dictionaries, however you need them. We can also get the list of any variables that exist in that Kestrel session. So we just have the one that we created, procs, right? We named it that in this one statement that we ran. There's also this second magic underscore variable that just refers, that's just an alias to the last one that was created. So in this case, those are both the same. Aside from just knowing the variables, we can actually get the data that's in that variable from the session by saying, using the get variable method on the session object. So we're going to put it into now a Python variable named procs. So we're basically pulling it over from the Kestrel session into our Python namespace. And if we do that here, you can see our data is coming back as a list of dictionaries. But, you know, this is a Python notebook. We're going to wind up using, wind up using pandas to do anything interesting, right? Just like most of the presentations we've seen earlier in the day. So since it's coming back as a list of JSON records, we can create a data frame using data frame from records on our now Python variable procs. And there we go. We've got, now it's in a data frame. Here's the head of our data frame. Here's our PowerShell processes, and then all the attributes of that, of those entities. But what about getting data into that session? So we've got different ways of doing that, but a straightforward way, say we had this list of IP addresses that you got from some API or read from a file or wherever you got it from. There's a create variable method on the session. So here we're going to create a variable, just call it some IPs. We're going to pass in that data we got And this is just Python data, right? A list of strings. And we have to, since it's just a list of strings, we need to tell Kestrel what it is. So we're going to tell it these are IPv4 addresses. This is the STIX object type, cyber observable object type for IP addresses. And by doing that, the Kestrel session is going to take that data, create proper IP address objects, and then put them into its internal database. Now we've got them there, and we're going to run a Kestrel statement that gives us info, just tells us some information about a Kestrel variable, some IPs. Remember, there's no some IPs Python variable here. That's the name of our Kestrel variable. If we were to run info on that in a Kestrel notebook, this is the type of output you would see, this formatted output where it's telling you there are 3 entities in there, are 3 IP addresses, also 3 records, because we just have, you know, 1 instance of each IP address. The entities have 2 attributes, value, which is the IP address value, the string that we passed in, and ID, which is what every object type gets. It gets a unique ID. So that was created when we ingested the data. We've got no associated data source because we just jammed it in by creating a variable. We didn't actually read it from a file or from a connected data source. Now let's pull it back out, make sure that we really did do a proper round trip of this thing. So now we're using that same method we used above to grab our Kestrel sum IPs variable, and we're putting it into a Python sum IPs variable, which is a data frame. And here it is in our data frame format now. There's the value column, value, and our ID column, ID, and then these are the unique IDs created when we inserted that data, the STIX IDs. I guess we're running out of time. I can stop there. Yeah, let's just stop there. Questions, comments?
Let me reappear. Sorry, I was just about to cough. Kept myself on camera. Yeah, I think we do have a little bit. Let me check the agenda. I thought we had a little bit more time.
Oh, sorry. I thought... trying to keep it to 30 minutes.
So, yeah, I think Roberto was very kind in, like, I think the 15-minute sessions often had like 25 minutes and stuff like that.
Oh, I can go a little bit further.
Yep.
Real quickly, just so show some very simple visualizations. We've got another analytic that produces visualizations called attribute plot, which is really just a thin wrapper over matplotlib for the most part. So here I've grabbed some network connections from a local file that I had prepared as a scenario beforehand. I'm grabbing any of these network connections that have a domain name listed in them, and it's using wildcard for the domain name. So I pulled 1,997 entities back, so unique network traffic objects. And now I'm just going to use that to do some simple plotting. So I'm going to run my attribute plot extension on that list of connections, and I'm just going to give it an X parameter for now. This is the STIX patterning language for the source address of a network connection. It's a little bit ugly, but that's what it is. And I give it to it, attribute plot. It's going to try to make sense of what it's asked me to do. Since I only gave it an X value, you know, the source addresses, it's going to use those as the X-axis labels. So these are the IP addresses that I got back, a bunch of private IPs, because this was synthetic data I generated. And then it just gives me a count because I didn't tell it what to do for a Y, for a Y axis. We've got, this is the timestamped transform. What that's going to do is take those network connections and apply the timestamp that was on the record that contained that network connection. The network connection itself may not have a timestamp the way that the STIX data is laid out. But every observable that's found in a sticks bundle is inside an observed data sort of envelope, if you will, that does have a timestamp. So this joins those back together and attaches our timestamp back to our connection object. So here we've got the full now timestamp network connections. You can see our source address and destination address and source port, desk port, etc. So now that I've got those timestamped, I want to see what those look like. I want to see my network connections over time. So here I'm just going to use the unique ID on the y-axis, just because I need something on the y-axis, and it's just going to do a simple matplotlib line chart here, where again it's just giving me the count of IDs over time, where first observed was our timestamp. What else can we do? So we're going to take those connections now, the timestamp ones, and I want to group them. I want to look at these in a different way. So instead of just letting attribute plot throw them in a time chart, I want to group them by the timestamp, but I want to bucket that timestamp or bin it into 30-second intervals, and then give me the count of those IDs. And I'm going to name that grouping, just call it result. So what that's going to give us is a little table here. So this result is a simple table of the first observed field that's been binned into 30-second intervals, and that count that I told it to compute. So if you're used to SQL, this is very SQL-like. And now maybe I want to plot that instead of my original line chart, and I'm going to tell it, give me a bar plot. That's what I want. So here's our time buckets with our counts over time. So just some simple visualization features here using matplotlib, nothing fancy, but maybe a good way in a threat hunt to, when you start out with a lot of data, get a high level view of it. And maybe if something stood out, in this case, nothing does here because it's mostly uniform, again, fake synthetic data. But if there were a spike here or a strange dropout, maybe that's something you want to go look at. I could group by, any attribute, really, not just the timestamp. This is just an example here. And we've got a few, let me get my bearings here. So we've got those analytics that I've been demonstrating live in this repo here, our Kestrel analytics repo. And we've got a few that are available as examples. So here's the PowerShell deobfuscator, which got a little bit of documentation in there, shows how to use it either by Docker or directly through Python by configuring your Python analytics YAML file. And then we've got some other examples. There's a data exfiltration model that you can try out. There's a domain name lookups. I wrote a log4shell deobfuscator as well when log4shell was a big thing. Here's our XFE, X-Force Exchange IP enrichment. Suspicious scoring runs over your process objects and tries to score the more suspicious looking process objects based on their command lines or parent-child relationships or working directories, things like that. We've got a simple wrapper over sklearn clustering, so you can use k-means or dbscan is the other supported one. So just some simple, try to keep it very high level, but some simple ways to try to take some data science methods, make them available to a threat hunter in a high level language so that they don't have to necessarily be programmers or data scientists, but have those tools at their hand.
Cool. Well, thank you very much, Paul. That was fascinating stuff. Every time I see Kestrel, I'm thinking, wow, man, this is amazing stuff. And I'm thinking, yeah, not just, it's flattering that you kind of would like to make Mystic Pi as a kind of like a, as a kind of external analyzer. I was also thinking the other way around. It would be kind of nice to have a kind of a data provider wrapper for Kestrel in Mystic Pi so that you could do the querying, because we have like an entity model, but the Kestrel one is like infinitely, well, not infinite, people throw that word around, but massively more richer than the Mystic Pi one. I think there's, given enough time, I think there's a lot of things that we could do to bring them both together, because it's just great stuff.
Yeah, definitely. And there was some talk in the Discord earlier about, a generalized query language, and that's kind of how StickShifter uses Stix patterning, and Kestrel builds on top of that. So in a way, this is sort of your generalized query language, because I can run the same query against QRadar, Splunk, Elastic, Carbon Black, CrowdStrike, yada, yada, whatever, and get the data back in the same exact format. So now I no longer need to be concerned with the specific data source I'm querying. I can just focus on what I want to hunt using this Stix data model. And I'm one step removed from that data source.
Yeah, very cool. I'm also very jealous of your, I wrote a kind of simple PowerShell deobfuscator, which is kind of nowhere near as pretty as yours. So I'm kind of jealous of that as well.
Well, that was a fun one. The PowerShell deobfuscator was a hack day project. That was me and one intern, Stephen White, and we threw it together in roughly 4 to 5 hours. And I've done some improvements since then, but that's where it came from.
Nice, very cool, very cool.
Hey, so I have a couple of questions, I guess. Well, first, thank you very much, Paul, for doing this. I think that similar to Ian's comment, every time this is the second time that I've heard about Kestrel. The first time was, I believe, in the Science 300 Summit, I think it was, that you guys presented about this.
Yeah.
I think it was like a year ago or 2 years ago, maybe.
Mm-hmm.
It's pretty also last year.
I think it was last year, right?
Yeah, and we presented at Black Hat a couple of times too.
Nice. So yeah, thank you for that. So the first thing, I guess, so one of the things, so from the community perspective, right, when it comes to a project that would help security analysts to build detection logic without thinking on, for example, like, oh, I need to learn this specific language because this SIM has that language, etc. Right? There's multiple SIMs, right, that have their own way to do things. So, Sigma, right, the Sigma project came out to do some of that at the YAML, kind of like level, right, trying to use a YAML with now some language included into that. But then, of course, it's not as extensive, right? Like, you cannot extend it to do some complex logic, right? So when it comes to this, for example, what you're showing right now, would the idea in the future, or is that something that you guys are thinking also, that you will be able to write logic like this and share it as a rule?
Yeah, that's definitely one of the goals. Once you can obviously do it interactively, that's why we're using Jupyter, right? But once you've written a hunt and you're satisfied with it, you could pare it down to just the necessary parts, and then that now almost becomes a detection rule, right? Maybe it's if a certain variable at the end of the hunt has something in it, isn't empty, then you've detected whatever you want to detect, and you can alert based on that. So the question is, do we make that part of the Kestrel syntax itself, or is there a layer on top that maybe does that alerting? And right now that's an open question. I could see it working either way, but that's definitely one of the goals. Be able to write these things, share them, schedule them, have them run on a schedule, and create alerts when necessary.
Yeah, that would be interesting to see, right, how the community, right, takes some of these, projects that, to me, at the end of the day, like, for example, a lot of projects do have the goal to, like, to empower the security analysts in general to build these things, not think too much about 20 different products to do something. So I think that it would be nice to see what the reaction is of the community, right? Because I think that for a long time, I guess that has been one of the obstacles that I've seen from people to use some of this logic.
Mhm.
And I've always been a big supporter of, so for example, I'm a big supporter of Sigma rules because I believe that they do provide value to the whole community, right? It's definitely a great project, right? But at the same time, when I share my logic through projects like the 300 playbook, I've been since 2018, I think it's been, 2018, 17. I've been trying to use Spark SQL or Pandas SQL because it's easier to get to those kind of complex use cases, in my opinion. And I think that Kestrel is kind of getting into not only SQL, but you're adding even more functionality on the top of that basic way to describe your logic, where you're adding transformers on the top. So you're like adding this like big framework that allows a security analyst to not only just define the logic, but maybe also enrich what it is that they're trying to explore, right? So I
Right.
kind of like that it's a more complete approach. So yeah, it's pretty interesting to see the idea behind it. So super excited to what's next for Kestrel.
Yeah. So we actually internally, when we're pulling the data from your SIM or whatever through Stick Shifter, converting it to sticks, we are then putting it into a SQL database. So we're actually operating on top of SQL, and some of these operations just get turned into by the kernel into a SQL statement,
right?
And that's pulling our data back out. So you could actually even integrate with tools that expect SQL, right? This is there's a SQLite database on disk here backing up this notebook. So I could run like Apache Superset if I wanted to do better visualizations or whatever uses SQL. That's another way that you could potentially integrate.
Yep. Awesome, man. The other thing that I had, so I'm actually checking also the questions in the chat, but I think that there are more comments. So Cybermonk Mehmet, he says detection notebooks with paper mill, maybe. I think he was referring to doing some of the automation piece, I guess, with Kestrel. Yeah.
Yeah, paper mill is one that I've heard so that's an option.
Yeah.
We did at Black Hat Arsenal, we did a demo with integrating with OpenC2. So if you had an OpenC2 orchestrator that had something you wanted to investigate, you could send that over to an actuator that would run a pre-written templated hunt written in Kestrel, and it would take the input and then run it and give you that output back. So yeah, there's a lot of possibilities, just not enough time to explore them all.
Yeah, definitely. The other thing that I had was, if there is no other questions in the channel, I'm seeing right now, but one question that I had was so when we talk about sticks, right, and then the observable objects, based on so I've been following sticks and observable objects for at least 4 years, I would say 4 to 5 years. Like at least 4 years is when I started like looking into, and to me it seems that it doesn't go beyond the process, file, like IP address, URL, right? But when we want to describe a lot of other things that occur, so for example, I'm working on building a basic ontology to maybe extend some of those concepts. So how are you guys planning in the future to say, what if we want to describe more than what sticks currently have? And then sticks starts getting into the, you need to create a custom sticks object, and then it becomes like a little
That's what we've done. So we had the need for things that weren't defined in sticks, but sticks does support extensions. So we've got like, for example, one of our teams did this XOCA event because there's some key event data that's missing from like a sticks observed data SDO, and this kind of restores that. So that's the current approach we've got. So Kestrel is a project of the Open Cybersecurity Alliance, as is Stick Shifter. So we've got they're custom extensions, but we consider them to be conventions that Stick Shifter connectors could use so that it's still normalized and we
Right.
still have that normalization to sticks, but we're covering the things that are missing from the actual stick standards. So convention, really.
Got it.
Until these things make their way into sticks themselves, if that ever,
if they ever get to that. Yes, definitely would love to continue the conversation. As I mentioned, I'm kind of working on trying to define a way to describe adversary tradecraft that would translate to detection logic. But I'm not trying to build that how to do the detection logic, like how to describe the logic. I'm not focusing on that. I think the tools like Kestrel are the ones that are definitely would solve that problem, right? I'm trying to be able to simply describe like actions, operations taken by adversaries or threat actors, and how those connect to certain artifacts. Like just trying to create how you describe the security domain, right, where we operate. And I think that when I was looking at all these projects, like they're missing so many different things that to me it's like, do I just build, let's say, like 80% of this with extensions, or do I just build the ontology from scratch and then figure out how we can start maybe aligning it so that people can also build their own sticks and extensions? But that's something that we can talk. That's beyond notebooks. That's something that I would love to continue the conversation for.
Yeah, definitely an interesting topic.
Yeah. Cool. Thank you, man. Thank you, Paul. Thank you for the time, and I appreciate you taking the time to do all this and sharing it with the community, man. Appreciate it.
Thanks for having me.
Yeah, that was awesome. Thank you.
All right. Cool. Well, I think that I guess there is no more questions in the chat, and so from my part, Ian, if you want to say some last words for today, but it's been amazing. I mean, sometimes when we think about the Jupyterthon and what's gonna be this year, I start kind of going back and watch the presentations, and sometimes I'm like, what else can we talk about, right? And then when I see all the proposals and now the Jupyter notebooks, it's amazing to see new things like all the time, right? And new faces, so like new speakers. It's been great. So so I don't know what you think, Ian.
Yeah, kind of a bit overwhelming just for one day. I mean, just like so many, like kind of like scribbling down some stuff for a to-do list. I kind of like think, oh, I'd like to do that. I'd like to do that. Integrate this, and like I think I've got like a to-do list that spans like at least a couple of years, as if we didn't already have one. So yeah, so a lot of really fascinating stuff.
Yeah. So Ashwin, you want to say a couple of things about today? What do you think about? I mean, it's called a Jupyterthon for a reason, I guess, and it's crazy when we think about the first Jupyterthon was one day, and remember how it went like hours and hours, and I was like, oh man, like this is getting very tiring, right? so I'm glad that we decided to move to the 2 days kind of like format. Ashwin.
I think it's I think we definitely see like a lot of maturity in every version. I think workshops were like a little bit exhaustive last time, but I think it was helpful for community. So that was great. Probably something tomorrow speaker panel we can probably discuss like how we can, or like what community is looking for to increase the adoption of Jupyter notebooks, or like probably discoverability of existing notebooks, or because it's scattered in a lot of places, and there's not like a structured way to go around.
Awesome, man. Joyce, any comments? This is your first Jupyterthon, right, Joyce? And I'm happy to see you joining us, staying for a long time with us, and I'm glad to
see you. We can actually see you.
Joyce, so what do you think?
It's great. I'm very new to Jupyter, so it was cool to hear everybody's talk, and I feel like I learned a lot, and I feel like there's just so much in my brain right now. I'm gonna have like a great sleep tonight and just like be processing all of this.
Oh my God!
Yeah, it was really great to hear everybody's talk.
Awesome. I mean, Ian thinks about, I guess, Jupyter notebooks and Python. I mean, you have a Jupyter notebook channel also internally, right? And we can you're constantly sharing things in there as well. So you're living in the Jupyter Notebooks thing. So
Yeah,
and even for Ian, like even today was like a lot.
Yeah. I know, I'm exhausted. I mean, like, I'm kind of glad we didn't have to do workshops though, because that was very tiring last year. But
yes,
yeah, this feels like it's just like a massive amount of knowledge to absorb.
Yeah. So in that aspect, so if we think about for those that are staying right now, and of course this is gonna stay in the YouTube live stream. So if we go to the agenda, the site real quick. So what we are referring for those that are new. So last year we did workshops. So if you go to the agenda at the bottom, we are still technically are exposing that workshop because I think it was super important to go through the basics of Jupyter Notebooks and all the stuff. So this was hard work by everyone that, most of the people that organized also 2022, and those are super useful. So if you want to kind of walk through the workshops that were done last year, you can watch the live stream from last year, and you can find that by going to the main page of the agenda. And if you scroll all the way down, you can see like the previous edition, day 1 and day 2. And day 1, I believe, well, both days, we did a workshop to kind of like kick off the day and get some like understanding of Jupyter Notebooks. So we decided not to do that this year because the content is already created. The live stream is already there, safe, so you can do it on demand, right? Just whenever you want to dive into those topics. So yeah, that was definitely a good but packed 2021 like content workshops and everything. So this year it is still great content, but of course less stress for the organizers to do a workshop as well. All right, so for tomorrow we do have, once again, we start the day at 10:30 a.m. Eastern time, and we have a lot of great talks, a great keynote by Thomas. So bookmark it for tomorrow as well. We're gonna be also tomorrow at the same time. I'm staying the whole day as well to the whole conference, and bring all the questions that you have. If you are watching this after this is actually done, like because I know a lot of people are not even awake right now in other parts of the country, so they might probably watch it later. So you can bring your questions tomorrow. We do have threads open for each talk in the Discord server, so you can actually even go back and see what others were asking, etc. We're gonna keep the Discord open, of course, until next year, and every other year there is always gonna be a Jupyterthon, so you can see even what was done last year. Any final thoughts before we finish and we stop the live stream? I guess, Ian, anyone?
I think I've run out of thoughts.
All right, cool. All right, well, thank you all. Thank you very much for staying with us, and I'll see you all tomorrow, 10:30 a.m. Saturday.
Yeah, look forward to it.
Thank you very much.
Bye.
See ya.